boom. There you go.
Is that your full screen?
I think so, yeah.
Great.
Yeah.
Awesome. All right, so...
Here, let me just test one thing, which is I usually use
Are you sharing any audio?
No, I'm not going to share any audio.
Perfect.
But I usually do, let me just...
Are you going to need power or you're good?
Let me show you how to turn on the mic.
Okay, yeah. Morning, folks. And I assume everyone in the back, we're good. So yeah, welcome everybody to the kickoff of Graph the Planet 2026. This is our 5th year doing it. So yeah, thank you for coming so early in the morning, and for the folks who are tuning in online for, I don't know what time zone it is, maybe staying up really late at night. So welcome. And also want to say thank you to actually, yeah, I want to share a few notes here. So first of all, hi, I'm Leo, founder of Graphistry, and so helping organize this for the last few years. This is our 5th year. You notice there's a little gap where we kind of got knocked off by COVID, but it's cool to be back. Basically, we started around the same time we started AI Village at Black Hat, and this is sort of the almost like a twin over RSA that we do every year. Online, we're trying to enable more folks to attend who can't actually fly out all the way here, so we are doing online, just for all the people who are here. It might be a little confusing. Likewise, for the folks online, I'll share some instructions. We kind of interesting this year, I think the whole AI thing got a little more popular, so we were actually 2x oversubscribed, and so I'm expecting later in the day to be pretty packed. Sorry, you're not presenting. Oh, can you set it up? Oh. I guess for folks online, you're not actually seeing anything, so we're gonna, yeah, let's get that set up.
Somebody else is sharing.
No, the browser.
Can you stop me, or shall I stop?
I think you have to stop sharing, or maybe I can.
Okay, all right.
Yeah, sorry.
Yeah, I can keep going meanwhile. Yeah, I did want to share a little bit about who, both in person and online, who we're generally seeing at the event. So it's a nice mix of basically makers and doers. And so generally, for the in-person, it's generally a little more senior. Online, we have like the full gamut. So you'll traditionally will get a lot of, for example, on the operational side, CISOs, we'll get directors of engineering, we'll get SOC leads, we'll get threat hunters, so generally a little more operation, a lot of security engineers actually this year. I think it's for obvious reasons. And then on the, let's see if I can do this. For some reason, my clicker is not working. And on the, kind of on the maker side, let's see if this works. There we go. On the maker side, we'll get a lot of interesting folks here. All the way, we have a bunch of, we'll have a few professors floating around, chief data scientists, founders, VP products, research scientists, and the like. So I don't know. I encourage you to meet who else is here. If you're here, you're probably kind of interesting, and then so is probably your neighbor. So say hello. Also, I want to highlight you know, year after year, it's not the easiest thing to do these things. And so I want to say thank you to our sponsors. So for example, Bloomberg for helping host this year after year. OnChain, many years has helped us as well. I think you'll be seeing Victor later in the day and his team. And then new this year, we also have Deep Tempo helping out. And we'll have some of the side sessions with those folks. I also want to, I don't know if who here is in a startup. So we have half the hands are in startups, and that's kind of representative of like, and especially, I think especially with what's going on in AI, that makes a lot of sense. And what I want to point out for past years, even though it's a small group, the weight class is very heavy. So I think $100 or $200 million raised from just the last 1 or 2. And I'm actually, I don't think I'm including Corelight because they would have just been, I think, $150 million on their own. So I'm not sure if they count as a startup anymore. Okay, and then, and especially for folks online, this is a kind of an event where, honestly, I get to invite people to give talks where instead of me having to like, you know, hunt down all these fun talks, and this way they can kind of come to us and get them all together. But it's kind of sad to only do it 1 day a year. And so with Sunderea in the back, we've started to do a series of sessions with interesting folks. You'll recognize at least two of the first sessions that we've done online with actually speakers from the event. And so we've just been doing a lot of, for folks doing data intensive investigations, we're doing kind of an interesting kind of interview series just to understand how different folks across the industry do what they do. So I encourage you to I don't honestly understand how exactly this works, but something with YouTube or LinkedIn, and I'm supposed to say click and subscribe. So click and subscribe. So yeah, these have been a lot of fun, actually. I've been learning a lot. So it's going to be a really dynamic day. And so honestly, by the end of it, it's kind of exhausting. And so, pace yourselves, take a break, and, talks are intense, just go hang out. Same thing with online, just go chat with people. So I want to take you through a quick tour. So I'm going to stop talking very soon, and then we're going to have our keynote speaker. We'll have some interesting talks. I want to point out for the folks here and physically during the first break, we're actually going to have a side room where one of the startups is going to be doing some cool demos. They're kind of doing an interesting take on basically their own foundation models, but a little more security oriented, and a little closer to like encoder only, I think. And then lunch, likewise, we're going to do a tutorial here. So we'll do it in person, but we'll also do online. And so if you're doing the online, switch over from YouTube to Slack. And I'll have a bit more info on that. We're also going to do something, we try to change a couple of things every year just as we improve the process. So this year we're also going to try to do kind of breakout discussions. I think with anybody trying to deal with AI deployment right now, that's a lot of discussion. So that'll be interesting. And we'll kind of all come back together. And then another break. One more thing I wanted to point out, because we have a very mixed audience. Some people here are pure AI. Some people here are like here just for the graphs. Some people are here for both. And so I did annotate on the right a few of the sessions. I guess on the bottom might be a little hard to see, but basically starting around lunch, we'll have interspersed graph sessions. So just to help you a little bit. And some of the graph sessions are actually graph and AI. So. Okay, for online folks, we're experimenting with how to participate. So during the normal talks, just chat in the YouTube. For more interactive sessions, I think there should be a Slack link that I have available, and that might be posted in the channel. Whoops. And yeah, we'll also be doing the breakouts with folks online too. And so we'll see how that goes. And finally, for folks who want to do the GPU and graph tutorial stuff, there's a little of information here. Totally optional. You could also just watch, get a free account in Graphistry Hub, and then jump over to the Slack as well, and then you'll get to do the tutorials. And yeah, okay. So with that, I actually want to introduce our keynote speaker. So Justin McCarthy is actually, I guess, I don't know if this counts, like a graduate of the Bloomberg portfolio. So Bloomberg is one of our sponsors. So I think congratulations for 10 days ago, you just closed on the exit of Strong DM. So,
I think I need sharing privileges.
Okay, yeah, let's switch you over. Okay, sure, good. Yeah, and so I want to maybe, while Justin sets up, share why we thought to invite Justin as the keynote. So most of today is going to be about how to make AI safe, or how to use AI to make things safer. Justin, maybe, I don't know if you'll agree with this, I think he's on the opposite end of the spectrum, which is he's trying to figure out how fast can we go with AI, even if we break a few things along the way. Maybe try to minimize that a little, but he's more on the, it's an interesting experiment of just how fast could a team go.
Supposedly I am sharing, so I don't know if there's any other.
Okay, but we're seeing on the screen is the wrong one.
Oh, that's right.
This one? Would you enjoy your mic?
All right. Thank you, folks. So thank you, Leo, for the introduction. And the one thing I'll say, just a tiny bit of background here, is we are a cybersecurity company at StrongDM. So it's true that we're actually thinking about how do we go as fast as possible. But in cybersecurity, correctness is not optional. So this is actually an area where we really have been asking how fast can we go, but always the consequences are very, very clear. And so with that in mind, everything that I'm about to present, you should think of it as existing within a cybersecurity company, within a team of engineers and product managers and sales folks and that actually care a lot about getting it right, okay? All right, so this is the story of the StrongDM software factory. So this actually begins, if we can advance here. All right. So this begins on Twitter, which is where all AI news still takes place. And the way I expressed this, I think this was way back in May of 25, is really a process that I went through personally after the initial sort of world tilted on its axis with the launch of ChatGPT. Essentially, this world of possibility unfurled in all of our minds, right? Like what could become of this new power? Almost immediately after the availability of the API, however, I and many others experienced the harsh reality that our imaginings were not manifest in the capability of the model at that moment. Okay, so that brings us up to essentially the spring of 23 here, okay? So, and the way I phrased it was, gosh, the models were not ready for multi-step agentic flows. Okay, and the way you would experience that was essentially compounding of error. Okay, so this is something that if you tried back then, or if you try with a dumber model, the list files in the directory, attempt to edit the file, all the normal things that you would expect if you were, for example, going to try to really prosecute any task, but specifically coding, engineering, any kind of cybersecurity task, that sequence was just going to degrade, and we all know the reasons for that. Okay, and then personally. I was left in that state until October of 24. So October of 24, Anthropic released a subtle revision to 3.5, and it just turned out that revision, for my purposes, caused really everything to go from never working to sometimes working. Okay, and the difference between never and sometimes turned out to be huge. Okay, so that captivated all of my attention, and as you can see here, like I've had a difficulty containing the top of my brain since then. Okay, and obviously that goes on until this day. Okay, because what we've seen since is we've seen a series of models that are getting better and better and better at following instructions, calling tools reliably. Obviously, context is expanding. Obviously, the price is coming down. Obviously, the latency is coming down. Right. So in every dimension that I care about in the application of these models, it's getting more, better, faster, more capable all the time. Okay, so with that initial condition, essentially, what's possible? Okay, and what we're going to talk about here is a few of the implications that I've experienced over the last 9 months or so, and what that might mean for the rest of us and the rest of all of us. Okay, so just one more journey back in time. This is what it looks like for a CTO as salesperson. This is what a CTO as sales looks like in the year 2024. You know, the poor guy committing some stuff, but not a lot of stuff. 666 commits, that's still pretty good if your job is primarily sales. A year later, without really thinking about it, that number here went up by a factor of 10. So there's an order of magnitude increase in activity. And this is like subconscious. This is without me noticing, right? And this is all in the era really before the current moment of realizing that throughput has spiked. So throughput was spiking for me personally, even though I wasn't aware of it. And then obviously in this year, now that the zeitgeist, now that everybody realizes stuff is working, I would say the trend continues. So I've clocked more than a third of my contributions last year already in the first month of this year, essentially, right? And this actually, a huge part of this began back in July in Menlo Park when the three of us unboxed some new laptops and really carved out a dedicated AI team, okay? So that dedicated AI team, on the first day that we got together, we wrote a bunch of use cases and missions and so forth, but among these, there was actually the most important one turned out to be, really in the first hour of that first day, we wrote this on the wall. And so we were committing, in July of this year, we were committing to not write a line of code, okay? I think there are many folks right now that, again, the zeitgeist would agree that it may be possible to not write a line of code. That was not where the average sentiment was in July, okay? So in some ways, we had a little bit of a preview of the future by committing to this early, okay? And if you had quizzed me on that day, like what are some of the implications of writing this down, I wouldn't have been able to unfurl some of those implications immediately and explain it. I can now, and actually the first thing that we realized almost immediately after committing to this was if you didn't write it, there's just no way to review it without becoming the bottleneck. Okay? So you can absolutely have an higher throughput, but you can't if you review the code. Okay? And that's why almost immediately we expanded the principle of not writing code to not reading code. Okay? And it became very, very important to us, religiously important, to not review the code and not read the code. Okay? And when you combine these two, but you still absolutely have to achieve correctness, you have to achieve happy, satisfied customers. It turns out you can get all of these properties, but you need to invert, re-architect, refigure all sorts of expectations about how you would achieve that. And really, that's sort of the rest of the ideas that I'm going to share with you today. Okay. Part of this, I will say, comes through this repeated pattern in us tool users, right? I guess chimpanzees a little bit use tools, and otters kind of use tools, but we can agree that we're like the main tool users, right? So, or we were. But we have a history of building tools for understanding, okay? There's a complex problem, there's a subtle problem, there's a problem that's microscopic or macroscopic, and we can't see it and perceive it with our normal eyes and ears and touch. We need to build tools. This is a moment where building tools to help us see what's happening in the AI is a recurring theme, and we're gonna call back to this a few times. I will say though that the name of this talk is Software Factory. Like maybe it should be a software garden. I'm not sure, but I think software factory, for better or worse, is just the term of art that's sort of been established at this point. But really, every piece that you're making inside of a software factory, it really does begin with this thing that we variously call seed or an intent. It is really just a beginning of an expression of something that you want. And historically, if you go out there in the city and you find someone and their job title on their badge says product manager, that product manager, you might be able to interview them about what a PRD is, like this, this acronym that they're familiar with. So you might be able to engage in a little discussion on a PRD, and you'd hear various descriptions of it. And I think all of us are familiar with, maybe what one might look like. You definitely don't need those anymore. You don't need a whole bunch of Figma anymore. You just definitely don't need any of that. You need just a sentence or a sketch or a napkin, a little napkin sketch, or just really a blurt of any utterance. Because what you're doing with the seed is you're just setting forth in some direction, okay? And you're initiating the process, okay? You're initiating the process of encoding your intent and your desire into some small piece that is subsequently going to be nurtured and germinated and ultimately amplified by the rest of the factory process, okay? So we start with a seed, and then we inflate that seed into a series of, in this case, it doesn't really matter, but call it tranches of intent, okay? Because the models live in a world of tokens that we all created. Once upon a time, we created these things called sprints in various software methodologies. So you could totally just use sprints and the models kind of get what you're talking about. You could call it tranche, you could call it slice, you could call it piece, you could call it bucket, just call it sprints. It's fine, it doesn't really matter. None of this matters, just anything that prevents you from biting off too much to chew in one tranche, okay? Because you can't, ultimately in a commercial environment, what we want to do is we want to write at the top of the whiteboard, make more money, and then actually not decompose the problem any further and then walk away. The models aren't ready for that. So we actually have to do a little bit of problem decomposition, one step down, and then maybe 3 steps down, okay? That's kind of where the models are at right now. As capability grows, we'll have to delete levels of that intent tree, and then we really will be able to leave make more money or cure a disease at the top of the whiteboard, and hopefully then we can walk away, all right? But for now, we have to decompose the problem into a series of tranches and have it pursue the goal. Something that many folks will realize if you've spent a lot of time generating the code is that the models are very good at claiming that they've accomplished the task, very good at claiming that they have met your intent, okay? I weight all of those claims at 0, okay? I simply don't look at them, okay? There's nothing that a model can tell me that I ever believe, okay? Really the only thing you can believe, and in fact, really this becomes the locus of all of our creativity and action and energy, is in that word there. It's validation. Okay? You only have what you can validate. And in fact, it's such an extreme form of this right now that I don't know how many, anyone done injection molding before? Okay, if you do injection molding without a mold, you just spew molten plastic everywhere, okay? And then you will have like a pile of molten plastic, okay? That's the cogeneration. Like it will just be a pile of molten plastic, okay? But if you put a mold in there and then you inject into the mold, then all of a sudden you have this plastic enclosure, okay? So the mold that you're injecting into is the validation, and it really becomes the piece, right? If you have the mold for something, you can make a million of them. And that is a different way of thinking for software. If you have the test suite, the validation suite, well, the implementation is implied. If you want it in Rust, if you want it in TypeScript, if you want it in, it doesn't really matter. Anything is possible and can fill into that mold. Okay, it's actually the mold that becomes, again, your locus of your energy, your attention, all of your focus. This also has the convenient property of when people begin unfurling the long series of whatabouts, this is what you point to. So just complete the sentence. What about, sorry, your name is? Dustin. Okay, Dustin, what about?
X, what about this? What about the test suites? What about the customer stories? What about the site?
Yeah, okay. So all of these whatabouts. What about security? What about performance? What about durability? All of this stuff. So you just put all the whatabouts into here. And we actually have a project internally that's called What About, and then some name of a piece that we work on. You just put them all in here. And then the reports, you just print them out. Okay? What about the stresses and loads and wind loads on the bridge? Well, you print out the stresses and loads and wind loads on the bridge. You print out the report. Okay? And it becomes the same. Okay? So validation is where you put all your energy. Generation, I don't know, that happens overnight. Who cares? One example from our world of booting up this validation process. So at the beginning, we were working on a piece where we actually had an agentic process. So this agentic process, we wanted it to exist in email, we wanted it to exist in Slack and Teams, we wanted it to exist over text messages. And again, we're a cybersecurity company specifically focused on identity and access management. And so this sequence on the left here, you could imagine a user, giving some utterance, a request. You could imagine an agent responding. You could imagine this happening again over email or Slack or text messages or whatever, okay? But we wanted this to exist, and we actually didn't have examples of this to validate against, okay? So we needed to bootstrap the validation process with some synthetic imagined examples. It turns out that all of us in this room are extremely good at judging whether this seems plausible or good or bad or redundant or incorrect or has a logical sequence in it. So for example, if the agent said, on it, I need email and manager, and then the user responded, Jaylin, and then the next response from the agent was, on it, need email and manager, we would all be able to look at that and say, gosh, that was redundant. You already had the answer to that. Why'd you ask that question? That's dumb, right? So we can all do that. The moment we can do something, we shouldn't do it anymore, because the models can do it too. and so this process of bootstrapping synthetic data with maybe a little bit of style curation, like maybe we put in a few tweaks on how we would rather hear you say it. I don't like the use of emojis. I do like the use of emojis. Once you set in those positive and negative examples, the models can then come in behind you and amplify that and permute that over all possible scenarios, over all possible configurations of some world state. Okay? And then you can sample from that corpus and begin validating your system against it. Okay? Now, this itself models an agentic process, right? We all know that these things are, stochastic, non-deterministic, however you want to say it. They're going to pursue multiple trajectories over time. So it won't be the case that you can end your CI/CD process and end your test suite and say it is Boolean correct. But what you can do, as every other engineering discipline has done, is you can sample and you can put error bars around it, okay? And so you can say, you know what, we've tried these trajectories, we tried 100,000 of them, all but one seemed plausible and good and correct, ship it, right? And you can set your shipping tolerances. It's just you have to acknowledge that, like, you were acknowledge that previously you were imagining that your test process was Boolean. In fact, there were error bars you couldn't see. Just reveal the error bars, accept it, and resume shipping. Okay? Once you have a corpus that you're validating against, we should not work ourselves to the bone to continue to curate that corpus, okay? We should instead utilize the system itself to begin amplifying that corpus, okay? So what that means is, again, considering the example of an agent, every time someone interacts with the agent, you can implicitly bucket that interaction into examples of a good interaction or examples of a bad interaction. And for the gray area, for the ones that are truly undecidable by, let's say, some automated process, you put those in a pile and you have the human in the loop decide. But those will become a diminishing fraction of all activity over time, right? So you can have a validation corpus that is of increasing detail, of increasing volume, for essentially a very low cost, because whatever the use and utility of your system, as long as it's recording those trajectories, it's essentially accumulating along that trajectory of what you want, okay? So this becomes obviously an important step, and it's the step that allows you to scale. It allows you to scale validation, right? So even though validation is where all of our creative energy goes, even though it's the hard part from an engineering and creativity perspective, it's a hard but tractable part, because we're amplifying the validation itself with the models. And I'm sure there's some information theoretic or philosophical snake tail eating question of the validity of this. And I don't know, I would just say try it for yourself. And the sort of empirical approach that we've taken to this is that sure seems to work, and sure seems to be hard to find examples where I can point at something obvious and the model isn't always also pointing at the exact same obvious thing, for both good and bad examples. Here's an example of a bug report. So this bug report is actually not a functionality bug. This is more of a, I'm annoyed by things being slow and costly bug, okay? So I'm annoyed that the agent was over-engineered simple operations by unnecessarily invoking planning system for straightforward preference management tasks. Okay, so you could imagine this bug report existing in any bug database. You can imagine an engineer or someone in QA or a product manager noticing this inadequacy, right? So there's something here, I didn't love it, you know, it was successful, but it was just inefficient. You know what we should do? Let's have a meeting about this. We should have a meeting about, we should skip planning for single tool operations like preference updates, and you know, we should just read that user context directly for preference retrievals instead of creating plans, okay? So this all parses for us. Like everyone in this room can read this and say, like, that's plausibly a JIRA ticket 1, 2, 3, 4, right? In a closed loop system, this is no longer JIRA ticket 1, 2, 3, 4. This is a transient finding that your model is observing from the trajectories of your system, and then it's remediating, right? So no human wrote this bug report, and no human responded to this bug report. The models wrote it and responded to it and fixed it. And this is like just a real example from our real software factory, right? So if this stuff is closed loop and we don't actually have to look at it, what's our job? Our job is to really just find, I mean, we use the judicial example a lot. We're just trying to be the Supreme Court and make sure that there are cases that are undecidable that are kicked up to us. But if you think of all cases like this versus the fraction that are really tricky, that are design tricky, it's just a tiny piece. It's just a tiny piece of the total volume. Okay? And that's hopeful because, yeah, there's all this stuff just cures itself. Okay. And then really, there's so many repeated patterns in here, but I would say the one that comes back again and again is for every what about, for every undecidable, we really have to, yes. Do you have, what is that, 5 minutes? Is that a 5? This is the 5-minute warning. For every undecidable, the cure is to find a way to apply more tokens. Okay? So applying more tokens has to come from a whole set of diverse places, but they're out there. You can create simulations, capture a bunch of screenshots, Do win-loss reports. What else do I have? Have you fed all your email in? Send a survey to a customer. There are analysts out there that analyze everything. If you have competitors, they have earning calls. Be adversarial. Read every job description. Follow people's eyes. Record all the voice conversation. Give everybody a bunch of fake prices and have them accept your proposition. Right? Have you considered satellite imagery? And then just one more sort of vignette on words of encouragement for folks. We've done this before. We think it's totally normal to see transients at a billionth of a second. It's totally normal. It's just on the test bench. It's your scope. I don't know what brand of scope you all have at home, but do I have this? No, I have a different brand. But anyway, scopes, they allow you to see things that are totally superhuman in terms of time. That's normal. They don't need to cut you open anymore to see inside your body. We use a 3 Tesla magnet to see some of this stuff, and we orient all the water molecules in your body, and that's just normal. You remember when we did that? And it's normal. It's a helium-cooled superconductor, and it's normal. Cars see with lasers, they don't need to touch the tree to know that it's there. It's laser. Cars have laser eyes. This is all normal for us now. Okay, so like we can probably like write some test suites, right? Okay. The most elaborate example of this for us is called the digital twin universe. In the digital twin universe, you can read about this online. We cloned all of our integrating peer SaaS applications that we needed to prove 10,000 times an hour. It turns out Salesforce won't let you start up 100,000 customer tenants overnight just because you want to or you ask nice. Same thing with Google Drive. They won't let you create and destroy tenants and objects and users at the rate we want to. So we copied all of this. Copied sheets, no problem. You could just have this now. And the digital twin universe of all those SaaS, we always wanted it. It was simply uneconomical previously. Okay? That bit has flipped. It's different now. Okay? You can have what you want now. And really, for those EEs out there, it's just this. And it's true that making sure your feedback leg is actually connected in your software and you're not diluted about that, that's hard. But once it's connected, this circuit will stabilize. Okay. How many more minutes? 3 minutes. For those of you that enjoy stable temperatures, you'll also recognize the calculus inside of a PID controller. Okay? All that thing is doing is it's trying to turn a square wave into a nice, consistent temperature. Okay? So really the feeling of these systems is they can overshoot, they can undershoot if you get the specification wrong. But through compounding all of these techniques, ultimately you are going to find a way to converge these systems to a definition and a behavior that you want. Okay, our thermostats turn square wave furnaces and air conditioners into a nice consistent temperature, and they do it through a process. Oh, I don't have demos. Hold up. How did I get the deck wrong? Okay. I think we're going to run out of time, but so I'm going to skip this. All right. I have a few more slides that we're not going to talk about. No, hold on. No, I actually do need to switch slides. One sec. Yeah, let's hear it. While I'm happy to take questions while I recover the important slide.
Testing. So I'll do one on behalf of the internet. Actually, I'm on my behalf, so first, thank you. But on behalf of the internet, how do your colleagues in like legal, risk, finance, all those things react to shipping things in this way?
Yeah, so I think that's a really great question. Yeah, because the risk is obviously super huge, and so I think every one of us has colleagues that are involved in managing risk, and so the risk of inaction and allowing your competitors to proceed ahead of you in the market is huge.
what are you finding that's still hard?
Okay, so the part that's still hard, I would say, is getting the right tokens. So the tokens are out there. A lot of them are hidden, latent variables inside of biological neural networks that are in the form of your customers. It could be in your customer's culture, but a lot of times it's in the sort of sum of some subset of your customer's brains. And you have to go to lunch with them, and you have to build trust. And you have to build trust and say, what if I sold you this pen? Would you buy it if it were red? Would you buy it if it were blue? Would you buy it for $1? Would you buy it for $100? Would you buy it for $1,000? That process is still extremely manual. Getting those tokens takes a lot of effort. There's actually skill. There's EQ involved. All that stuff. Those are really expensive tokens.
Great. Well, thank you, Justin. I think we should probably.
All right. So let me just skip ahead to the. All right. Anyway, all this is true. All right. There you go. Go apply more tokens.
Great. Excellent. And actually, can you stop the screen share?
Yes.
I work really closely with our policy side of the house, which is led by Natasha Crampton, who's my amazing peer in all of this, but I represent how we actually put this into practice in engineering. So with that, I don't really need to say any of this after the last talk. I think everybody is seeing it. The potential of Agentic AI is huge, not just in us all having assistants or things that help us, but totally changing how we build software. And the reason I bring this up is this is an enormous change function on how we work, on society, and there's a lot we have to do to get to a place where the world is ready to adopt this. Now, there's this great report that was put out by the University of Melbourne and KPMG, and they were either very lucky or very smart because they started doing this pre-ChatGPT, so they amazingly have data about how people are feeling about AI. And unfortunately, what we're finding is all of the metrics are going in the wrong direction. They trust it less. They're more worried about it. They're less willing to rely on it, which feels, and this is across about 50,000 people across 47 countries. So this is a pretty wide sample of people, and that's very much at odds with the presentation Justin just gave us. We're saying we're going to bet whole hog on this thing, right? And so this is a problem. We have to figure out how to close this gap so that we can really get the benefit of the technology, because people aren't going to want to use it. They're not going to want to use systems built on it. There's a serious risk of a backlash here if we don't figure out how to get this right. So what are the AI risks? There's a million different taxonomies. All of them are valid in different ways. But I like to think of it, and there's probably a black on black label of this coming from the International Safety Report last year. But anyway, this I think is kind of a good way to think about it. There's malfunctions, okay? Your AI agent gets confused and goes off task. Then there can be misuses of AI, and either that could be like prompt injection attacks and taking it over, or using it for things that we see as illegal or problematic. And then there's the question of systemic risk, which are the change function I was just talking about. What if all of these agents put all of the software engineers out of work? What do we do with that as a society, right? And so all of these are important to think about when we think about what to do about managing AI risk and preparing the world for this technology. Microsoft has investments across all of these in collaboration with many, many others. No single company can do this alone. But for the rest of the talk, I'm going to just focus on the malfunctions and the misuses, because this is something as technology builders we can actually do something about and put the situation in a better posture. So I'm going to talk a little bit about Microsoft's approach and kind of show you some tech here. Again, all the taxonomies, all the frameworks have different things to like about them. The way Microsoft does it is really similar to the NIST framework, and so I'm going to kind of walk through the pieces and give you some real examples of how we govern, how we map risk. As Justin was just saying, measurement is huge because everything is about how you actually validate and test, and a large amount of our investment also has to be in managing this risk, both using traditional techniques and inventing new ones to really put all of this together. So we're going to do, in this amount of time, a kind of whirlwind tour of different pieces of what we do here. So starting with govern. I'm not the policy person, but I do get to spend some time here. So Microsoft's approach starts with AI principles. The thing I think that's interesting to point out here is just that they're quite broad. If you try to silo your different risk functions and you look at privacy and security and digital safety separately, you're gonna have a problem because AI risks cut across all of those. You could have a prompt injection attack come in, and it could cause a security issue. It could also cause a safety issue if you're producing harmful content. It could cause other types of things. And so I think something that we have done that has turned out well in our program for many, many years now is not try to separate this and say there's already a function for that, but use responsible AI as the big tent and then activate all those other functions, help security understand the new AI risk, collaborate with privacy to understand what's at stake. The other thing I'll say, so we take those principles. No one knows how to put principles into practice, at least not your average engineer. Maybe the brilliant agents do. But the next step is then we have to turn them into a standard and like actual requirements, or teams don't know what to do. But again, if you look at the requirements, that's policy language. That's not really what engineers speak. And so the way we make this work is a lot of investment in tools, testing infrastructure, and then of course training people to understand their accountabilities. This investment is increasing massively when we go to this agentic world where the systems are building themselves, and so you need the tooling to actually be enforcing this because you really want the humans much more in the outer loop in that kind of auditing and monitoring function. So lots of investment in that. Let's see what else I have here. Also interesting, I think everybody knows for a long time we've been doing this at Microsoft. We've been totally self-governed. We had to sit down and say, like, what are these systems supposed to do? What does the world expect of us? That's totally changed now. We have sort of a huge number of regulations and actions appearing around the world. And so it's definitely a change to start thinking about what to do when there's very clearly written outside expectations. The good news about this, I'll say, though, is that yes, each one of them has their own kind of little special snowflake thing. It is forcing us to be more mature on, being able to audit and explain what we're doing to the outside world. But that said, everybody's finding the same big pieces. Hey, you should have a governance process. You should actually test your systems. You should have, mitigations in place. And so I think that's really encouraging that kind of all across the industry, because, a lot of these organizations work with different academics, with different companies, all of that, everyone's finding close to the same answer, which I think is good. That gives us a path forward. But still painful to consume all of these and then figure out how to put them into practice. Lots of effort. The other thing that's been really interesting in our practice at Microsoft is something that customers ask me all the time is like, well, what does Microsoft do versus what do I have to do? And the answer is it varies depending on kind of what level you're adopting. And so what we found is in our responsible AI practice, if we're the person building the model, that's different than if we're just hosting it as an API. And that's different than if we're taking the model and integrating it into one of our own co-pilots and creating a complete application. And even our co-pilots themselves are very much a platform where other people are building applications. And so there's themes like when we're building a model, we need to test when we're building an application, we need to test, but we need to test for different things. So for example, if we're building a model, we're going to test for dangerous capabilities, emergent things like acceleration of biological weapons. If our customer is building on top of our model, then they need to test whether or not it makes sense for financial services, but they don't need to retest the bioweapons thing, right? And so figuring out these layers of responsibility is something that's really important to actually make this work in practice. And I think there's low understanding today of kind of where those layers go, and that's something that we need a lot more people to kind of skill up on. All right, we're gonna jump out of governance into mapping risk. So this is a slide from our AI red team. Ooh, I think we lost some text too, sorry. There's some beautiful text here that says complexity and maturity. We're pretty mature at testing traditional security. We're really not great at testing psychosocial harms there. But we have a new one of these, I feel like, every year. Every year we're adding some new category of risk that we think is important to test. And so we're spending a lot of our time over here now in dangerous capabilities and these psychosocial harms. Previously, we were spending a lot of time on security and content safety. We still spend time on these. It's not like we've solved it. We just keep adding more to the bucket. But the way we test a lot of things when we get a net new category of risk is we built an AI red team. And the AI red team publishes a lot, so you can kind of check them out. Ram, who leads it's here at RSA. But anyway, this is a unique set of experts that we've pulled together that look at how they break models and systems, but in this much wider range of risks. So not just traditional security things, but all of this whole category. And so when we get a sufficiently new technology, like as Justin said, there's these step functions all of a sudden where you're like, whoa, this one's different. And unfortunately, or fortunately, we get one of these, whoa, this one's different every month or quarter. And so we bring in red team and other experts to really understand and kind of map the risk. If you want to know about what they're finding, they've published a great paper that you can learn more about some of the specific lessons we've learned from generative AI, so check that out. The other thing is like red team. I couldn't live without them. My job would be very, very hard if we didn't have them. But they are a scarce resource. We cannot use them on every single system of our own. Our customers usually can't afford to have the same level of red team, or maybe they can afford it, but good luck trying to put one together. There are only so many experts right now. And so one of the things the red team built for themselves is Pirate, which is an open source tool that uses AI to augment red teamers so they can be much more effective in their attacks. Now, that still implies you have a red teamer and you have a human in the loop. But a lot of systems we want to test that are lower risk, we don't necessarily want to put a human red teamer on that. And so we've taken all of their great techniques and we've built them into a red teaming agent that is part of Foundry, which is our AI platform, but you can use it on any system. Kind of all the pieces are modular. And so then we're regularly updating our agent, which we can use on different systems from the knowledge of the red team and what they're actually learning. So the other lesson that we've learned that's really important is that trust and building trustworthy AI is a team sport, and this slide was made for a very specific reason. So you might end up saying there's a bunch of personas missing here, and that's true. But when we think about the active systems that we're building, you absolutely need to think about IT. They have an important risk management function today, security, obviously. But one of the things we're seeing in our practice at Microsoft is that the developer matters a ton too. If we don't build these systems the right way, if we don't have the developers investing in the right testing and guardrails, it's really hard to actually get the outcome you want. And you can think of it this way of, okay, IT can figure out that an agent is off track and stop it. But if you actually want to fix it so you can use that agent, you need to bring the developer in most of the time, right? And so the developer is a really important function. And so the rest of the stuff I'm going to show you are developer-facing tools, and we use these at Microsoft in the systems we're building. They're also things that people can use themselves externally. There are connected security and IT tools that are a huge part of this story, and they are also being presented at RSA, or we can talk about them after, but I'm just showing you one slice focused on the developer, but you need all of these pieces to kind of fit together. a big decision that Microsoft made early on that has been critical is that we build all of our internal systems on the same platform that we offer externally, which is now named Microsoft Foundry. We love rebranding. But this has been really important because the world is changing so quickly, and it gives us a single place where my team, we see a new type of attack come in, we can fix the system in one place. That helps us kind of fix it in all of the Microsoft AI systems. It also allows us to learn very quickly from a diverse set of applications, as well as from our customers. And so this took sort of company leadership to say, we want to have one AI platform. If we really diversify, then we have to go be fixing things everywhere. It's hard to keep it on the cutting edge. So we made a centralization decision that's been very critical in making this actually work for us, given what a heavy tools investment we found we actually need to make responsible AI work. Okay, so let's look at some actual stuff. Measurement, huge, so important. I think everybody in software engineering would probably agree that testing matters. That said, when we looked at AI 4 or 5 years ago, the amount of testing that people were actually doing when they shipped this first wave of generative AI was light. Now, the most successful teams invest heavily in that testing or validation function to actually make this work, but we're still seeing kind of low maturity across most organizations in this. So the other thing is what you have to test for is different. You really need to test for both kind of high-level things and low-level debugging metrics. And so this is my very basic agent example of, okay, I just want to ask the agent for the weather. It's pretty basic. Where can this go wrong? Well, it might not understand what I want, so you might have an error in intent resolution. It might pick the wrong tool for the job, right? And so you might have an issue in tool call accuracy. And these can all have downstream implications with these errors. It might actually get the right information, know what I want, but then fail to put it all together and respond to me and fail to complete the task. And so we need to build systems that allow people to both understand, like, was this agent successful in this job overall, but also what went wrong along the way, because this is how we actually both detect if there are issues and help the systems get better over time. So I'm going to jump over. I'm going to put this here. Hopefully you all can still hear me. Yes, no? Okay. You don't need to see Zoom. Okay, I'm going to show you what this system looks like for us here. So this is Foundry. As I said, these, we'll try talking here. These are, I'm showing you the third-party interfaces where you can use these directly. These are the same tools we use internally, and they're also, we can turn this off. They're also something that you can use modularly through code. You don't have to use them through the UX, but it's obviously easiest to see in the UX. So the first thing here is I have an agent. This is Java. It's a retail thing. Microsoft loves to use it as an example. And I want to actually test that this system is doing what I want it to do. So I can create a new evaluation here. I can say I want to create an agent. I'm going to generate synthetic data. I could give it more interesting stuff. But then you see we've got already, for our engineering teams, a whole built-in set of different things that we want to test for. So tool selection, output utilization, the different quality metrics, is the response actually relevant, coherent? All of these should make sense from the chatbot era. And then, of course, different safety things. Is it producing vulnerable code? Is it vulnerable to prompt injection attacks? All of that. And so we enable you, I'm not going to probably run this, to actually then test your system for all of these different ones. I'm going to go back here. And then you're going to get a result that looks like this coming out of your system. This is one that Ying on my team ran previously that allows you to see, like, this agent. It's really good at picking the right tool. It's got coherent responses, all of the other stuff, green, green, green. It actually is looking great on safety, but it sucks at tool input accuracy. So this allows you, and you can actually then here, let's see if I click on it, I believe, you can actually, maybe not today, go in and see the specific answers, and AI will help you figure out which examples are going wrong and all of that. Now the other thing here though is those are kind of using the system as intended test mostly. I also want to make sure I'm testing adversarially, and that's where you can create these red teaming runs, and you can decide like how much money you want to spend actually red teaming this, and more interestingly, what are all the different types of, we don't have tool information here. You can see all different types of attacks that you want. There's risk category, so here we go. All different attack strategies that we've put in that you can test the system. And so these kind of testing tools are something that's really important in our practice. We would have a very hard time deciding that any AI system at Microsoft is ready to ship without kind of robust testing. Now, here's a newer capability that's gone even further, because I think, like as Justin was talking about, the amount that you really want to test these systems is you need it to be a very meaningful level about what you actually care about. And so this is a new capability we've developed that actually allows you to specify what you want to test for. So here, for example, I can say I am worried about anthropomorphic design, and I can use our system here either to do kind of a quick thing, or it can go and do deep research and really understand the concept. It uses a new technique from Hannah Wallach, my friend in Microsoft Research, to actually systematize this risk, to break it down into different subcomponents and then generate high quality tests against it. And I'll show you what these actually look like. I've already generated some here. But if you look at it, it breaks it into, in this case, 31 policy components. So for example, it should comply with being conventionally polite, but it should refuse to actually express like that has a lived experience. And so this is a place where we as experts have put a lot into this tool and making it work so that our engineering teams who are not experts in these different types of risk can build on top of this tool rather than having to start from scratch, because they would not be able to break this particular risk into these 31 claims. And then of course this works as you expected, where there's seeds that then how do you test for this particular claim? And then of course results that there's only one kind of result here where you can see what was actually done, and this one only complied 2 out of 3 and make your system better. So this is one really important part of the system testing. I'm gonna go back and show you, I need 2 hands, go back and show you what do we do about mitigation. I think Justin covered this really well, but part of the game here is we used to use humans really tightly in the loop. Okay, they're reviewing every response from the AI system. That's the chat era. Observability is what enables us then to actually move that human to the outer loop. And so these tests, we also enable them to run online continuously in our systems, so that we're not only, because these systems are so dynamic, testing pre-deployment, but continuously making sure it's still adhering to the properties we say we care about. Now, great. Okay, we've tested it. We found some issues. We actually want to do something about that. And so managing is where we're having to equally invent a lot of new technologies. So I'm going to cover this really high level. Okay, agents can go wrong in a lot of ways. This same survey that I like, you can kind of see 3 big categories people are worried about right now. Agent doesn't do what you want. Agent is vulnerable to new types of attacks. And leaking sensitive data. And what do we do about these risks? Well, we're finding that we need to mix old and new technologies. So agents are a new type of entity in our systems, right? They kind of work like users sometimes. They kind of work like apps sometimes. Well, we have ways to secure users and apps and devices. And so extending that existing data governance, identity plane, everything, to work for agents is part of this. And so we have an agent ID and Entra, for example, now. But then also, there's new types of risks that are more specific to these autonomous agents that we are developing technology for, and we put these 2 pieces together to actually make this work. And I'll give you an example of the new a little bit. So you could make a really easy data security policy and just say, okay, agents, internal agents are only internal, external agents are only external. But it's not that interesting, because to get a lot of value from an agent, what do I really want to do? I want to take all my brilliant internal sensitive data. I want the agent to think about that. I also want it to understand the external world knowledge and then be able to put those two things together. And so you have to be more clever about what to do, because there's this thing that many people call the lethal trifecta, which is you can have untrusted content come in, therefore you can get attacks to come in. If it's accessing your sensitive data and it has external tool calls, you can get unpredictable model behavior that leaks sensitive data externally. So what do we do about this? We add a variety, still want to do things like least privilege, access and all of that, but say it actually needs to access this data. So we layer different things on top. We have different preventions and detectors for prompt injection attacks coming in. We have things that are analyzing the data going out. And we have new capabilities that are looking at, is this agent actually doing what it's supposed to, or should I stop it? So we bring these different detectors in at different intervention points to really make this work. And I have to wrap up, so I'm gonna just say one or two more things here, which is, so we found that you need 4 things when we really think about agents. Observability. Observability is really important everywhere to actually know what's going on and detect these issues. We've been partnering and contributing to the OTEL standard to help sort of make a standard for all agents there. Controls, old and new, I just mentioned a little bit there. Deep integration with traditional security things. So if your agent is under attack, I want the controls to stop the attack, but I also want my security operations team to investigate that. And so this is a place where we're connecting our developer plane deeply with the security operations so that they can participate in this. The other thing is, you don't know where to look. We don't want just one agent. In Microsoft, I think we said we have 500,000 or something that security is managing now. And you need to know where to look. And so being very smart about how to help people understand where there is risk, where the system is going off task is really important here. We have a developer capability here called Foundry Control Plane that brings all of these capabilities together for the developer in a nice interface, which I don't have time to show you. And so it's really about bringing the testing I showed you, controls, all of this together so that all of these tools are available to the developer in collaboration with security and IT to really make this work. If you want to use Foundry Control Plane, it's here. There's lots of nice links. The other thing I'll say is you want to learn more, like so much of our external tools at Microsoft are built on how we have actually learning to do this with every AI release we see at Microsoft and what we're finding our company actually needs to do this at scale. We publish a transparency report every year on how we do responsible AI, so you can check this one out. This is from last year, and we have a new one sort of coming out soonish. So that's where you can learn more about our whole kind of program overall. And then I'll just wrap by saying, like, I think this technology is so exciting, there's so much potential, but if we don't get that foundation of trust in place, and that's gonna take all of us, we're really gonna limit what this technology can do to help people and the impact that it can have. So appreciate you all listening and happy to chat more after.
So I think we can do a few questions while we
Sure.
set up for the panel. And if maybe Thomas, you can help set up for the panel, or folks on the Graphistry side could set up while we do it. Yeah, I don't know if anyone has a question for Sarah already that you've been thinking about.
I'll take pointy comments too.
Justin?
Is that okay if I ask about this? Just regarding trust and sentiment, my impression is that it's actually bimodal. So that one showed one distribution. Can you say a little bit about the developed world, separate from the maybe less developed world and the sentiment?
Yeah, at least in the data in that report, the bimodal is right. Actually, what that report found is that there was more adoption in the less developed world because there wasn't pre-existing systems that they already trusted. And the more you adopted, the more you trusted it. So I think like getting people comfortable to get hands-on with the technology does remove some amount of the fear, because you're no longer like, this is an abstract thing I don't understand. You're like, oh my God, it's really amazing. Also, it's really dumb over here. Okay, and you get more comfortable with it. So I think a really important thing is to make sure that people have access to this technology so that they can participate both in governance and remove the fear.
Let me give you the mic here.
Yeah, just a quick question on the one of the initial graphs, or one of the initial slides, you talked about the concept of fairness as part of AI governance. Given kind of the evolving conversation, how do you navigate standards of fairness, especially globally and across different cultures?
Yeah, it's obviously a very topical question. And, I think the answer I would say in terms of how we're thinking about it is it's still really important to understand how your system behaves. So we still need to invest in the testing and the tools to understand and control your system behavior. And then ultimately, it's up to the specific application to decide what makes sense in that deployment context, whether that's their legal environment, their customer environment, all of that. And so we've focused a lot of our energy on creating those foundational capabilities, but making sure that the actual final decision is in that local context and control. But it's something that we've seen a change in how people feel about harmful content coming from these systems as well. And so that's one of the interesting things about this is that we are very actively as a society navigating what we think is appropriate AI behavior, and it's not going to come out uniform, of course. And so that's why making sure we have the controls so that you can adjust rather than baking in one answer overall is going to be really important. Cool.
Great. So thank you, Sarah. Actually, I'll ask you to stay on stage for a little bit. And
Okay.
I think we have Bernard here as well, and then Justin. So we want to do a little panel of 3 different perspectives. So you already met Sarah, you already met Justin. We have a third participant, Bernard. So he's the CISO of Corelight. I think folks may know Corelight as basically Enterprise Zeek, post rename. I thought this would be an interesting panel because now we have 3 very different perspectives. I think we have sort of the AI extremism, we have the responsibility, and then the person who has to kind of internally balance people doing both at the same time. So I wanted to start off, and also for folks online, please just post questions in the YouTube, and we'll be including you. So I wanted to start off maybe just like an easy one. So, at home, what are you using? Are you using Claude Code? Are you a Clawbot person? Do you none of it? You just go hiking? I guess whoever has, just pass the mic.
I have the mic. At home I go hiking. Actually running, I'm training for the London Marathon, so I only run and sleep and work.
At home, I try and wrangle 5 kids. And when I have a break from that, I play around with Claude Code. That's been my primary development platform. I have recently started a small Moltbook experiment, but I am not running OpenClaw. I decided to defang it and re-implement my own agent in AWS that fits the Clawbot kind of needs to operate on Moltbook. But that's what I'm up to now.
I think you can't learn to play poker with fake money, so you need real stakes. And so it's important for me at home to really have stakes. So I have what I refer to as my domestic staff. They're in my home Slack. So my family's in the Slack with me. All of our expenses go through there. We have business topics and calendar and everything. It's all custom agents. It's informed by the clause, but it's my own implementation. So my domestic staff, they help me with everything.
Great. So next one is probably for Justin and Sarah, but feel free if you guys want to go different. So next 3 years, I'm kind of curious about the next 3 years of AI coding from your perspectives. So this year, about 20% of code at Microsoft and Google was AI generated. Oh, sorry, that was last year. And it's predicted to be now 20% in this year of all code on GitHub will be AI authored. So I'm curious what the next 2 years look like for a competent team.
Do I have to go first? Okay. All right. So I can only reject the premise. I definitely don't know what code is. I think mostly I work for businesses and I work on businesses, and businesses have operations for the purposes of receiving revenues and then fulfilling them with lower and lower costs at faster and faster speed. So I guess sometimes something needs to generate, some code to compile in order to run on the hardware, I guess. That's not the main thing.
So we will forget what all these twisty bits are within 2 years.
Yeah, that's propeller head stuff.
Yeah.
I think, as I was saying in my talk, I hope, or feels necessary at least to do this well, is much more investment and thinking around what are you actually trying to achieve. So to Justin's point in his talk of only kick it up to the humans for the meaningful decisions. I think we have a lot of work to invest in that decision interface and how do you actually really capture that. And right now you see organizations bringing experts of different types to talk about risk versus reward and make like these high stakes decisions. But if we want to start doing that really at scale in our organizations, I think we need to invest a lot more. And so I hope the future holds that, but I'm sure not everybody's going to do it, and we're going to see the Wild West of excitement and also what we saw with OpenClaw. Wow, this is so amazing. Oh my God, why did they delete all my email, right?
I can take a stab at it. You know, we're going through an interesting period of time where people who have no business writing code or trying to push to production now have a fully featured developer sitting at their fingertips. I think it's a forcing function for the business to kind of actually understand the system that it's operating within, which means that now executives down to your frontline managers into the individual resources that are building things are thinking in a system context instead of just their individual functional or role responsibility. And I think it means that we will clear up the kind of disconnect between here's the business logic, here's the processes that inform how that business logic is executed, and therefore here are the systems and environments that those things are executed through. And it will create a ecosystem where, like Justin was saying, there is no code, there's just businesses trying to do business things that it'll constrain itself into a much smaller problem area. And I think that, you know, we land in a space where, yes, agents or AI are somewhere greater than 50% of business operations and solutions that are underneath that.
Can I poke a little bit on your initial statement that people have no business doing this? I think that's actually what's really exciting about the technology. Is it's unfortunate today that there's such a high bar to be a software engineer in terms of education and ability to have an idea and actually just go make it real. And so the ability of this technology to make every single person a builder, I think, is fantastic. But we just have a lot of work to, like, we all went through a lot of training to make sure we think about reliability and security and all of these things you care about, and we have to figure out how to democratize that as well, or build it into the system so people don't have to think about it. But I think that's what's very exciting about it. Scary too, but exciting.
So, so thank you. And I feel like I was trying to debate, like, I think there's, as we're rolling out these things, there's sort of like an internal view versus an external view. Like, and I think oftentimes we start internally because it feels a little safer. You have more control. You can put in mechanisms. You can, you know, slap some hands, you know, that kind of thing. But then when you go to production and start getting customers doing things, now it's a much more messier thing. It's a little hard to tell customers no sometimes, and the whole shared responsibility. So I'm kind of curious, like, for folks who are starting to go from, well, maybe you think internal is harder, and then I'm curious what's the zero to hero for doing an internal, or if you think putting it into your product and actually having an AI product where the customer is actually doing AI stuff on top of your stuff. I guess the question is, like, which do you think is harder? And for teams making that leap, what's your recommendation for zero to hero?
Somewhat controversial statement. Nobody knows what they're doing. And it is much easier to provide offerings to customers when they are just kind of learning and expecting value from you, that you don't have the same constraints and kind of organizational change management that you have to go through internally, that makes it a bit easier to deal with the external versus the internal. I think the internal side is, again, it's winning hearts and minds. It's a shift in practices. It's understanding the processes that underpin that, the system that you're working within, and then what are we doing with these things to actually create value versus pet projects, experiments that don't go anywhere, which is much different because on the outside there's always a value capture mechanism that says this is how well you're doing, where internally that's just a little bit different.
So a lot of times in our responsible AI sort of practice, we recommend that you go internal first, and we'd say sort of the same thing to customers. And I think it's a mix of it's a more trusted user base. It's usually a more sort of informed user base, and you can manage their expectations better. So I think there's a lot that can make sort of internal easier. That said, customers, especially like at Microsoft, enterprise customers are a lot more demanding in a lot of ways. And so I think running the internal experiment first is imperfect because it doesn't necessarily push you to always make it great. And so sometimes we don't really get the kind of great signal, or internal users have a lot of context. And so they have the same assumptions as the system builders compared to kind of external ones. As well. And so I think it really depends on like what do you think is going to give you the most signal to actually make the system do what you want it to do.
Okay, yeah, thank you. So that resonates as someone who has to work with all of those personas. So for accountability, like, when something goes wrong, who's responsible? So is it like the AI model maker, the inferencing provider, the agent maker, the developer, the product company, someone at the customer? And what does that mean? What should be done before an incident? So I feel like this is just actually Sarah's entire talk. But
That's why I put that chart in for you, Leo, because I was like, oh, I found a chart that exactly says a lot of people are responsible. I think it's a really great question, and it's actually one customers ask me all the time also. I think that everybody has a role to play, so there's not a binary answer here. We have probably an over-rotation on the model providers right now, and thinking that everything can kind of be fixed in the model and that the models are responsible. We're starting to see that conversation mature a little bit. I think one of the things that I've learned in my experience that's very challenging, though, is when we're in the middle of an incident. It's actually very hard without a lot of information to understand where it's going wrong and why. And so then that makes this conversation about first just debugging to stop the incident hard, but then also the conversation about who really should have been doing what very hard. And so that's one of the reasons that like the first thing on my slide is observability, and it has to be meaningful observability. You could just barf all the telemetry and still have no idea what's going on. And so we have to build tools to help quickly figure out where the issue is and who's responsible for it. But the conversation itself is healthy that we're starting to have it.
Oh, sure. So when things go wrong, I think the vast majority of the area under the curve of things that go wrong is a failure to apply the models to the maximum extent. So we don't typically discretize a failure to achieve market share or opportunity costs in the terms of incidents, but that's by far the biggest concern that's going to face all organizations. So I think the responsibility is that of management. So when you are responsible for an organization and you fail to supply demand at the rate that you theoretically could have, we already have mechanisms for dealing with that. So it's management's responsibility to essentially fail to meet demand at the rate that your customer is demanding.
it's a very startup answer.
Well, I think we are in a space where we're still learning a whole lot. That there's a shared responsibility model that we just have to actually define. There's a set of things that we can kind of pre-plan for. Hey, where do I have the potential for hallucination? Where do I have the potential for data leakage? Where do I have the potential for some other risk that I'm actually aware of and have categorized and can assign properly? And then after that, it's just how well can we do blameless retrospectives and get down to determining with model provider, customer, vendor, whoever, who should actually own this and how that gets defined in some standard.
Yeah. Actually, Bernard, I had one that I thought you'd be good to go next on is, so what keeps you up at night?
So I'm in an interesting role right now. I've got the CISO hat that I wear, yet I'm also responsible for AI adoption and enablement in my business. So I've got a CIO hat that I wear. And right now, the thing that keeps me up at night is, will I be able to steward AI into this organization in a way that we actually demonstrate value and move the ball forward on achieving greater revenue to where the business is still competitive, more so than I do the risk side of AI in our products is going to disclose some information and be a company-ending event. So to me right now, it's the acceleration and value capture inside the business that keeps me up more than the security and risk side.
Yeah.
I can
Yeah, Sarah?
So one thing that's fun but crazy about working in this space and in this market now is the rate of change of the technology is absolutely crazy. The rate of change of how people are applying the technology, also crazy. And the expectations of society are changing very quickly. And so myself, my team, we are moving, at pace because I believe very strongly that we want to demonstrate that there's not a trade-off between doing this responsibly and doing it quickly, because we want to set the standard to show that you can move at pace but do it responsibly as well, because it's very hard to argue against doing that. And so moving at scale, at pace in this high-stakes domain, I think is a very good environment to ask yourself every day, are you making the right decision? And so I think the thing that keeps me up at night is how is, when we're heads down in the trenches right now, how is this going to look in the arc of history, 10 years from now or whatever, and making sure that you're simultaneously looking big picture, well day to day, making very rapid, high stakes decisions.
So all of us maybe in this audience have some avocations. So there's something we would choose to do when we're not at work. And then we probably also all have vocations, right? And if you imagine just the Venn diagram of our energy and time spent on our avocation versus our vocation, the thing that keeps you up at night is the not huge overlap that across the world and society. So we're spending very little fraction of our attention in the sort of upper tiers of Maslow's hierarchy, and we're working more down low. So that's the thing that keeps me up at night. Yeah.
I've actually got one more that keeps me up at night, and I think this is, we're builders, or we're very good professionals, I'm assuming, in this room. I always ask myself, is there more that I could be doing? And AI has removed the barrier from actually being able to just go build a thing. Like, I see a problem, I can just go build that thing. Should I just go build that thing, release it open source, go find the right person to ship it to? Those things pop up for me much more often now, because I get an idea, 20 minutes later I've got a prototype. What do I go do with this thing? And so, how much more impact I can be having globally than just what I'm doing in the company is something that stays top of mind.
Yeah, that's great. That actually makes me think about the whole free as in puppy problem that we're starting to have. I'm curious for folks in the audience, is there anything while we have, see someone back here? Alex?
Yeah, so I guess the question I'm curious about is, it's for all of you, but starting, Justin, with your talk, there's this notion of getting more tokens and intent. And then, so I'm kind of imagining, okay, so the customers, there's a lot of intent and there's all these conversations and there's good intent there. And then how to curate that? What's the future of the user interfaces or experience of how does intent get curated and prioritized? Does it go stale? Or how do y'all think about this sort of thing?
Yeah, I think the modes for this are going to be, we're going to do a ton of experimentation with this, but I'll say a huge part of it is the interface that we already have with our colleagues, or the storytelling that we're already doing to build support for an idea or to sell an idea. If you could imagine getting a feature film funded, how you would pitch that, how you would articulate that, how you would tell that story. I don't know. I think it's a lot more like that. The human interface, the ways that we're intuitively able to respond to something, the ways that we can express something that achieve an impulse of desire. I think all of those apply, even if it's about how are we going to move this much iron ore from this continent to that other continent.
Great, and so thank you, Justin. I don't know if anyone wanted to answer further or you're happy. Yeah. So I guess back on the security train. Some or doesn't have to be. You actually can take this anywhere you want. Is there one thing you want to see teams to stop doing, or something if you were going to do it over again, you'd do very differently?
I want my teams to stop working in the problem and go work on the problem. There's a bias for action that people see the atomic thing that just happened and want to go fix it. And that takes up a whole lot of cycles, especially down in like my SOC and in my GRC teams, where they're just like, I'm going to put out the fire. Like, no, you have the ability to take that same, call it sprint that you would have spent doing that previously, to think about the system that actually fixes this problem for you, and then we can go build a prototype, and then we can work on getting that prototype into production. So it's a shift again, and that's was to my comment earlier. The people that have no business, like, it's not that they shouldn't build; it's that they aren't thinking. They're not seeing the forest for the trees, and therefore they aren't thinking about the system, and therefore they are building things that are meaningful in the small scale, but not to the level of impact that they could potentially have on either the program goals or the business at large.
Yeah, my answer fits very much with you, which is I was going to say, maybe I'll reframe, all startups can usually be a start too. I want to see people to start using their brain. We have too many people kind of trying to just throw spaghetti at a wall or use going fast as an excuse for not really thinking about what they're trying to do and doing it the right way. And the teams that are the most successful are the ones who are actually looking at that higher level goal and then experimenting with ways to achieve it. It's not that everything's going to work. You have to be thoughtful about that experimentation, but the really actually thinking and not just blindly following the herd is what I would like to see people start doing.
Yeah, no, maybe an observation is, I think if we talk about AI factories, like Justin was talking about, the people closest to the problem are the analysts in the middle who are in the problem. And so now they actually can also, in theory, be the most effective at solving it. Like they get to see the data, and data science, that's the number one thing, is look at the data, and they're the ones who know it. Well, anyway, so thank you to our panelists, and if you want to chat with them after, I think we're going to have a break period, and hopefully they should be around for a bit. So thank you.
It's very nice to meet you.
Good to meet you.
All right, folks. So we're going to get started with the next session. And also I wanted to share just a couple schedule changes. We're going to have these updated on the website. So we actually have two essentially foundation model pre-training talks, or I don't know if this is pre-training or post-training, but we will find out. One of the changes is at the deep tempo encode. I think it's an encoder-only model session got moved to 3 p.m. That will be in Quadro. We'll take a little field trip to walk over there, and I think we're going to try to get that online as well. And then the David Cass talk is getting switched with the Victor Fang on-chain talk. So we'll get those updated on the website. But meanwhile, I want to introduce Amin. So I think you were part of the acquisition of Robust Intelligence into Cisco. And I think you're the director of data science research. I'm butchering this here.
Nobody knows.
Nobody. I think nobody knew before, nobody knows now, and it'll just keep changing. Chief scientist, sorry. And so I think this will be really. Actually, yeah, I'm just going to leave it there. I was very excited that when Amin agreed to share with us today.
Of course. Thank you very much for everyone for being here. Today I'm going to talk about a small reasoning model for cybersecurity. It is a culmination of ideas. It's these days called mid-training and post-training. So, and we'll go through these stages in order to see how this works. And I think one of the main reasons that we wanted to build a reasoning model was just, at least for high-stake reasoning, for high-stake tasks like cybersecurity. Very often it is not enough to have a model that is very fluent in responding. What we really want is a model that exposes its thinking, its internal processes, so that we can look at it, we can audit it, and we can say yes or no to how the model gets from the beginning to the end. So I'm going to focus on the one that we built, which is a very small model, but it really punches above its weights. Very good. So I cannot get all the credits for building such a model because it was a very tight collaboration between different teams: the research team, the data team, the threat intelligence team, and the platform. I really don't think that building a specialized model, small cybersecurity model, is only a model problem. It is really a combination of problems. You have to get very good data, very high quality data, so that the model, the models are as good as what the data they digest. And to do that correctly, you need a very good data team. You also need experts, so that they tell you what is good data, what is bad data, what are the problems that we are trying to solve here, and we are very fortunate to have such experts in our team. And finally, the platform. We have to be able to run many experiments in parallel, check different checkpoints with different models, and also have a very robust evaluation of the models that I'm going to talk a little bit about. And that is extremely essential because this is going to be the North Star of where we are trying to go. This is the only way, actually, that I know how we can get from a research prototype to a model that really matters in practice. The effect that we have seen with such a small model in the cybersecurity community, in particular with our customers. I think this room is not unfamiliar with all the challenges that we're facing with all the security challenges. The data is just accelerating I think the right way is maybe accelerating at acceleration. It's just like exponentiating the exponential, and there is no way to go back. So there is just overload of data. At the same time, just to couple that problem with how few experts we have in cybersecurity, that is a conference that we are all attending, and that is it, I think. Not so many people. There is the threat landscape is just evolving with AI. Like every day, there is someone puts on Twitter something that that completely changes people's mind about what is a new kind of threats, and we are constantly under fatigue. So the security analysts, the security experts are like bombarded from different directions at the same time. So it's not enough to just detect the threats. I think we should be able to reason, to go through these threats at machine speed. If these problems are they are because of the machines, maybe the solutions is also by using them. If AI is making a lot of changing the threat landscape, maybe the AI is also the solution in order to come up with a solution. So why do we have to build AI models in security? First and foremost is the scale, right? We talked about the volume, the velocity, the variety, and the complexity of the data that we're facing, and no expert or a collection of experts can handle or process the data. And at the same time, I think it is very important to be able to build models that are customizable, that are very cost efficient. I don't think if you have an operation based on AI, if you're automating your AI operation, the cost of security should not be as much as the cost of automating the workflow. It should be a fraction of it. So we need solutions that are cost efficient. We need solutions that they support data sovereignty. And on top of that, we may need solutions that we can optimize their performance when they are deployed in any security platform. So for that reason, I don't think that building an open source model is a preference. With my academic background, I think it's a critical requirement to build such models, to get feedback from customers, to be able to deploy them with all these requirements. And to do so, in Foundation AI at Cisco, we came up with a variety of models. We came up with the base model. This is a foundation model that is going to be the foundation of all the models that we are going to build later. This is the nucleus of all the models. This model, the base model, digested all the data, but it doesn't have the ability to chat. It doesn't have the ability to reason. It just knows, but there is no structure in its output. We also built the instruct models that are chat optimized for direct use. And recently, the most capable model analytically capable model that we built is a reasoning model that has the analytical capabilities of the instruct model and the base model. So today's talk is going to be focused on the reasoning model. And I think the main shift in the main paradigm shift is that the correct instruction tuned models, they're very good, and actually the big ones are extremely good at direct Q&A answer. But when it comes to multi-step analytics, they struggle. All right, and I think very often in cybersecurity, it's not only that we want the correct answer. We want to know how and why a model came to this conclusion. All right, and that if we cannot do that, then there is going to be a trust barrier for deploying these models, especially for security experts. So that is the reason that we built a native reasoning model. It natively thinks and goes through different steps of critical steps of thinking and reasoning in order to get from the prompt to the final answer. So in this example, it goes through extracting TTPs, maps into MITRE, query CVEs, synthesize threats, and it gives a line of sight to security experts, and so that it is not only it is fully exposed how the model got from the prompt to the answer, but it is auditable by those experts. And to do so, it has 3 stages. The first stage is actually what is called the mid-training or continued pre-training of the model. That is a base model that we built. And this base model has all the knowledge, okay? It digested all the security knowledge. Then the first step is to do what is called SFT, or supervised fine-tuning, in order to instill the structural habit of native reasoning. So basically at this step, what is really happening is that the model learns how to think correctly, how to basically have all the thinking traces. But what the model doesn't know at test time is how to prune these training traces when they're wrong. And that is why we have to have another stage, which is called the reinforcement learning with a verifiable reward, and that is in order to basically make the model very focused, sharpens its analytical logic against verifiable rewards in order to make it correctly reason, prune the incorrect ones, and truly have a thinking model. So just to show you that, how the training data, what is the training data composition between different stages, in the supervised fine-tuning, it is actually a broad spectrum to have basically fundamental reasoning across many different domains. We don't want to have only for security domains, because thinking is very general, and we have to have general thinking for general usability. But then in the second stage, it's going to be extremely targeted. And it's going to focus on cybersecurity, instruction following, and math. And and basically during the supervised fine-tuning, the data composition is that cybersecurity is 26%, math and coding, which basically tells the model how to establish, it basically teaches the model to think step by step. Roughly, the data is roughly 35%. The exact numbers are not important, but they're rough numbers. And then for the general ability is 41%. So it is teaching the model the behavior. For the RL part, what we had to do was to overcome 2 issues. The first is that data heterogeneity, which means that the thinking traces that we synthesize, they have very short and long length, and that causes a lot of problems for training. So we had to make sure that we change the GRPO algorithm. This is a reinforcement learning algorithm, so that it puts basically same emphasis on short and long terms, and it stabilizes the learning. The second one is a very well-known problem, which is called the reward hacking, because the model gets higher rewards by giving you the correct answer with very, very short reasoning traces. Sometimes what it does is that it doesn't give you any reasoning trace, it just gives you the answer. So we have to make sure that it doesn't do the reward hacking, and we have to introduce a penalty for that. And here is what the RL did to the model, how it completely changed the behavior of the model. So there is a direct change, direct impact in attack technique extraction. There's almost 10 points. What is even more interesting is that there is an indirect impact. We try to teach model to have a very good cybersecurity, and the reward was basically on security and math. But then, it became very capable in other domains and generalized very well in general reasoning. And also there is a very clear impact on cybersecurity, vulnerability analysis and root cause mapping through this RL training. So basically SFT taught the model what to say, RL taught it how to think correctly. And that is maybe the highlight of what I'm talking about today. Okay, so we have reasoning models that competes and sometimes beats much bigger models in cybersecurity tests. So here for the CTI bench MCQA, it's on par with Llama 70B, which is 9 times bigger, and 98% of what is GPT-OSS 120. And what is even more interesting is that for CTI bench RCM, which is a root cause mapping, it beats both models. And this table brings the message. It brings home the message. With respect to Llama, there is a very clear push towards better or cybersecurity model. It is on par with GPT-OSS and Llama on those things. And what is even more interesting is the CW prediction. This is a new benchmark that we created. It is about CV and CWE mappings. And the timeline is that none of these models have ever seen these new CV CWEs. It's just after the timeline they have been trained. These are the new things that we collected. And our model beats everyone else by a very large margin. This is just not an isolated case. Across many cybersecurity benchmarks, we see the same pattern. And finally, because this is a cybersecurity model, the safety should not be an afterthought process. So what you see here is that if you just use the model as is, there is some safety, not great. If you use our model with the correct system prompt, then the performance goes against Harmbench to 93. And finally, if you use the Llama guard, then it is 98% safe, the model, at least against this benchmark. This is a system prompt. It is basically saying that you are a senior level cybersecurity with very specialized capability that you have to have. You should be very, very accurate. You should ground your reasoning, and you should have very hard boundaries against misuse. Final point, it's very important to make sure that if you're a specializing model, it doesn't lose its ability for in general purpose tasks. And what we see here is actually the green line with respect to the Llama. And the green is a reasoning model that is actually much more well-rounded than the Llama model. And if you want to get started with this model, we have cookbooks on GitHub. You can just, it will show you so many examples that you can use these models for. You can download them from the Hugging Face. And you can also, we can co-develop things together if you're interested. Because I think cybersecurity is truly an open source matter. We have to collectively solve the problem. We can just be in our corner and not do just focus on our own thing. But then we are not going to solve the real problem. So if we come together, and that is our thesis in Foundation AI, then we can have better models that are more capable, and everyone is going to be safer. Thank you very much.
Thanks, Amit. And meanwhile, can you stop the share on your Zoom?
Sorry?
Can you stop the share on your Zoom?
Yes.
Thanks. I don't know if folks, anyone, it looks like we already have one question here. Let me give you the mic here.
Thanks for that talk. That was really interesting. I'm curious, as harness engineering and agentic orchestration has kind of evolved rapidly over the last few months, what are your thoughts about what the harness should be doing versus what the model should be doing?
Yes, I think that's a very hard, right? So I cannot claim that I have the answer. Right? It's first and foremost. What I think right now the models are trying to do is to just lower the pressure on the analysts. Okay, so try to basically automate a lot of, like, at least the cybersecurity models. They have to help the analysts to lower the load on them so that they can do important jobs. What is some of the important jobs? Actually harnessing, right? So So that I have never seen a security analyst who says that, I mean, today I have so much time, I can do whatever. That has never happened to me, right? They're just basically on the other side. Like there are so many things I can't do and I don't know what to do. Can you give us a model that at least, tells me these are the most important things? This is a summary of all the threats that you have. These are the patches that you can do. And then I can go and go through them and just do them. So that's maybe my biased answer. But what is, I think, extremely important for the agentic workflow is that sometimes every single part of it can be safe, but together they can be unsafe. And that is something we don't have an answer for.
We have 2 CISO questions, so I think both of you will get them. Well, let's start with Bernard.
Yeah, I want to push on just making the analyst faster, with making the analysts more effective. Like, how do you think about in the model itself zooming out? I think about like different, I guess you'd call them perspectives. You've got the perspective of an analyst. If I looked at like the national security apparatus, I've got a single source analyst, I've got an all source analyst, and then I've got the person that builds the PDB. Moving from that single source analyst that's just working kind of on that problem all day long into that all source analyst that says, here's how you should reason about the problem differently so that you can remove all this stuff that's at the bottom. How do you think about that as you're training and building these models?
Very good. So there are 2 things I think that you're saying. One is that you want the analyst not to be faster. I think okay, so that I think what is not what you meant, maybe. I want analysts to have a better experience with what they're doing. But the second thing that you're saying is actually important, right? And that is, and I think that is the main point of what you're trying to say is that, like, you can actually look at it globally to the problems at hand and have many different solutions, right? And some of them might go through the analyst, some of them may not go actually through the analyst. And that is the whole idea of the agentic workflow that we're building next. And I think you're going to hear in some of the RSA keynotes of, if you have a holistic view, then and then have very different models with different specializations, then they can do much more than just a single model that does like a few things. I fully agree with the approach that you're saying.
It wasn't that the analyst should move faster, just making the analyst faster.
Yeah. Sure, yes, I agree.
Great, and I guess we have one more question from Steve. I don't know if you're still interested in asking.
It's actually a double, yeah. So the paper was great, by the way. So it's moving fast. Are you guys doing new research with a stronger base model now? Because it's been a few months. And then secondarily, I've noticed CVE, is this focused more on vuln management or SOC? Like, what are the use cases that the model is good at?
Very good. Yes, I used to be in when I was a professor at Yale, a few months was nothing. Like it was a long time actually, right? So these days, like 2 weeks, you're like out of loop. We are working on newer models and bigger models that they will come out. Open source again for the community to work with. It's not because we love training bigger models. The fact is that sometimes especially for tool calling, you need bigger models. The correct tool calling without hallucination, you need bigger models. That's the main reason. What was your second?
What use cases are you talking
Oh, so
about?
that was mainly SOC, but we are going to have search soon coming out, a model that is extremely good at searching vulnerabilities and finding patches for it.
So actually I have one of my own.
Yes.
So we're heavy on the harness side, and I'm curious how you think about like co-design of like if you control both the harness and the model.
Yes. I have not worked on that. And I think one of the problems that we see actually is because of that they are like somehow detached from one another at the moment. I think the immediate solutions are just using agentic models so that you can actually cover both, but co-designing might be the right way to do. I agree.
Any other? Oh, we got one back here. Sorry.
Thank you. In my experience with post-training different models, whether or not it's supervised or unsupervised, you mentioned this yourself, there's like new emergent improvements in the model and tasks that you didn't expect the model to improve in. But I've also noticed, and there's some academic research on this too, that models can also get worse at other tasks.
Yes.
Have you found this to be the case? And
You
have you noticed models get
yes.
worse at cybersecurity tasks or completely unrelated tasks?
You're absolutely right. If you do SFT, that is usually what SFT is known for, is that it gets better in one very narrow direction. It gets really worse in other directions, and it is extremely important to have our correct RL after that. There are other ways that we are experimenting now, and these are newer models that we are building that try to minimize forgetting other tasks, and they're based on what is called on-policy distillation, another RL way of distilling models, and they happen to have much less struggle with the abilities that they learned before. So our newer models are going to be based on those techniques.
I guess maybe my one last selfish question while Dave actually lets me. I thought I would have to wait till dinner or something to ask all these questions. So this is wonderful. There's this notion of like a reasoning poverty line that's somewhere around like GPT 4.0, or like for Justin earlier today, for him it was like 3.5, where just things started working, right?
Yes.
And so you're doing one of these like smaller models that's like more deployable, right? So I'm kind of curious, like for like a nice like interactive speed above the reasoning poverty line model, like are we there? Or and especially I think for a lot of people it's like single GPU. If you have like one like H100 or H200 or something like that single GPU form factor, even though it's kind of big. Yeah, like are we there? When will we be there? Like how do you think about it?
For general purpose or for?
Yeah, if you want to do an agent harness that could do Clawbot, or that you don't want to throw it out the window, you know.
I think we are very close. I think we are super close to it. I'm pretty sure that when our slightly bigger models are out, you will be like, okay, this is it.
So that's like this year, basically.
It's, yes, very soon.
That's wonderful.
Yeah, this year is, sooner, hopefully. Yeah, there's a lot of legal things that we have to go through at Cisco before open sourcing models. So, yeah.
Yeah, I guess for Stowaway, I guess I was curious about, there's a phenomenon where sometimes I find like, sometimes I'm really having a lot of work productively using Cloud Code, et cetera. And then other times I hit these kind of like weird patchy parts where it's like, I feel stupid and it doesn't feel like I'm able to get my intent to translate any longer. So yeah, I guess.
Welcome to the club.
Yeah, I guess I wonder from your perspective of training models, like what is that about? And
yeah, and can you
so especially about reasoning models you're asking, or?
Yeah.
So the models actually, what is important is that they get locked into their own reasoning and spiral. And that is usually the reason that usually this happens, is that the reasoning traces become extremely large. So there is a lot of research in shortening the traces, like after DeepSeek, so that the model actually don't get stuck and come up with like these weird things. And the other reason is that once they get actually, they start like spiraling down, they don't explore the model. So there are also ways of exploring the space more effectively using dispersed sampling, basically.
Excellent. So thank you to our speaker, and I'm sure people are going to have a lot more questions for him after. So thanks. Great. When you're ready, this will be. So yeah, I'm happy to introduce our next speaker. So Dave has kind of, I feel like, been everywhere now. Like he started on the operational side. I forgot if it's like security, fraud, or both.
Security.
Yeah, security side, and then Splunk boss the SOC. I think he's one of the founders. And then time, I think Google Chronicle got renamed to SecOps, I want to say.
Yeah.
And then nowadays, and I guess he likes scale, so he jumped from Google to Databricks and so he gets to be the eyes in a lot of interesting rooms. So with that, yeah, let's turn over to Dave.
Thanks, Leo. Right. Cool. All right, sorry, a little bit of AV problems there. So yeah, Dave Harold, I'm super happy to be here. Thanks, Leo, for having me. Yeah, this is a topic that I used to talk about a lot, and I didn't anticipate talking about it a lot more. But everything that's kind of old is new again. I think over the past little while. So we'll jump in here. The reason I'm here is because, well, let me jump here for a second. The reason I'm here, this felt like a couple of years ago to me, but it was really actually less than a year ago, about 10 months ago. I woke up and this was in my feed. So I don't know if any of you have seen this. But this is Leo and team, basically unleashing investigative agents against an old data set from about 10 years ago that I happened to help create. So it caught my eye because I helped with Boss of the SOC a number of years ago, and they keep doing this. This is from this week. And they're doing just more and more stuff. And my friends from Boss of the SOC are like, hey, I saw that you're speaking at this guy's conference. Like, what is the thing? What is the deal with this thing? And I said, well, near as I can tell, they're super serious people. They do real research, like 364 days a year, and then one day a year they create these crazy ass AI generated thumbnails. But seriously, when I first saw that, I reached out to Leo and the team and just kind of talked about, hey, what were they doing with the data set, and how could we help and collaborate. So yeah, I'll just jump to but like kind of who are these people, and then the thing with Boss of the SOC, it's an investigative blue team capture the flag. It's been around for a long time. Splunk still runs it. And it's super successful, right? Tom Schmidt over there still runs it, but I'm going to talk about some open source data sets that came out of that a number of years ago. This also, for me, was sort of an existential moment, like last April, where I think we all kind of have this moment, especially as a security person, where you realize that something that you thought was probably not going to be disrupted by AI absolutely is being disrupted by AI. And for me, it was sort of this sort of intuitive investigative flow that we attribute to security investigators. And that's when I was like, okay, I'm going to take this maybe a little more seriously. So yeah, I think investigation is one of those things that is art and science, and I think increasingly, if you put it in the frame of terminology that we use today, it's taste, right? It's human taste. So understanding, like, how do I, when do I sort of make a pivot? When do I dive deep on something? When do I formulate a new hypothesis? When do I continue to follow a certain hypothesis? And it can be learned, and this is something that we did in Boss of the SOC a lot. There's a lot of different CTFs that focus on a lot of different things. Ours was focused very much on investigative craft, right? Like how do you actually do a good investigation? And if you participate in this CTF, like it would teach you, right, from question to question, like how to progress through an investigation. So it can be taught. This is actually a picture that we took at one of those events. It's like tens of thousands of people have gone through this event. Like I said, it's still going on. I think they did version 10 last year. The open source data sets that Leo's posting all of his bombastic social media about, those were from the years in 2016 through 2018, right? goes back a long way. A bunch of us listed there that contributed to that. There's some open source data sets, Creative Commons 0. So these are things that people can use. There's data sets, and then there's also questions, and there's answers, and there's hints and things like that. The thing that caught my eye was Leo said, hey, here's a data set and here's questions. And if I just reframe that a little bit, it becomes something that I can use for eval for agents. So I can try an agent, go through this CTF, see how it performs. Okay, I can tweak something, can go through the CTF, see if it gets better, and you can start to hill climb and do eval. And for me, it actually says right there under the data sets project, we wanted to train security professionals. That's why we open source this data, but we always also wanted to fuel research, right? And I would say that there wasn't that much research that I'm aware of that happened because of this data. Lots of people used it to learn. Maybe a couple researchers, I think, Ram from Microsoft used it a long time ago. But I was really excited. So that was a cool thing for us. And one thing though is that, and this is what everybody, myself included, right, when they see, hey, we're using this for agent training. The problem is that the data is so old now and so well known that it's in every training model. The question, this is from Saturday night. So there's this guy, James, who helped us build these. And one of the questions in the Boss of the SOC data set was, what's James's favorite Coldplay song? Google knows, Gemini knows, Claude and ChatGPT all know the answer to this question, right? Because it's been out there. And so this is sort of one thing when I was talking to Leo about this is like, how do you deal with this? And they're actually dealing with it, well, right? They're understanding, hey, this is something that we have to take into account. But, it got me thinking that, we should maybe create some new versions of this. And so, oh yeah, there's some, there's a few photos. I didn't want to put too many Splunk photos in here because I don't work at Splunk anymore. So these are photos of my own house where we generated a lot of this data. There's my little lab under the steps and a much younger, some of my colleagues there. But, when we create these data sets, one thing, and Leo pointed this out, and we've had like tens of thousands of people point this out to us, is it was the realism that we, and the sort of the care that we took to make the data sets extremely realistic, using real malware, creating like very believable characters, having interplay between the characters, actually making sure that everything lined up from a timing perspective. Took a very long time. Person months to kind of go through all these things. So I thought, hey, things that I used to think took us a long time and that were a lot of toil and very tedious, now become much easier, right? And so how could we maybe create some more of these data sets for that would be open and free, and but were sort of built to that same high level of that kind of high bar of quality. So now we'll talk about new data. And so I was like, hey, I think we can do this pretty quickly. So I spun up something called Bad Actors Framework. It's Claude code, but with the idea being that when we would build these things, it really was like it was like film, like making a film. Honestly, it was like creating characters, creating a story. Creating all these storylines, and so and this is all stuff that I created. I started this on the 10th of March and finished it about the 18th of March. Again, this is something that back in the day we would spend like a long time building these months and months. So create some fictional folks there. Operation Yarnball. So this is something that also was really important to us when we created the bots data sets, and that was important for people that went through it and said, hey, we're learning a lot from this. We would always create a realistic but fictional adversary group, and we would take it as an opportunity to teach like CTI fundamentals, like, hey, there's there's this adversary group, here's a diamond model that shows like who they target, what techniques they use, what industries they target, that sort of thing. And a lot of times we actually created malware that sort of that was new, that sort of looked like it would come from one of these folks. So we have the attacker Yarnball, and I gave it a little bit of a nudge. I wanted a developer to be using OpenClaw, and to have his OpenClaw get prompt injected from some malicious content that he got in an email message, right? So I thought that would be cool, something timely, and so kind of prompted it. And yeah, I'll talk about the timeline of creating this in a second, but this is like 15-minute increments, right? Like, okay, prompt it before I go to bed, prompt it when I wake up in the morning, maybe between a meeting here and there, but really sort of minimal kind of work on my part. One thing that I will point out from a few years ago was this talk, or this paper from some folks at Stanford that created this world called Smallville. And so I don't know if anybody's seen this paper or not. It's really great. And basically they created this little world. They created spaces in there, and then they unleashed, I think, 25 agents to just and they gave them little personas, and the agents just started kind of wandering around, and they started doing all these things like meeting each other, talking to each other. I think they invited each other to coffee and have dates and things like that. And I remember reading this paper a couple of years ago, and I was like, that would, I think we could actually use that to like accelerate like the way we used to do these things, right? And it turns out you can. In the sort of data set that I created, we had these characters over here, they were like, opening PRs and kind of pinging each other on the status of PRs, and like, talking about, expenses and costs and things like that. And I didn't tell it to do any of that, right? It just said, hey, you're an IT manager, you're a finance person, you work at Pause, right? And so that was cool to see that come to life. And then, a big part of these things is just like standing up the infrastructure. And that was actually one of the things that I always did, because I had that silly stack of computers in my basement, right? And so it takes forever, right? It just takes a long time to stand these things up, even if you can try and use automation, but you just tell Claude, hey, here's my Proxmox stack, which is my open source hypervisor. All these people that are in this MD file, they need computers. And it went and said, okay, cool. I'll use Packer, and I'll set those up, and I'll join them all to the domain, and I'll even connect them up to Cribble and S3 and send your data into Databricks. I work at Databricks, and Databricks is a great place to send security data. So like, if anybody's interested in that, come by and see our booth tomorrow. But this was like literally took minutes, and it was like, okay, this is something that took me months and months. I won't say maybe it didn't take me months, but maybe felt like it. And there's like it's like super aware of like, hey, you told me to put that on a local disk, but don't you know you have, Dave, don't you know you have a NFS, NAS or something? Like, it's telling me all about my lab. I finally stopped and said, will you just please fix everything in my computer lab and document it? And it was like, yeah, you have a bad disk on that, and I'll log into your Unify network and fix that, document it, whatever. So I got a nicely documented lab out of the deal. This is sort of the agentic decision execution loop that it came up with, which is really cool. This is sort of this is the flow of how it said, okay, based on this scenario, we want to execute this. We want to execute this attack. Here's these personas. Here's how we're going to do that. And basically built all this for me with agentic engineering, if you will, vibe coding, and it worked really great. It cost me this part actually used the Claude SDK. Or excuse me, the Claude API, I should say. And so not my Claude Max subscription. So I think I spent like $80, just kind of like getting all this, going and working, which I thought was pretty great. Found lots of things all across the all across the MITRE ATT&CK framework. I think there's a little bit that's not on the screen there, but when we go and look at the telemetry, which is the important thing, right? Like it's there. There's stories to be told. There's connections. There's proper sort of parent-child relationships, and these are all things that are very difficult to get in good, like in security telemetry. It's easy to kind of replay telemetry, but it's hard to get all the events to sort of match up so that it stands up to like investigative scrutiny, which is the whole point of these things. So I was really pleased with that. Created lots of lots of different kind of data sources, a lot of Zeek in there. So I was happy to hear the Corelight folks talking today. Big fan. And so, you know, just in kind of some of these things, the compromised machine and all that, I would probably go back and add a few more data sources to this if I was making it something that I was, you know, not just trying to get done for a conference talk, but I was pretty happy with that, with very minimal sort of input. And the questions, so you know, I said, hey, now you have to write investigative questions about this, and it went through, and it did a great job. Actually, it did a bad job, and there was a bunch of questions that were either unanswerable, or they weren't sort of discrete answers, right? They were story problems, if you will, or essay questions, and not sort of a single answer, which is not really what we're going for. So we did a few rounds on that, but ultimately came up with some really great questions that I was really happy with. I won't dive into all those questions. This is a timeline, so I just had Claude, hey, go back and tell me how long it took to build this data set. And it said, hey, you know, you started, see if this works. I don't know if that'll work or not. Guess it won't work, but started on March 10th, kind of finished on like March 18th, again, not wall clock time, just sort of working, you know, from you know, 15-minute increments, if you will. Yeah, super happy with it. And now there's a few new things if anybody wants to check them out. There's a new data set, so you can go check out that data. It's called the pause scenario. It's in Echo Lake, is just this place in Colorado where I live. But there's a replay engine that'll replay that data to kind of wherever you want it to be. There's data sets. I also had it create like just a gigantic amount of of atomic red team tests, because I was doing that for something else. So if anybody finds that useful, and the bad actor stuff with all the questions and a lot of the diagrams and stuff is all there as well. And I think that's all I have to say. And I appreciate everybody coming, and I appreciate Leo for resurrecting the open source boss of the SOC data.
Yeah, I should be saying, thanking you. Like you gave a lot of fun to our team.
Yeah. Oh, and yeah, if anybody, it will be at the conference tomorrow. Databricks. We'll have a keynote tomorrow morning, and we'll have a booth for the first time in our history of Databricks. So we'd love to see everybody there.
So while I definitely have questions, as I'm probably our team, I'd say, is probably looking at this way more than we should. I don't know if anyone in the audience, any questions for Dave on what they're doing here?
Yeah, I don't have these sort of like these sort of like big important topics that you all seem to work on all day around, you know, the future and governance of AI and security. But this is more of a fun talk.
Yeah, I mean, this kind of looks like a digital twin of investigations. Have you thought about it from that concept?
Yeah.
And how would you extend it to make it fully rich?
Yeah, I mean, I think a lot of organizations use their own investigative data to do these kinds of things. I think one thing that we always like to do was say, hey, this is something that's completely synthetic, yet it's extremely realistic, and make it available, to kind of freely available, because it's really difficult, in my opinion and in my experience, it's like very difficult to take actual incident data from an organization and scrub it, because it's hard to know that you've done the whole thing, you know, that you've done a complete job. And so, you know, yes, I think that that model is really good, especially for internal usage, like thinking of a digital twin, or, you know, taking a some investigation, but like substituting in maybe a different attack or something at a certain point. Like, I think those are things that are like very straightforward and easy to do with the tooling that we have available today. And I also recognize like this is just like everybody has their moment of like, yeah, like this, I just did something useful with Claude Code and it's maybe not earth shattering to everybody in the room. But it's certainly a lot of fun. And I think it's just one small useful use case, I hope.
Okay, one more back here.
Yeah, I'm curious, where are the gaps as far as teaching investigation, or insofar as what would make this more relevant in industry, or yeah?
Yeah, the gaps, I think the gaps are like availability of data. And like, I think maybe one of the gaps is like, I don't think you could ever do boss of the SOC and not run into the fact that data is like from the old data sets from 8 years ago, it's everywhere. So I think availability of new data, maybe, and that's kind of the reason that I did this. I also think that maybe people don't they maybe don't train on like really good investigative techniques. So something like a Chris Sanders, level of like thinking about how do I really think about investigation? Like, what are the actual sort of like cognitive processes that a person goes through when they're doing that? I think those things are not probably emphasized enough. But also, I think a lot of this is going to be done by agents, and we need a lot of good data probably to help train those agents. So,
actually, yeah, maybe you just.
One question I have is we experiment with a lot of open source data sets, and one thing that we see occurring is that it's not realistic in the sense that the majority of the data that you see as a SOC is mostly benign behavior, right? It's all your and a small part of it is very much your attack. And so, as like a lab, like our biggest problem with generating any data set is matching that scale. Like being able to generate these massive amounts of normal-looking data is really hard, especially because there's a lot of privacy issues. So, like, have you guys thought about that? Like,
yeah. Well, and sorry, I have my AV issues, so I didn't maybe mention everything, but like background data generation, super hard to do. Sounds so simple, very, very hard to do. The way we used to do it, one of the things that contributed to that time is we would have people sit at a VM and act like, Mallory from finance or whatever, and just like surf around for 3 hours, right? And then we would replay that data. Now I could have agents, take on that persona and generate background data, and I plan to do that actually. Yeah, it's a great point.
And maybe a selfish one for my part while Don sets up here. So sorry. So maybe a perspective is, I don't know if you thought about regenerative. And so the context is, as often when you're doing evals, one of the rules of evals is you're supposed to throw them out, right? Like they go stale, as you pointed out. And what we've found, for example, success elsewhere is we'll actually find new threats online, and we'll actually regenerate we'll have fresh evals generated when we're doing certain ones. And so I'm kind of curious, like from a regenerative view of the evals, have you been thinking about like, when like new threats come to retrain it, or like, how are you thinking about regeneration?
Yeah, I feel like I have a superpower now with that. So like now I could just say like, hey, because there's a bunch of stuff in there that I could actually speed up by like making it a skill and make it really fast and just be like, hey, go read the news about, go read the news about the Striker attack and help me sort of emulate that, right? And I'm pretty confident now that I can like crank those out pretty fast. And so, yeah, I think that's the key, is just probably just more, but keeping the quality at a level that's high enough, right? That it's useful.
Yeah, I'm looking forward to playing with it. Great. So while Don's setting up, I will actually introduce Don. I'm not sure how many people here need Don to be introduced, but I will try. Don has done, as far as I can tell, everything in security, like crypto, binary program analysis, adversarial AI. I think misinformation with LLMs or something. Like, she's done a lot. And then last year, I've been learning, failing to learn to never disagree with her. So last year, she made a statement that basically red and blue are just going to get faster and faster, and it's going to happen faster than we expect. I thought she was wrong, and she was right. And so, as anyone who's tracking what's been happening, and like time to exploit and whatever, and the doomsday clock and everything. So I'm not actually sure what she's going to be talking about today, but I'm pretty sure I need to tell myself not to disagree with it. So with that,
thank you.
Do you have a microphone?
Let's swap.
Do I put this here?
Whatever. Would you rather hold it, or do you want it in?
So I don't have to. Okay. Hi everyone. Thanks a lot for being here. Thanks a lot for the intro. Yes. So I'm Zhang Sam from UC Berkeley, and I'm also faculty director of a campus-wide center called Berkeley Center for Responsible Decentralized Intelligence. And today I'll talk about towards building safe and secure agentic AI. Like Leo said, I work I have a lot of breadth in my work. This talk also have many slides. We'll see how many I'll get through. And so hope just people have fun. Okay, so I'm already excited about the fast advancement in frontier AI. And last year was called the Year of Agents. And this year, we do expect to see further explosive growth of agents. And with that, on the other hand, there's a broad spectrum of AI risks, as outlined in our recent reports, the International AI Safety Reports, that's supported by close to 30 countries and UN and so on. So overall, as we deploy AI, as we all know, I think here I won't preach to the choir, it's really important to consider the presence of attackers for many reasons. And this time the stake is even higher with AI. So with that, then it's important that we build safe and secure agentic AI. And for this goal here, there are two main different categories of issues that I wanted to talk about if I have time. The first part is how to build secure agentic AI. Essentially, how do we protect the agentic AI systems from being attacked by attackers? And then the second part is how to mitigate misuse, how we can actually, for example, mitigate misuse of AI by attackers, and in the landscape of cybersecurity, in particular looking at the impact of frontier AI on the landscape of cybersecurity. So first, let me just briefly talk about the first part, building secure agentic AI. So everybody is really excited about agentic AI systems. These systems, they can observe the environment, get feedback, and then reason, plan, and take actions. So when we talk about safety, actually, I want to contrast two parts. One is LLM at the model level, safety, and there's the safety security issues of the overall agentic systems. So given the interest of time, I won't have time to talk about at the model level, the safety security issues. You can, welcome to watch my iClear keynote last year on this, that just mainly focuses at the model level. And for this talk, I'll focus on the agentic AI, the overall system level. So when we talk about agents, I think now also people are more familiar with now that it's not about just one thing. Agentic AI has a very broad spectrum in terms of the design space with actually many different dimensions. So in our recent overview paper, we actually lay out the overall design space of agentic AI across many different dimensions: input trust level, access sensitivity, workflow automation level, memory tool, and many different levels. And the overall points here, in our overview paper, we show that as we increase the agent flexibility across these different dimensions, we also significantly increase the attack surface. Again, given interest of time, I won't go into the details there. You can check out our paper for more details. So what this indicates is, as we design and build agentic AI systems, we need to consider this broad attack surface and with different attack vectors and different security risks. So again, in our paper, we actually give a taxonomy for these different types of attack vectors and different threat models, and these will then result in different types of security risks in the agent and external environments. And all these essentially they lead to the key of the security goals for agentic AI, which includes in security we always talk about the CIA, confidentiality, integrity, and availability. And these, of course, they have their new instantiation and implication in the agentic AI space. And also I want to mention that there is one more that in particular that's important in agentic AI space that we call contextual security. So in this case, we want to ensure that the agent actions are aligned with user intent. Given the intelligence of the system, this is a particularly an important security goal in contrast to traditional software systems when we talk about security. So that's in our overview paper, as I mentioned, we lay out the agentic AI space in terms of the broad spectrum of the design space and also the taxonomy of attack vectors, threat models, and risks, and so on. So now the question is, what do we need to do to actually build secure agentic AI systems that are actually resilient against attacks? So in this case, to achieve this goal, here essentially I will talk about two main types of two main stages. One is for evaluation and risk assessment, and the other one is how we do defenses. So first, in order to build secure agentic AI systems, it's really important to actually build a systematic evaluation and risk assessment. And then, so this will help us to better understand the risk issues in any given agentic AI systems. And then we need to, of course, build defenses to protect against these risks and attacks and so on. So first, let me briefly talk about evaluation and risk assessment in agentic AI. And the goal here is that we want to build automatic red teaming for agentic AI. And again, so in our paper, we also lay out taxonomy for automatic red teaming in terms of the scope and the different setup. So the automatic red teaming can be for different types of target agents, coding agent, web agent, computer user agent, general assistant agent, and so on, including, for example, OpenClaw. And then there are different types of attack goals and security risks, like the CIA that I mentioned. And then there are different threat models depending on what the attacker has access to in terms of its knowledge, in terms of its level of control, and so on. And then for automatic red teaming, essentially there are several parts to that. One is that we need to understand what is the agent state space for the automatic red teaming, and then how attacker can affect the state transition through the attack actions across the attack surface, and then cause the agentic AI system to transition into an attack success state. And to drive all this automatic red teaming, what we develop is essentially an optimization loop, where we essentially have the system, the automatic red teaming system, to go through this optimization loop where it can generate attack candidates, and then we'll launch the attack and then evaluate the candidate in the system and collect the feedback, and then we can then update the attack generator to then continue to this continuous optimization loop. And the optimization methods can include different types of methods. Of course, the simplest is you can do some heuristic search-based, and then you can also do gradient-based updates, and also you can do reinforcement learning, RL. So in our work, and then overall we can also the automatic red teaming system itself can also be essentially agentic system itself as well. So that's essentially what we have done. So here are some examples of our work in this space, where we developed automatic red teaming system for different target agents with different attack methods that I mentioned that achieves a broad spectrum of different attack goals. And here are some examples. So leak agent is, so this actually is the first work using reinforcement learning for red teaming, where we're actually use reinforcement learning to build a red teaming agent for privacy leakage. So essentially, as what I mentioned earlier, through this RL loop, we can essentially automatically train and improve this red teaming agent, and in this particular case, to try to extract sensitive information from the model. And here are some examples where it's automatically then able to extract system prompts and also extract sensitive information from the training data as well. So that's RL-based automatic red teaming agent development. Here's another example. Essentially, also this is the first end-to-end red teaming of black box AI agents, in particular for example, prompt injection attacks and so on. So in this case, we use black box optimization. So people have heard about, for example, Alpha Evolve and so on. So this actually was, you can think of it as Alpha Evolve for red teaming for black box AI agents, although we actually did the work even before Alpha Evolve came out and so on. So this, again, attackers only has black box access and can only modify the environment through which the agent interacts with the environment. So for example, attacker can inject malicious inputs, data into the environment, and then when the agent reads the malicious data, agent, for example, can get prompt and injected and so on. But in this case, we developed this using black box optimization loop. We continuously to update essentially the generated attack candidates and leading to successful attacks. So for example, this is an example of a real-world web agent being successfully attacked using our system, where our system automatically, in the end, generates a malicious review on the product review website that includes the prompt injection attack. And then when an agent is performing a task for a user, for example, to try to search for product review to make a product recommendation, in this case for like Samsung Galaxy screen protector, then the agent actually, when the agent reads a malicious review, it gets prompt injected and then leads the agent to then visit attacker's malicious website and then download malware and so on. So that's agent virtue. So this is our most recent work, agent exploits. This is the first multi-agent system for automatic end-to-end red teaming, and in this case for white box attacks. Here we assume that the agent actually has access, access to the code of the agents. And in this case, with agent exploits, we have multiple agents. We have an analyzer agent, and then we have an exploiter agent. The analyzer agent uses various tools to analyze the targeted agent's code base and to identify the tools the target agent uses and the potential attack path. And then we have an exploiter agent that's then try to automatically generate potential attack inputs and also identify and then also has advanced techniques such as context-aware generation, multi-injection, collaboration. So when you combine this together, so this is an example of using our agentic system to find vulnerabilities and generate successful attacks automatically on open source coding agents. In this case, a GitHub issue resolving agents. So in this case, the analyzer agent examines the coding agent's code to examine the target agent's architecture, identify untrusted input sources, and also flag sensitive tools the target agent uses, and then maps the attack path where malicious data can be injected into a GitHub issue, and then when the target agent consumes this, it can then be attacked and then leading to the target agent to run certain malicious code injected by the attack and achieve the attack goal. And so that's the attack path. And the exploiter agents then takes this attack path and try to generate then candidate attack inputs given the context and so on, and then leading and then generating a successful attack that can cause the then can cause the target agents to then take malicious actions. So these are the different automatic red teaming that's methods that we have developed. So I wanted to also briefly mention that we have been now running a competition. So as some of you may know, I have been running this MOOC, Massive Open Online Course on Agentic.AI. We have around 40,000 enrolled globally and so on. And in conjunction with the MOOC, we actually have been running a competition called the Agent Beats competition, which actually focuses on agent evaluation. And we have many thousands have been participating in the competition globally and so on. And one of the tracks is actually on Agentic.AI safety and security. So the competition is actually now ongoing, and we hope that people can help can help spread the word and have more people join the competition. So that's the first part on the evaluation and risk assessment. And of course, then defense is, as we understand and discover vulnerabilities for agentic AI systems, also it's important to develop effective defenses. And there's no one single silver bullet for effective agentic AI defense. What we need is defense in depth, and also following the general defense best practice. For example, with least privilege, privilege separation, safe by design, secure by design, and ideally develop privileged secure systems and so on. So again, in our overview paper, we actually have provided also a comprehensive study analysis of the overall agent defense space. And given the interest of time, I won't have time to go into it. I wanted to just briefly mention one of our recent work called the Project, which is a programmable privilege control and guardrail for agents. And it's the first work that actually enables this programmable privilege control with contextual security. So in this case, the Project actually monitors the agent behaviors, for example, tool calls, and also sees the user requests and so on. It then actually dynamically generates policies. So given that a general agent may have a lot of privileges, given that I need to do a lot of different tasks, but once the user provides a specific task, then for the agent that actually needs to execute this task, actually doesn't need that many privileges. So ideally, you want this agent to then have the least privilege that's needed to execute a particular task. So this is what we do with this with Project, is that we dynamically generate these policies to reduce the privileges that's needed by the agent, and then hence to enable contextual security with least privilege. So that's the first part of building secure agentic AI. I think Leo is showing that I don't have much time left. I'll just briefly mention. So the second part is how we can mitigate misuse. In particular, try to understand the impact of frontier AI on the landscape of cybersecurity. So the part I really want to talk about is we have been developing these benchmarks to really evaluate the the fast progress of AI, frontier AI capabilities in cybersecurity. So here I'll just give a couple examples. One is our work on Bounty Bench, where we developed a benchmark with essentially for web applications. These are from real-world bug bounties, and that covers essentially most of the OWASP top 10 risks and so on. And then the question here is, so we gave the benchmark to the bounty task to agents. The question is whether agents can actually detect vulnerabilities, exploit them, and generate patches. And our work showed that, AI is moving really fast. So this result is from last year. Even for last year, the agent was already able to solve many of the real-world bounty tasks and was able to essentially claim bounties worth of tens of thousands of dollars. So essentially, you can use your AI agents to actually make money by solving these bounty tasks. And now I think it will be even, the capability is even stronger as what another of our benchmark shows. So another benchmark is CyberGym, which contains close to 200 large-scale, widely distributed open source software with over 1,500 previous known vulnerabilities. And we give the agent task to essentially two types of tasks. One is to identify previously known vulnerabilities, and the other one is to find 0 days. So with our work, we show that, again, some of the numbers is from last year, and we have some of the latest results here as well. So basically what you can see is essentially there is a straight line going up in terms of, one is the success rate for agents to find, to discover previously known vulnerabilities and also generate POCs, proof of concepts. So these are inputs that can actually trigger the vulnerability. And the other dimension is to find 0 days. So our work showed that the agents can also find 0 days previously unknown vulnerabilities in this large-scale, widely distributed open source software. And again, they have been, the capability has just been going up, yes, with really fast rates. And our work has been included in the system card for many actually Frontier AI Labs latest model release. This is an example from Anthropic's model release, and in the latest Opus 4.6, it's also included there as well. So with that, I think the question is, what can we do? And also, I think the challenge here is that given the natural asymmetry between attacks and defense, it's not sufficient to just have AI, to just rely on AI finding vulnerabilities and hoping that defenders can patch the vulnerabilities before attackers. So with that, we have launched this, we call Frontier AI Cybersecurity Observatory as a central place to that we have collected the various AI in cybersecurity benchmarks. We hope this can be a central place for the community to come together to to continue to monitor AI capabilities in cybersecurity. And also in terms of defenses, I do strongly believe that we hope the best solution is to use AI to help us develop secure by design, safe by design systems that's actually provably secure. And in particular, as we all know, that the holy grail is if we have formally verified systems, but these are largely labor intensive. My group has been among the earliest to use deep learning for theorem proving. So this actually is a paper with Ilya from OpenAI back then, like 7, 8 years ago, which even back then we showed that deep learning is can be effective for help automating certain steps in theorem proving. So now with Frontier AI, this is our recent paper where we laid out a roadmap to show that now we are hitting an inflection point where we can really use Frontier AI to help advance and automate formal mathematical reasoning and theorem proving. And we hope that using this approach, we can, instead of just generating code, we can actually generate both the code and also the verification for the code to, in the end, to be able to generate provably secure code. So, so towards that goal, we have been developing techniques and also comprehensive benchmarks on verifiable code generation. So Verina is an example of a first of its kind for comprehensive benchmark on verifiable code generation, where the benchmark includes the evaluation for both performance for models generating the code and generating the spec, and also generating the proof that the code satisfies the specs. And the model's capability on proof generation actually has been limited, but however, with the recent advancements in some of these new models focus on formal mathematical reasoning and theorem proving, there has been huge increase in this as well. So with that, I hope you have learned some information about both the two sides, building both for building secure agentic AI and also for how we can try to mitigate misuse. So with that, I just want to conclude with, so as I mentioned, I'm a faculty director of a campus-wide center called Berkeley RDI, Berkeley Center for Responsible Decentralized Intelligence. And for example, the MOOC and the competition that I mentioned all has been hosted by Berkeley RDI. And last year, we hosted the Agentic AI Summit at Berkeley with over 2,000 in-person attendees and over 40,000 joined online. And this year, we are hosting it at Berkeley again. And we expect over 5,000 in-person attendees and hundreds to join online and so on. So we have a call for, call for talk proposals online. And so we welcome you to both sign up for the summit. The registration, early bird registration is ongoing, which will end very soon. And you can submit your speaker application online as well. And also late last fall, we also organized a workshop on Frontier AI in cybersecurity, risks and opportunities, where we had over 5,000 joined online. So for more information, you can check out the workshop recording as well. I talked about the MOOC, and I hope that you can join the competition as well. Right. With that, thanks everyone.
Do we have any questions for Don? Maybe I can kick one off. So now you've done both the red and the blue. So for folks building harnesses, which is some of the people here, if you were going to just pick like one or two areas that, hey, this is the defensive technique for building an agent, like, and especially like a full-blown agent that you think would be best areas to focus on, right? Where would you encourage folks to, like, which defense, like you were talking about defense in depth for hardening agents. Which methodology or what would you recommend people to focus most on?
I see. Okay, that's a very good question. So essentially, as I mentioned, there's no single silver bullet for effective defense. We really need defense in depth. So I think as you build agents, it's really important to think about to take this defense in depth approach. And also, I would say agent architecture with security architecture is really important. So that's why we talk about, for example, privilege separation. So essentially how you actually architect your agent to essentially limit the, for example, both for least privilege principles and so on, And of course, some work that I mentioned that these, for example, Progen and so on can help you to dynamically enable this privilege as well.
Do we have any more questions for Don? Jaime, let me give you a...
So do you think there will be, I mean, what is your thinking around as models get better, will there be a point where like prompt injection safety will be part of the model, or what are your thoughts around that?
That's a very good that's a very good question. So certainly yes, I think as model gets better, certainly it can be helpful as well. So there's a work that I didn't get to talk about. So in our recent work called the Prompt Armor, we actually showed that you can use this model to try to essentially observe the target model's behaviors, and then you can try to detect, for example, whether both the inputs and outputs to try to detect prompt injection attacks. So it's very interesting that like our work showed that if you just use the model itself directly, the prompt injection attack can actually succeed. But if you use another model, or even the same model, if you let it reflect and see whether there's attack happening, it actually can detect the attack. So essentially these models with their reasoning capabilities and so on, so they are improving in their understanding of the prompt injection. So when we compare different models, so certainly the later models, more capable models, and also I think they have been probably fine-tuned with post-trained with this type of data and so on as well. So yes, the capability has been improving.
Oh, great. So Victor?
Yeah, thank you, Professor Song. And then my question is actually quite practical regarding to the guardrail problem you mentioned, right? So, so when we do like for example, we asked recently like the GPT-5, the latest model, hey, can you write exploit POC for a DeFi? It stopped answering for those questions. So how does your team? I mean, I'm sure like when you deal with CVEs and all these exploits and all that, you have to deal with that problem a lot, right? So what's your best practice on bypassing the guardrail for that?
That is a very good question. For the latest model, we experienced that as well. So when you run that on the benchmark, actually, I mean a percentage fails. So, but I think although the issue is that, of course, you can do jailbreak and so on. So attackers, it's always, right, there's a cat and mouse game. So attackers can do jailbreak. It can also decompose the problem into different sub-problems and so on to try to bypass. But yes, I think it's, on one hand, it is nice to see that these models put more of these safety guardrails in, but on the other hand, it does make other, maybe some security researchers are white hat researchers want to use a model to do their legitimate work. I think the challenge is that maybe these people then they can't do their legitimate work, but attackers can still do jailbreak. So I think there are still challenges. But yeah, thanks. Very, very, very good question. Yeah, yes, absolutely. We have seen that.
I have a follow-up on that then.
Okay.
Have you been exploring ablating models to disable their safeguards? I've seen some papers coming out about new tools that basically disable the safety circuits of AI models for anything that's transformer based. Have you played with any of those new techniques such as Heretic and a few of the others?
I see. So I mean, so first of all, if you talk about open weight models, then in general, you don't even need very complicated, sophisticated techniques. I mean, there has been work showing, right? Even if you just fine tune these open weight models a little bit, then they actually lose their alignment and so on. So overall, it is very challenging to try to protect these open weight models from their alignment being removed. We have some joint work with other collaborators try to harden these open models, but overall it's like still open challenge.
All right. Well, thank you, Don. That was always fun. So we're about to have lunch. For folks online and also for folks here, we're also going to be doing a tutorial. I think we'll be doing like graph modeling for whether you're doing investigation or you're doing graph modeling that feeds into AI detection models. I think there might be some GPU stuff there. So grab lunch, come back, and yeah. And actually, I think Sunderea has something to say.
Yeah, so I'm not going to be the guy standing between you and lunch because I know that's hard to be. But so a little teaser on what we're going to do. This is basically an extension of a talk I did back in 2024 based on work I did working for Norwegian National Police investigating ransomware groups. So we got access to a bunch of Cobalt Strike data. So this is based on a data set where we're actually looking at how an attacker or the attackers infiltrated and traversed the network. So we're going to look at that as graphs. So grab some lunch, come back if you want to look at that.
He's on his way. Okay, shit. There's not in this room for two computers.
Was microphone dropping off?
Yeah, we're starting out. So, my name, Sunderea, coming out of Norway, and with me, Manfred.
Yep, my name is Manfred. I am a visualization engineer working for Graphistry, and also you may have seen me taking pictures for this event today. So, hello.
So yeah, what we're gonna do, we're gonna go over basically investigating a real ransomware group in a sort of like a step-by-step guide. It's not like we don't have time to go all the way down into it, but we'll touch a little bit on it. So my background being a police officer and investigator, I'm going to also talk about like how you can incorporate investigative methodology and thought into actually doing work with data. So if any of you have been to Graph the Planet or viewed Graph the Planet before, you might know John Lambert and his famous quote on why graphs matter, that attackers think in graphs and defenders think in lists, and as long as that is true, attackers will always win. So Cobalt Strike and the tool we're going to look at, it's basically graph-based. So what we're going to look at, we're looking at a ransomware group from the early 2020s, how they operated. So the data set, it's anonymized data based on a real group. So I've basically redacted everything that could lead back to any victim here. So that's yeah. And as I said, this is a extension of a talk I did back in 2024 together with my old colleagues. It's on YouTube, so you can watch that and how we went about investigating these groups. So we're going to look at it using some of the investigative mindset and also interrogation methodology. So if any of you have been looking at data before, the best way to approach it when you're trying to find answers in your data is to build hypotheses. If you don't have any hypothesis of what you're looking for, you're just like fumbling around in the dark. So you build your hypotheses, you identify your information needs, you start gathering information, and you tie that information to your hypotheses and decide, does it strengthen or weaken my hypothesis? So the interrogation methodology is basically to avoid confirmation bias, which is a big problem. You should start openly, like, okay, so let's describe what happened, get an overview. And then you go further down the funnel is basically ask more direct questions, describe this part of the problem a little bit better, or enrich your data. And the bottom of the funnel is basically confrontational, where you basically start up asking yes or no questions, closed questions. So going down the funnel for every question, every hypothesis, information need, you basically at the end have a scoring system where you say, okay, this is what likely happened here. So you're just repeating this for every new topic you're investigating.
Yeah, and so we're using this data set as an illustrative example for what we also want to teach you, which is how to apply graphs to data sets in general. I mean, graphs, actually, show of hands here, how many people know something about graphs? Apply them? Cool, all right, cool. So stay relatively low level then. Okay, so yeah, so we're going to walk through each one of these things to teach you first how to, transform your data set from a form which may not necessarily be entirely conducive to graphs, even though it's relational, into a node list and an edge list. Second thing, touch on using hypergraphs, when to use them, when not to use them, what's their downfalls to using them. Third, how to pick useful node encodings, edge encodings. There's a little bit of psychology, visual science to this, which is kind of neat. And also how to handle time and graph data, graph querying, and the graph querying will let you interrogate your data set much more easily. It'll let you visually, basically, instead of running SQL queries, you have a visual representation of everything. And finally, considerations when applying graphs to large data sets. So again, the idea is that you should be able to take this and then go home with it and put it on your own data, and we're going to use a security data set, but I mean, it could be anything. It could be social, it could be fraud, it could be any relational data.
So yeah, how to follow along or try later. So sign up for hub.graphistry.com or one of these two servers. These two servers will stay up for a little bit of while. And also go into our Graphistry community Slack tutorials, and you will, there's a thread there where people can request access to the dataset and the notebook. We will probably post it on GitHub later on, but for the starter, it will be right there. So the dataset, as I mentioned, it's anonymized Cobalt Strike events taken from a real ransomware group. What happened is basically the Norwegian police, in collaboration with a lot of other law enforcement agencies, were able to get a hold of a lot of command and control servers that had Cobalt Strike on them. And basically, Cobalt Strike is a red team tool. It's super awesome. It's point and click and you hack, basically. So it stores a lot of information as well, because it creates beacons. So you have a server communicating with a beacon, sending a task. So you have a natural graph showing how things are connected. So the data set we have is a small subset. It's basically one victim anonymized. It contains 34,000 rows. There's the duplicates there because of duplication across C2 servers, but when you dedupe it, it's basically 9,000 events or so. So it's built up of a IP timestamp. The CS data column is basically the raw command being sent. So we're going to start in the top of the funnel is basically overview. So we're starting by going, hey, let's see from the C2 server, the team server IP, go to the public IP for any victim and look at what that gives us. So that's basically the open question overview.
Yeah, so can you put a few more? Yeah, so first thing we need to do is we need to take that data set, which that data set is not something like a network log where you can just map from IP to IP. This one needs to be treated a bit differently. So we want to stay high level. So what's the most high level thing we can do? We can try to take the IPs of which represent individual command control servers, and we can try to find out which organizations they're trying to hit. And so the easiest way we can do that is we assume that these C2 servers will be hitting computers behind an external IP. So we aggregate on that. And next one. And so in this representation, the existence of any logs between a team server and a public IP is represented by an edge. And here you see a simple example of that relationship. So now we have a very, very simple graph, which is hopefully quite easy to interpret. Anyone want to have a guess on what's happening here? No. Okay, so so here you've got three C2 servers. The ones in red, blue, two separate networks. So even though this is a relatively simple graph, you can actually draw some conclusions from this even. So you notice that there's a node at the bottom that's connected to two different networks, one with one host, one with 142. So what do you think the role of that C2 server is? Yeah, initial access. Try to get in, explore, all that stuff. And so if it looked at the one host network and it said, it's not that interesting, so let's move on. But then it saw the 142 host one. It's okay, so there's something here. So let's throw more C2 servers at it, which probably have different roles or whatever. So my point is, even with a graph this simple, you can immediately start drawing conclusions from it.
So yeah, that was like the overview. This is the image you can go to your boss and say like, hey, something happened on our network. We haven't gone deep into the investigation yet, but we see communications with 3 servers across our network.
Yeah, but is there anything else that we can learn from this graph with our data? Probably not, right? So what do we do now? So the solution is to reformulate our graph, to expand it, change it, so that we can answer other questions. So that's exactly what we'll do now.
Yeah, so this is basically moving down the funnel, because now we've been looking at the overview. We start like, oh, we're not seeing the full picture by just looking at IP to IP. There has to be something else. Oh, the data set contains also private IPs. Maybe we need to go and start from team server to private IP, or team server to a beacon ID. So expanding the graph to see more. So this is what we're doing now.
Yeah, so what's the easiest way we can do to, we've got these individual nodes representing entire networks. So now we want to expand that. We want to look inside these networks and see what's actually happening. So one way we can do that is to instead map the C2 servers to the private IPs. And the private IPs will be the individual hosts inside that network. So now we've changed the definition of a node. So now it represents a server, database, domain controller, exchange, or team servers. These are all different servers inside this network, and we construct it by aggregating rows of events by those. And so now the definition of an edge is the existence of any logs between a team server and a private IP, whereas before it was a team server and a public IP. Next one. Okay, so now we have this much more interesting graph. So first detour. So on visual encodings, that color encoding, anyone see anything wrong with it? It's a bit hard to read, isn't it? Yeah, there's some white nodes and there's pink, but they look sort of close. So first detour. So, when you're thinking about node or color encodings in general, it's useful to think of it in terms of hue, saturation, lightness, because that's how a human eye perceives color. So you'd probably, in this case, we're dealing with categorical data, would probably want to maximize the difference in hue, saturation, or lightness, and probably just pick one of those so that you can get the maximum intelligibility between any of them. And so in this case, we've got the pink and the white. We're just changing lightness a little bit, and that's not great. Yeah. So moving on to the graph. So now we see this graph. Cool. Great, but we don't actually know what's happening. We see the network, but we don't know what's happening. So let's move on. So now we're color encoding by the roles. Okay. So now you can see more detail. You can see which hosts are connecting to what, and that's useful because now that you've got all these server roles, if you're a team server, which host do you think you want to hit first, right? Or which ones do you think you want to get into? It's probably the domain controller, right? So it'll be interesting to watch for that, to be able to see how these team servers, try to work their way in. So this is great, but we also lost information. So before the previous graph that we had color encodings mapped to public IP, so you know which network's part of what. Now that it's all jumbled together. So we just lost information. Is there a way to have both? The answer is yes. And the way to do that is to introduce hyper edges. So congratulations, if you understand this, you understand hypergraphs-ish a bit. The technical definition of that is just an edge that maps, that connects to multiple nodes at once. But I mean, the best way to think about this here is just we've added an edges, the teal ones, which correspond to public IP, and now we're connecting nodes to that one if it belongs to that public IP. or if it has that. So now we're mapping both of these sets of information on the same graph. So you have now more information. And some notes about using hypergraphs. It tends to cause more visual noise. I mean, you can see it's a bit of a busier graph now. So in this case, it's not that bad, but that could become an issue if you've got bigger graphs, messier graphs. So you want to be careful with using it that way. It's also harder to comprehend, especially if there's multiple types of hyperedges. And also, in this case, we've got one edge connecting the hypergraph to each node. And this is just a representation that we have because we're doing hypergraphs on a more conventional graph renderer. That being said, if you've got a massive graph, then that means that if you add a hyperedge, you're going to massively pump up your number of edges. And that has problems computationally. So just some caveats, but it is a powerful tool.
Yeah, and that's like when you get started with graphs, it's quite easy to be like, oh, cool, everything is a node. And everyone that starts with graphs, they're basically going to hit this at some point where they made everything into a node, and suddenly you've gone too far. So that trying to understand like what should be a node, what should be a property, that gives you that idea of like, okay, this is a useful graph, this is not a useful graph. So beware of the super nodes, basically.
Okay, so now we know a lot about the structure of this network. So we know which computers are what and what belongs to what network. But we still don't really know what's going on, like how exactly this attack progressed. And so we've got more information available to us that we can use to figure that out. And yep, keep going. So we can use time. So we can use time to try to link sequences of events and again, understand what happened. So great. So what I've done here is I've taken the same node color encodings, but now we've added edge color encodings. So in this case, before we were using colors categorically, but now we're using it as a continual spectrum. So we're mapping edges represent like first seen, and we're going from oldest to newest, and oldest newest being mapped to red to yellow to green. So the red ones are the ones which are the oldest, the first.
Yeah, basically the initial access.
Yeah. So based on that graph, you can probably see where the initial access happened, right? I mean, first of all, you can see which C server is the initial access server. That's the same one that we pointed out connected to two different networks. So that confirmed our hypothesis. That's great. And then we can see how it's slowly spread out among the network, which is also neat. That being said, there is an issue, slight issue with using edge color encodings this way. We just wiped out our previous edge color encodings. So color encodings are very, very flexible, but at the same time, they are, we can't throw everything onto it. You're going to overload that, and that means that it's going to be a lot more difficult to comprehend your graph, understand your graph, and interpret it. Right. So we don't want to lose information again. So what do we do this time? We encode time as an animated graph, so that we can use edge color encodings for something else. And so here's a demo of what happens if you try that. Let me do this one.
So yeah, go a little bit back. Starting off, we're playing this as a live video. Hopefully you're seeing it good. So it moves across the entire network from one C2 server onto the beacons and nodes, and suddenly you see there's a lot more activity happening. So at some point they got hold of something or some access that made them able to traverse the network. And we'll go a little bit into that later on and see like they're working a little bit, taking some time off, staying cool. And when we go into the data after, I'll show you a little bit of why that's happening. because at some point here, they're doing a dump of the Active Directory and getting the hashes and getting tokens and cracking passwords behind the scenes. And suddenly they have the passwords for the domain admin. And this is what's happening now. They got access. Now they are in full control of, and can do whatever they want on this, this network. So cool. What else we're not getting here? And yeah, go Manfred.
Yeah. Okay, so now we know roughly what's happened in this graph. So the next question is, can we get some actionable information out of this? So can we extract a kill chain from this network so we can more precisely understand what's happened, pinpoint the problem, fix it? Yeah, we found some new interesting things from that animated network graph, right? We found out that, well, we confirmed our suspicions that 198.51.100.10 was our initial access team server. And we found out, you saw at the end, there was a big explosion of purple where it suddenly, hit all of the servers at once and dumped the data, right? So we found out that the cluster of nodes around 100.30 at the top there seems to be the final targets of interest. So let's see if we can use graph query algorithms to find what path they may have traversed. And this is going to be a hypothetical scenario, but we'll continue with that. So this is using collections in Graphistry, but in general, what we're doing is we're taking subgraphs and we're highlighting them on the graph, and then we're able to use color encodings to compare the different subgraphs, see how they differ, and hopefully we get some interesting information out of that. So the first one is just the initial access team server. Simple subgraph is just the 100.1.10, sorry. But we can move on to more interesting ones. So this one is just seeing if there's any path, forward-moving path. Edges are directional, or they can be directional. So we're just following the edge in the forward direction between the initial access server and we picked a random node in that cluster over there. So in this case, there seems to be a path. It's going through a handful of nodes on the right-hand side and it's jumping to that one yellow one on the left down to the bottom right. And the bottom right on this side, whoops. Oh, okay.
I'm not sure what that is.
Maybe you can make that go away.
Yeah.
Talking to the
Yeah. And it's not on my end, it's on this computer's end.
Let me go grab
Oh, it should be good.
Okay, cool. Yes. So this node here is the one that we did the greedy pathing to. So we found the path for that. Let's try with another one. Try to this one. So same nodes firing, right? Except the only difference between the two subgraphs here, and we did that by just like overwriting the color of the previous one, is this node stayed yellow because that's the one we were interested in before, and this one turned green. So if we find the intersection of that, we'll find that all these nodes here are in common. And so if we wanted to break access to all these computers, this was a problem, right?
So yeah, moving further down the funnel. Like now we've been looking at some stuff, but we've not been looking at the raw data yet, like the raw logs of what the actual commands are, because in this picture, there's a lot happening behind the scenes. And that's generally also the logs you're seeing on the defender end, what's happening in your network. Like the command's been run from the white blob in the center here going out. It's like it's nmap, it's network scans, it's basically, it's tasking the computer to do something on its end on the logs. And when we do that, we can go even deeper. So given that you have a raw data log, you can start to extract information like, okay, it targets IP like VMIC, node, port scans, PSXEC, stuff like that. So you can extract new targets that it's attacking based on the logs for the node. These are not direct communication paths because they're living off the land, basically. So they're using the computer that they have like a reverse shell on to run new commands and expand their attack path, and then spread files and upload files and download files and use credentials, dump credentials, and stuff like that. So this is like going another level down the funnel where you add more nodes and more edges. So I'll go with that. I'll jump over here and we'll try, if the demo gods allow us, we'll run through every step we've done now in this notebook. So basically first, to do this, you need an account on Graphistry, of course, because we're using Graphistry to visualize it. And I have this subgraph demo dataset. So I'm loading that one. 8,800 events, 142 hosts, and 210 beacons. So basically, a couple of the hosts we have here have multiple beacons on them. And a beacon is basically a reverse shell talking to a server, like a command and control server. So going down the funnel, so let's look at the simple approach. Basically, my first graph on this. So you have your data set, you have your head. We're deciding that we're going to go from team server IP to public IP without doing any other than going like, okay, cool, look at all the events, make a graph, and see what happens. So what is different on this one than the first one we saw is we did not aggregate the number of hosts and group them. So we basically would get all the edges going between 5 nodes. It's the same, it's the same image, but a little bit different. So doing that, adding more overview to it, the same data, and we're adding some color encodings on it, as Manfred talked about, and we get this one, as we saw earlier on. And on this, we have the dates, first in, last in, so we can use that to filter and go into data tables, search, and time bar. And so the second level, or the second step, is basically adding more information, as I said. So now we're mapping it from the team server to the host. Getting more nodes, adding some coloring on what type of host it is, what type of role we're having, and we're plotting that. So now I'll go big. But so basically what we have here now is the edge between them. You have the edge type. This is a PSXEC command being sent from the server we saw out to this, and it's running that and returning data. The deep dive here, as I said, is basically going and looking at the raw commands. So extracting that as well, we get a lot more. We get a new node type, which is basically a target IP, because we're extracting IPs from the commands. Like if it's tasked to run a network scan, we're mapping out all the nodes that's also part of that network. So you get a lot more information on this. Because you also get the targets, and you get, if it's opening, yeah. So basically, the command being run is make token ABC blah blah and the redacted password. So it's creating access and on new devices. So it doesn't set up a new path to the team server. It basically creates from living off the land basically on the device. And we have a fourth level where we're going like super, super granular. It's basically going for beacon host IPs all the way. And I'm going to go a little bit fast on this because we're getting close to the hour. And this is where you're getting a lot more information and nodes in your graph. And we'll center on it. And you're starting to see, oh, hubs are forming here, because now we've gone and added that we're going from the C2 server to a beacon, basically, which is the reverse shell. And the reverse shells, we can go one hop out on this one. So when we're expanding, one hop, two hops, three hops, and we're touching everything, just going 3 hops out. So we're getting close to the end here, and Leo is going to come in after and talk a lot more on both AI and graphs. But I would like, if you want to do this, we do also like Graphistry is based on Rapids behind the scenes, which is basically GPU-powered data frames, so you get a lot of speed. So you can run a lot of algorithms on graphs, like using Graphistry, that has a significant speed up. And I'll try to show you, given that this is a small data set, it's probably not going to be that impressive, but we shall see. If the demo gods are on my side. Yeah. I got kicked out of the internet. So yeah, unfortunately. We should see if this happens or if this works again.
It's not updating.
Yeah. We shall see. Yeah, I got kicked out of the Wi-Fi, so I'll try to get back in.
I lost the screen.
Yeah. Now we're good. Okay, so yeah, basically, yeah, moving this to GPU. Instead of using pandas, basically you do QDF, read the CSV file, you're on GPU. Yay. And now we created a new data frame, basically, and it is similar. So we'll use that. I'll reuse the I'll reuse the graph we created and in step 4 to run PageRank on a CPU. So I'll create the GPU one based on this, and we'll time it on the CPU. So the same thing, it's like 700 milliseconds versus 142 milliseconds. And this is a very small data set, but if you have bigger ones, yeah, there's a huge speed up. And Leo is going to talk about that later on today by using GFQL, our graph query language, which also runs on GPU, and he'll show you some of the speed ups that you get. So yeah, questions? Oh yeah. Sorry.
Yeah, so I'm just going to run through these very quickly, but I want to show that, you know, as I said earlier, graphs are applicable to many different fields. So here you can see this is social network. This is an interesting one where, you know, red is like users checking into a geo-social network, and like blue represents average location. So, I mean, you can see, and also blue edges represent friends, so people, edges traveling between the average locations of the users. So you can sort of see how people make friends across the world just with this one picture. I mean, it says a lot, I think. Moving on. This one is mapping out the amount of research that they did on COVID versus, you know, the entire human things that are either proteins or are there genes or whatever. I don't know enough about biology to really dig deep into it, but it just goes to show that we've done a lot of research on on COVID and linked it to a lot of different things we know about the human body. The third thing, this is just a cool one. It's financial fraud. So these purple lines represent flows of money which have been reported, or at least they think it's fraud. So you can sort of see how money moves from certain countries or even certain cities to other ones, depending, and you can probably guess what the usual suspects might be. I mean, there it is. All right, sorry. Okay, so conclusions. So the one thing I want everyone to get out of this is that a graph is a great solution, but you have to design your graph to get the answers you want. It's not just going to fall out because you put it in a graph, right? Again, as I said at the beginning, you have to interrogate your data. If you want to get answers out of your graph, ask it a question. And you ask it a question by making good decisions when it comes to mapping your data to the nodes and the edges, and as well after that, making good decisions with picking and choosing your node encodings, edge encodings, etc. So you have to be very intentional with everything because you're using a picture to communicate every single pixel is valuable. Like everything on your graph has to mean something. It has to contribute to answering the question you have about your data. As I mentioned, balance information density with visual clarity. This is especially a problem with complex data sets or big graphs or both. Sometimes, yeah, you need to have a lot of information in your graph to answer your question, but at the same time, it turns into a mess. You can't answer anything. So you need to, there's a balancing point between those two you need to find. And I mean, you can try to be clever with trying to optimize the space you have with optimizing encodings. Like, for example, one trick that I like to use is if you've got many edges traveling from one to another, as you saw in the social network one, you can set the opacity down. So now you're depending on the additive blending of the renderer. And by the way, I'm the one who works on renders in Graphistry to encode data. So the more opaque it is, the more nodes there are in that space. So you can be clever about that. Information dense graphs work best when distributed among many possible encodings. Again, like I mentioned, don't overflow your color encodings. You can make it mean a lot. You can even try to be clever and try to use both hue, saturation, and lightness to represent 3 different things at the same time. That is almost never a good idea. If you've got a way to represent dimensions in any other ways, like you can try to take advantage of hypergraphs. You can try to, if it's time, you can stick it in an animated graph. If it's geospatial, you saw a little bit of that for the fraud one. You can try to fix the node positions on a geographical map. Actually, I find that if you've got a large geospatial data set, that could really improve the readability by a lot because you're no longer just trying to depend on raw physics to like make everything work. You're actually using, it actually starts to mean something positions. Yeah.
So yeah.
One more.
Yeah.
Finally, final slide. Fourth thing, end things. If a graph does not answer your question, reformulate it by reshaping it, revisiting encodings, try again, maybe you have not found the optimal balance point between all the things you need to show. So, try playing with it more. It often can, pay off because as you've seen through the presentation, you can change a lot about what you can learn about a graph just by changing how you're encoding things. And final two, for insights in complex graphs, try extracting subgraphs and then doing the subgraph comparison as you saw in the subgraph demo, and with large graphs, and this is the last thing. Both your computational budget, so how many nodes and edge you can render, and your visual comprehensibility budget, which I'm going to use that word as in you can only understand so much information in front of your eyes at one time. Both of those are stressed to the max. And one interesting point here is that even if you fix the computational budget problem, like let's say you've got an amazing render, that does not fix everything. You've still got the other half of the problem to deal with, which, I mean, you can even argue is the more important part. So it is important to make sure that every decision that you make is every node edge graph encoding that you put on the screen is as impactful and useful as possible. So to close off, as you can see here, hopefully, Graphistry, I mean, graphing is a science, but it's also an art. And so, I mean, it's the name Graphistry that was recognized even 10 years ago, but it's definitely still true now.
Yeah, I don't think we have time for questions, unfortunately. You do?
Oh, cool. All right.
Oh, awesome. Great. Yeah. Got awesome. Get in.
Mike? Oh, sorry. Here.
Yeah, my question is more on kind of that last point you had around just the human kind of brain being able to process large graphs and what your perspective is on using depth and distance. So three-dimensional graphs versus two-dimensional being a little bit more for better for analysis or worse or just any perspective.
That's a good question. So I've played around with 3D graph renders a little bit. I find that as a general tool, it is not very. It doesn't really improve things very much because now you're introducing more complexity. Let's say we didn't talk about size encodings, but you can have node encodings. You can have information encoded in the size of the node. Now, if you've got a 3D graph, is it bigger because it's further away? Or is it bigger because it's closer to you, or is it bigger because it's a bigger node? And so you need to find a way to deal with that problem. And as well, I mean, there aren't that many good graph renders for 3D. That doesn't help any. So I've seen use cases for it. I've seen use cases for it, and I've seen things implemented in 3D well, but I'd say it's an exception, not the rule.
Any others? Yeah, I have another question.
Okay, go.
So I thought the data set was really interesting. I don't know if you guys have ever looked at like Kestrel Lang and kind of these hunting languages in Python, but I'm curious if you looked at how to merge multiple other data sets together with that, like as you dug deeper in that investigative funnel, say EDR data might loop into that and how that might look in a shared graph context.
What you could do is basically one way to build out your graph is basically edge list is a nodes list basically. So you can append stuff and add more edges to your graph and tag it basically. Oh, this is my EDR data. It's communicating, and build out your graph programmatically down, like having a Python Jupyter notebook, add more data. That's thumbs up. I've done that a lot. So it's basically, as you mentioned, doing an investigation and using graphs. And if you're a SOC or EDR or whatever, and in my opinion, you normally want to start like, okay, what are the entities here? User, device, and you have an alert hitting a user. Okay, what device is that user on? Okay, cool. Now we're grabbing more information on that device, building our graph, and having like the entities as the source, and knowing how many windows we need to protect, basically.
Cool, thanks.
Yeah. Simon, he's coming with the microphone for you.
Thank you. Just curious, like in terms of like the statistical methods of like centrality and things like that you can apply to analyze it. What do you think of those approaches as opposed to using more of the context of mapping by timing, by entities, and so on to
Okay, we've been using and we support a lot of those algorithms as well, like PageRank between the centrality and and it has its use cases. We've been using it a lot when doing social networks, identifying like who's the key person retweeting a message. What happens if you take that person out of the equation? Is like a message spreading is good, or like who is the key person inside of a network? So we've been using that a lot, and we see with larger data sets, the GPU speed up is awesome. Like you don't press enter, go grab coffee, you press enter and you have the results. So that's one of the powers of the GPU.
Yeah, maybe I can get two. Kind of waiting for AV. So meanwhile, maybe two examples. One was basically we were dealing with essentially $1 billion lawsuit. So somehow we got into a side hustle of helping a sequence of $1 billion lawsuits, and having waiting an hour for like a CPU algorithm for, and it was like these like OSINT social media data sets versus having it like 1 minute. If you think of just iterative analysis as we're doing the investigation, that was like pretty critical to us being able to deliver like when we know the court date is looming or whatever, right? And then the other that was kind of interesting was we won the U.S. Cyber Command AI competition for alert volume reduction a couple of years ago. And think of like a fusion center where, imagine like in Splunk, you have all your notables, like all the alerts, whatever. So we were dealing with like, I don't know, like 1 billion or something alerts, and they're from, telcos and universities, whatever. We having the GPUs to actually just do ETL and feature engineering was pretty critical. And then once we had the graph of all the alerts across the kind of the threats landscape, having actually multiple community algorithms that we can actually cut up the graph into actually, instead of working at the alert or event level, we can now work at the incident level. And so having the grouping and being able to do that in a reasonable amount of time and again, iterate. But I would never do that on the fly. Like that'd be really painful. So having it set up ahead of time has been pretty, that's actually why we do a lot of our open source libraries, so that when we actually get into these, we just have the toolkit with like pre-set up. So it's about being like Legos, basically. I still don't know how to get the display going.
Yeah.
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 Okay, yeah, start the timer here. So hi, I'm Leo, founder of Graph.
You need to share the slides on Zoom. Like present it on Zoom.
Oh, I need to
Open
share
Zoom
screen?
on that computer.
Actually, maybe you can do that? No.
I can try.
So just switch to Zoom, but I'm not seeing. Oh, that's not over here. Yep. Yes. And that's right. Great. Yeah, so hi, Leo, founder of Graphistry. I'm going to be talking about AI that investigates and GPU Cypher, and then at the end of it, I'm actually going to be talking about those together. Any work like this is really a team effort, so a lot of our team, and I'm just like a person in the middle here. And for folks who are not familiar with us, most who are familiar may know about our core product, the First Visual GPU Graph AI platform. So we'll be talking a little bit about that and some of the new stuff. Graph the Planet also ends up being one of our annual community events where we just kind of share a lot of roadmap and things that have been happening with the community, also for folks online. Hopefully that's helpful. And then the first half of the talk, we're really going to be focusing on AI investigations and how that goes together. Likewise, just as background, we have been around for a little while, so we do work with, governments around the world use us. Think like NATO, Five Eyes, banks, a lot of regulated industries, but all the way down to like startups, scientists, newspapers. So we get into a lot of interesting investigative scenarios. Generally, we try to give them the power tools, but a lot of the work that we try to also always make sure we're kind of leaning in with some operational teams to actually do some investigations of our own, that just make sure that we're eating our own dog food. Also, history of open source. So even if you haven't heard of us, I'm guessing people here have used a database, which nowadays we use something like Apache Arrow. So we helped start that project, and NVIDIA Rapids for GPU data frames, which we helped start just so that we can actually build Graphistry itself. So kind of kicking it off here, I think, let me see if I can move this, or this is going to be really awkward. Okay, maybe that's, I don't know if that's better.
Just move it up to the top, move your mouse.
Yeah. This Zoom does not make it easy. All right, I think this is about as good as we're going to get it. Okay. Let's go back here. Okay, so backpedaling a sec. So I would claim that investigation teams have an intelligent automation problem. I'm going to be talking mostly about security. We happen to do a lot of investigations, other domains as well. But for simplicity, we're just going to focus on cyber. But fraud, IT, supply chain, a lot of operational teams we work with feel similar. So in cyber, when we get alerts, a few interesting numbers here to get a feel for it. So over half of the breaches, and this is Mandiant's, now that they're acquired by Google, they have their annual report. They report that over half of the breaches are externally reported. That's like a very polite way of saying either the hackers told them that they got in because it's ransomware, or it's somebody else kind of knocked on the door and said, hey, you have a bot on your network attacking me, please stop it. So we're in kind of like a right of boom, assume breach scenario. That is reality. It's not like the teams aren't doing anything. So a fifth of the SOC's time will be investigating, like correlating, timelining, like all that kind of stuff, aggregating. And even with all that effort, in reality is the surface is increasing, and then there's always pressure to do more with less, like all the kind of the usual nonsense. And the reality is if you talk to any team, they'll say, yo, half the alerts, I would like to investigate those, but we couldn't, or we can't in time, or even if we can, the reality is they don't feel it's sufficiently investigated. And so that's just reality, right? And so what's interesting from a historical view is like the definition of crazy is doing the same thing and expecting a different result. And so 2 decades later, of a lot of, I think, security engineering approaches, unsurprisingly, Python automation does help, but it doesn't, help enough. ML detection does help, but it does not help enough. Even AI workflows, like, hey, I have my Python workflow, could it call ChatGPT to classify something? Not enough. And basically, I'm making the argument that from a breadth perspective, these don't cover enough breadth. And for each one of those breadth, it does not go deep enough. And to me, that's basically a failure of intelligence automation. So we're going to be talking a little bit about that. But I'm going to kind of detour a little bit. So obviously, I'll be talking about agents, if you haven't guessed. But I think it's useful to think about the coding world and what's happening there, where basically we could look into the future about 1 or 2 years by understanding what's happening there and reflecting on that. So in the coding world, GPT-4 came out, is pretty awesome. Startup Cursor went from, in record time for any startup, $0 to $100 million. People really like to have code autocomplete. So that's pretty awesome in 1 year. But the next year, Claude Code did something really interesting. The agents were able to code longer, so you can kind of have them do more. And then they went from 0 to $2.5 billion in revenue in 1 year, basically. I might, maybe it's like 1 billion or like, but at that level, this is crazy, right? But I think that's money, but I think adoption is it's clearly something with adoption. And that's when Google and Microsoft said something interesting. Hey, already a fifth to a third of our code is AI authored. And this was last year. This year, we're kind of on track to have a fifth of all open source code on GitHub to be AI authored. And if you kind of look at the curves, then it means okay, so next year, most code in general is going to be AI authored. So clearly the coding community is going way agentic. So I want to kind of ask a few questions here. First is, So obviously, if you're in this room, you use ChatGPT in some way. I'm not even going to ask. But who uses 3+ coding agents to write software at the same time? So we've got a few hands here. 1, 2, 3, 4. So like maybe, and it's not a big room, so it's like, you know, reasonable. Now, who uses 3 agents at the same time for investigating event data? We have, oh my gosh. Well, okay, we have one of our staffers, we have somebody building an agent and somebody also building an agent. So basically operationally, nobody. I gave a talk a few months ago, I think a Chaos Congress, think of it like DEF CON in Europe with like more like disco lights or something. And 1,000 people, it was the same thing. Basically, coding agents everyone's doing, they're actually really pushing these, but nobody's investigating with them, like especially at the level that the coders are doing. So clearly there's some sort of gap. Now, Graphistry is a very kind of deep tech, kind of science and engineering driven organization. Like that's why we've been able to do year over year the type of things we do. And a lot of that starts with measurement. And in the age of AI, that's especially true. And so when we're looking at this investigation automation gap, one thing is if you cannot measure it, you cannot improve it. So that's Lord Kelvin. That's kind of a normal engineering thing. But then as a community, when we have in a day when it's easy to vibe code anything and just open source anything, we're getting a lot of basically a kind of freeze and puppy, where it's like, oh, somebody made a thing, but it's almost like an art project, because if you actually adopted it, now you have to actually ensure quality, right? Because they're not doing the evals, right? So it's almost like negative value. So I think it's part of important is measurement, is actually setting North Stars of what is good. And then having, if someone's going to release something and they can't say that it's actually hitting the public eval, well, it's an art project. It's not a tool anybody honestly should use unless you're investing it as some sort of art project. And then I'm going to say this, I don't know if as a CEO I should be saying it, but increasingly when I look at software, evals, or you could sound it out, that now I'm pretty increasingly, even though I didn't start on this side, I'm actually now feeling very strongly about evals. And so I'm going to kind of give you a bit of feel for it. So about a year ago at RSA, we made an announcement. And as you heard about Boss of the Sock from Dave earlier, this actually made some waves. We have a little URL there. Like if you just search Louie.ai beats Boss of the Sock, we have a cool video. We have a bit of cameo, like a cartoon, like an anime form of one of our folks here who actually might have just given a tutorial you'll enjoy. But the reason that it made so many rounds is because it was a good eval. We intentionally, like we do all sorts of benchmarks of our systems. We intentionally picked that one because we're like, hey, what's the most representative one that everybody knows in the community and anyone who kind of has been around and actually tried stuff? And like, yeah, Dave's team did a great job. It's over 100 data sources. It wasn't just like alerts. It's like different, like, it's logs. It was like Windows logs. It's S3 logs. It was like broken buckets. It's identity data. It's like layers of like alerts. They did a really good job. And then anyone who's done a CTF, and thousands of people do it every year, they know that the tasks being done are like, oh, like timelining, scoping, correlating, like all these annoying questions that 20% of the time I was talking about. So it was a good one. So the result we released last year was, hey, in these kind of like, initial attempts, we got a passing score. And that was kind of a shock to a lot of people that like, whether it's us or the sign of the time, like, hey, this thing's coming. And in a sense, like we actually had numbers where we know that it was literally a 10x, like 20 hours becomes 2 hours, 2.5 million minutes to answer one of these kind of real questions. So we've been measuring more, and we're starting to like release things. One of the things I thought was interesting, also playing off of Dave's thing, I just launched Bots Bench a few days ago, and we're starting to look at both the agent harness and the model underneath to start saying, hey, which of these, like if you're going to say you're an AI SOC or if you're just a general AI tool good for cyber, like I think everyone should try to use Claude Code for this kind of stuff. If you're not, like I bet most people already here are. But we're starting to find interesting things. Like one is Claude Code, and it's almost like embarrassing, like humble pie to our team. They actually, Claude Code 4.5 gets that same 73% that we worked so hard on last year, and they actually did it out of the box and with less prompts. And I was like, these are really great. And that one of the things that told me is most AI stock companies probably should not exist because they're not doing as good engineering. Most of them would fail this. Like, if you're an investor on this, make them take bots, I bet most would fail. But the second thing I found interesting, and I was looking at, we do measurement, we're engineers, is the first time I found model contamination. That the 4.6 series of Opus, like Opus and Sonnet, like you could run the bots challenge, but instead of having the CTF connected to a database and trying to answer the questions, you could just disconnect the database, run it in like a sandbox, and it'll actually start getting a lot of the questions right. And so as a methodology, like we actually have to be very careful how we do measurement. Even getting the evals right are hard. So that's kind of part of why we're running bots bench is not every team could be as serious as us, and that's such a huge misstep methodologically, especially if we're meeting a lot of SOC teams that are internally trying to build this stuff, and they're just honestly doing it wrong. So hopefully this is going to be helpful. So of course, I'm going to do our new announcement. So the good news is we've gone from a passing score to a 96%. And I'm pretty sure if we wanted to give another month or two, we'll probably get 100%. And then instead of 2 or 3 minutes, we now figured out how to do it in about 1 minute per question. That does not mean we have solved investigations. That does not mean we've solved security. I wish. But it does mean we're on to the next level of evals, and just as a community, it's one, bots is dead. And if somebody can't beat bots, I think that's a good, kind of tells you where they are. But as a community, that means we do need new benchmarks. So for folks building LLM stuff, or folks actually not building LLM stuff and wanting to get a feel for it, I want to kind of make a few points here. So our score last year and kind of where Claude Code is today, I think one, that's incredible from a historical perspective. But from an AI perspective and a quality perspective, that's much closer to the beginning than the end. And what I mean by that is, like, let's say in an investigation, 10 things have to go right. Like if you miss any of them, the investigation's wrong. You missed it, like the people are still inside, whatever. So if I have like a faulty coin that kind of does each step, and it's right 70% of the time, which is pretty good. Imagine like GPT-4 or something. Well, if it has to get all 10 of them, do all 10 of the steps, well, it's only going to actually have a 2.8% chance of doing the investigation right. So that's not really trustworthy. But if I improve my coin, I improve my model, I improve my agent, like whatever, and like from 70%, like halfway to 100% is like maybe 85%, and then another halfway, and I'll do another round of effort. Now I'm at 90%. Another round of effort, I'm at 95%. Well, for the actual investigation, I'm still at a 59.9%. And if you go to the RSAC floor, later today or this week, you're gonna have people saying that they're getting purely automated investigations, but I bet they're here, right? And so I don't know what they're automating, but I don't think they're automating the actual investigation, from the numbers view. But if I go from 95 to 98, 98 to 99, 99 to 99.5, 99.5 to 99.9, now I get like a pretty reliable-ish, it's not even reliable, but reliable-ish shot at actually doing the 10 things in investigations right. So there's actually a couple of our experience, feeling these numbers, has kind of changed my thinking about where what's the future of the investigation AI factory. So one thing is, I do for purely autonomous investigation where we are right now, I think we actually could do a pretty good job if it's a short task. So if I am under that 10 steps or wherever you are in that, what that means is we actually could do some pretty good work. And a lot of the things are basically this notion of blocking and tackling, of this a triage or contextualization. I would not call those investigation. I might call them pre-investigation, but I think that's actually really useful to just get rid of the noise. And so I think that's really valuable. The second thing so for Louie, we talk a lot about vibes investigating as an analog of vibes coding. And if you think about it, let's say I could do maybe 10 steps if I'm being charitable with one of these autonomous SOCs. Well, if I have a human going left or right, well, then I could go from 10 steps to 100 steps, or 100 steps to 1,000 steps, right? Because I could keep guiding them going left or right or both, That means I can actually get that breadth and depth that I was wanting that I just couldn't get with all those AI SOC people. And then now from a methodology and an AI factory perspective, if you recall the Keynote, it's all about the loops and building out those validations and smoothing out those cow paths as you go down, you turn a deer path into a cow path by walking down it. The people to do that, half of them are the analysts who are looking at the data. And so this is why we're so bullish on making Vibes investigating core part of the SOC flow. So instead of data scientists pretending they can come in and do it all, we're actually trying to get in there and work with them and enable them to kind of smooth out tools for themselves and then bring into the broader flow. Reality, that also helps us do other stuff as well. So this is kind of a two-layer game. But that's also, when I think about feedback loops and what a true AI SOC is, which means feedback loops, it's increasingly how I'm thinking about it. Just as a quick example of what this kind of materializes as. Here I'm taking a little example of a boss of the SOC question, what is the full user agent string that uploaded the malicious link to OneDrive? So it's a reasonable question. But what's interesting is instead of me trying to answer that question, I could turn that into a timelining exercise, create a full incident response report, and then turn that into a full visual kill chain. That's what the pre-investigation is now. And then that's what the analyst gets. And now because the analyst is no longer going raw into investigation, they actually have a mini database of investigation that's pre-investigated. Now it's a much easier problem. And so even before we get into learning loops and things, this is already things that we can do today. It's just if you asked me this a year ago, this would have been crazy. So I have been mentioning the phrase vibes coding, vibes investigating. I think it's useful to understand it in two ways. One is good vibes investigating starts with good vibes coding. So our agent harnesses start by doing what the best coding harnesses do. And the earlier talk about from training models was the same thing. To teach a cyber analyst, you first also teach it math and coding. Same thing at the harness level. We need to let it do all that stuff. It's just basic tools. But then there's things start getting different. So for example, in coding, you're kind of coding and debugging, but in investigations, we're doing triaging and correlating and timelining. They're just scoping. They're just kind of different. Likewise, we're not trying to search 1,000 files to figure out which one to edit. We're trying to deal with I don't know, 1 million or 100 billion events a day and how to go through all the database tables. It's just a different problem. It's not I wouldn't say it's fundamentally one harder than the other. It's just different. Likewise, this one actually is harder, I would claim. In coding, you get to have specs and unit tests and type checks and whatever. But investigating, your job is to come up with the answer. So you don't know going in if it's right or not. You don't really have that nice little oracle. So other things I think some things are the same, some are harder, probably some are easier. Yeah, and so there's I can talk a lot off of that, but I also want to give a feel for kind of some of the things that we do internally, but it's also directionally what we're trying to figure out how to enable users of our platform and our community, because I think they have to do the same thing. Certain things, because I think certain things the platform do, some of them we have to work with the SOCs implementing it. And keep in mind, it doesn't have to be SOC. It could be fraud. It could be IT, SRE, same thing. So let's say we take any eval to do with any of these things. So we have all these, right? What we'll need to now do is run the benchmark and see where it goes wrong. And maybe it went wrong because the Python code did something wrong, so we're gonna have logs. And maybe it went wrong because the AI did something, so the prompt is wrong. So okay, we're gonna have all that telemetry. So we happen to use open telemetry. I'm gonna talk about that in a sec. And then instead of us doing the error analysis, we're gonna have the AI do the error analysis. Then the AI comes up with how to improve, whether it's the prompt or the code or anything else that's going on. And then we loop back until basically we do the hill climb, and then we see, hey, we're whatever the thing we value, it doesn't have to be boss of the SOC. It could be your internal, whatever type of investigation or case you're trying to do, or we're trying to make a new tool that generalizes, all of those. Maybe I'm doing count CTI or something. So we've been building out Louie so that we can, instead of us doing it, the AI could do that loop, and so we can basically methodically and predictably improve quality. What's a little interesting now is, well, now we have a telemetry stack and we have a telemetry process that whatever thing I want to do, I could actually automatically improve it. And so this is something I'm called, instead of vibe coding, I call it eval-driven AI coding loops. And I think if you reflect on some of the speakers today, they feel a lot closer to this than what a traditional vibe coder would talk about on on one of those social media sites. We're all using evals and using that to guide how we improve things. And I want to give a little, just to really hammer that home. So skills are taking over how teams and practitioners do this kind of things, where if you're not familiar with skills, imagine you have a standard operating procedure that used to be like a wiki page or Confluence page of oh, if you have an identity incident, and it's in New England, you do it like this, but if it's in Asia, you do it like that. You have all those wiki pages and just define it. there's an interesting study that said that, like, hey, if you ask an AI to generate that kind of corpus and then have the coding agent or whatever try to use that AI-generated skill, and that it's very natural. Imagine your Claude Code and you're like, hey, I want you to automate the workflow I just did. Please make a skill file so the next time you could use it. It's very normal. They found that generally it either didn't help or did worse. So it's like, oh, that's kind of like, well, does that mean skills don't work? No, it just means writing skills badly doesn't work. And so what we found is that, well, if we do a skill, but we also have an eval, and we're like, hey, this is like, I want to do this kind of investigation, or I want to do this kind of tool use. Cool, here's our eval. Now I could then throw the coding agent to actually loop with our skill file and just iteratively improve it and hill climb. And then we start seeing benefits like, for example, 3.7x more of our cases passed. Or in this case, we're actually teaching, we're finding a lot of our users are now starting to like ask us less questions because they just use Claude Code to use Graphistry, which has honestly been awesome. They do really cooler things, and we get to have more interesting conversations with them. And so what we found is by doing a better skill file out of the box, it wasn't that great, but by doing the hill climb, it was able to handle 3 or 4 times more cases, like going from a 0 to a 1, and then also for even if it didn't like solve it, like maybe it was able to solve it without it and find its way, we were able to go about 2 times faster. And so like by doing the hill climbing, it's not just our core code, but I think anybody doing prompts, like whether you're a skill file internally or externally, I think this is pretty important. So it's kind of a direction we're going. So that said, obviously we've been busy. So one of the other things I kind of wanted to announce here is we're doing something called Louie Desktop. So hopefully you're getting a sense that we are trying to be the best at something, but weirdly, we're also trying to give it away for free. So the idea with Louie Desktop, thank you. And so the idea with Louie Desktop is like, I don't care if you're like an Apple, Windows, Linux, you'll be able to install it, use whatever, run it anywhere, use whatever LLM, and you'll be able to get all this stuff. And we've been focusing a lot on the investigative side, so think Splunk, Databricks, a lot of the Microsoft ecosystem, Custo, Sentinel. We actually have some announcements coming with them. So that's all there. And then what our real focus on is like, we need to get people successful. I think making it easier for people to try it and start playing with this stuff, getting vibing, I think that's number one. Another thing that we're trying to do is we actually started doing trainings. So we have an AI masterclass we started doing. So at Black Hat last year, we actually ran the most popular training at Black Hat of all. And so that was really cool. And so just to see all the people like wanting to learn this stuff. And then all of that basically funnels towards our regular product where that's cool that once you start getting comfortable, like, whether as solo in a team, you're playing with it or at home, eventually you say, hey, what if I could share my skill files with my teammates? What if when I have a case, I could actually give them a live link to the case and they could start vibing, we can continue together. So that's basically our kind of enterprise or team server. Obviously the usual like RBAC and that kind of stuff. But hopefully that gives a bit of sense of where we're going and what we've been learning to do.
So is the Louie Desktop, is Louie Desktop mainly the loop that you just explained for investigations, or is it generic? I can use any skill and it's basically this eval loop that I can build with it?
Yeah, we're making it to be kind of bad coding agent, and then but on top of that, a really great investigating agent. That's the heart of it. And so everything you could have done with Claude Code, just a little bit worse. But then once you want to get investigating, it's better. And then some parts feel the same, like API, like. Other parts feel different because it's more investigation and data oriented. Yeah, I wrote here, for example, data-centric AI plus UI. Claude Code is very file and text oriented. We can get back 1 million log lines from Databricks, and that's cool. And then we're not just going to dump it willy-nilly into the LLM. We'll actually intelligently do that. And then we have a really great Vibes UI where instead of just seeing like text in the terminal, you actually see like an interactive table so you can investigate. Actually, I'll get to a demo in a second where you can kind of feel a bit of this stuff. So being a little roundabout here, I guess like I'll tee up the demo. It's not like we're not doing Graphistry stuff. We actually have another cool announcement. So again, a reminder of last year, we've had a problem traditionally with as like the data world and data pipelines and like, data is a team sport. Like, you have the SOC analyst, the security engineer, you have like the data science, we all have to work together. What we found that when we were trying to deploy the Graphistry GPU stack, like imagine you want to visualize stuff like you saw at the tutorial before, we always had this problem is like somebody might have like Databricks or Splunk, they might do a Jupyter notebook or a dashboard, but to do graph stuff, yeah, we could visualize it or we could do some AI on it, but they had to wrangle it. And then often they're like, well, should I just copy all of my data into like Neo4j? And that was terrible because Databricks is really big and Neo4j is really expensive. So that was kind of, and then now it's this big data engineering project when you just wanted to see your data. So what we realized was, and this is actually honestly, it's like overnight success, years in the making. Like in 2022, I put out a piece with Ben Lorca. We're like, hey, for graphs, we need to separate the compute tier from the storage tier. So use any database you want, Databricks, Snowflake, Splunk, Elastic, all that stuff. Even use a graph database, maybe like, they're awesome too. But for all the compute stuff, let's do that compute tier. Let's do it as a compute engine. Make it easy in Python. If you have a GPU, let's use the GPU. If you don't have a GPU, maybe you can offload to a GPU. But if you don't, or you just want to locally, just run the CPU. But importantly, it's like columnar, so that we can actually do all those optimization tricks. And so now I could do something like here. And actually, this is actually the next announcement. So this is what we did last year. We built like kind of low-level engine, but honestly, we're using that so we could build Graphistry. And so like all the cool stuff you were saying. But then we're like, well, what if like could people write it? So how would we have other people using it? And then second is like, could we actually have the AI write it? Like, and what would make that work better? What would be a good like language for AI to kind of do graph data science? And so we're like, well, Cypher is the most popular graph property language in the world. What if we made that run in the compute tier and made that run on the GPU? And so here we have basically, we've already implemented over half of the conformant Cypher standard. It's actually, we found that Cypher honestly is a little awkward sometimes. And so here we have a picture of like a full graph pipeline. There's like a Jupyter notebook. And honestly, this is all open source, by the way. So you can just run this like, just for fun and on CPU and it's fine. So we did a regular like data pipeline of like, hey, could I load some tabular data? Could I shape it into a graph? Can I do some graph mining, some graph search, maybe some algorithmic enrichment? Like if you're going to do an ML pipeline, that's what you would probably do and go back to tabular land. Let's do the full graph pipeline. We could do Cypher when we want. Sometimes if your entire world is like selling a Cypher database, you might make certain trade-offs and things get a little awkward when you have to do other things. We don't have to do those things. We could do a lot of flexibility of the compute tier. Our code ends up being actually simpler. And what's interesting, it's also a heck of a lot faster. So for like a 2 million edge graph, which honestly is kind of small from like a performance view, we were processing in about 0.4 seconds through this full multi-phase pipeline. Neo4j took 22 seconds. When we 10x'd it to 30 million edges, now, okay, great, we take 7 seconds. Neo4j just like times out. And that includes their compute tier GDS stuff. So we're about, I think, if you do this out, I think it's about 50x faster. So that was, and this is just free out of the box, again, open source. But again, remember, I was saying something about AI, right? Oh, sorry, yeah, one more thing. Again, this is actually a result from last year. We still need to do new numbers, but basically, on just the core engine, we were able to do 1 or 2 billion edges per second on a single GPU. So depends on the GPU size. We can also do maybe 100 million if you have like a cheapo one that costs amount of coffee. But again, like it isn't just about speed, but it's like cost. Like you don't have to have a big footprint. We could do a lot and keep it interactive. So I wanted to go back to the AI thing. So LLMs love language, right? And so now we have a language to talk about graphs, and we have the whole Graphistry ecosystem of visualization, shaping, analytics, all that fun stuff. And so what I want to show a demo here is, I gave a talk at AI Village a few years ago during COVID, and we were doing some OSINT analysis with a little bit of machine learning, and I wanted to show taking that full pipeline and now doing it hands-free. So we're going to start on the Louie side. Let's see, does this load? Maybe. OK, cool. We'll give this a second here. So we just jump into Louie. OK, thanks. So I say, hey, get 1,000 profiles from the misinformation data set, Project Domino, and then draw UMAP clustering. So I want to know which accounts are similar. And so and then in the background, the data is connected to Databricks, Splunk, some graph databases, so all sorts of databases. I actually wrote a skill file ahead of time just because I want the demo to run a bit faster, so representative of what a user might do. And so here what we're seeing, an explanation as it runs. So it's different from ChatGPT because you actually get explanations you could drill into. So we're seeing it does its pipeline, it figures out where to pull the data. We can inspect the data. Again, this is where we're data-oriented rather than being text-oriented. So I actually get all these pulled query results, and I have this trail. And then it generated the UMAP. And now this basically recreates half of that entire talk I gave at DEF CON, except for I didn't have to write code. I just wrote a one-sentence prompt. So that part is actually that's already Louie. There's nothing special. This next one is actually something, this is more prototype, so this is not yet in Graphistry, but this is we actually prototyped it years ago, but we didn't think AI was ready yet, but now we do. So I asked, hey, Louie, can you take that graph from before, but make it a more compact layout? So I wanted to have a prettier picture. Cool, so those 5,000 nodes, 100,000 edges, cool, it laid it out for me. And then I asked, show me the distribution of QAnon users using a purple gradient. So now I'm we get a lot of complaints from users that there's so many features in Graphistry, I don't know how to use it. But now you can just tell it what you want, and then it'll kind of do it. And so here we have all the QAnon accounts getting highlighted, and whenever through the UMAP algorithm they're similar to other ones, we kind of see that network. So next one I asked, the distribution, what are we asking? Show me the most influential accounts and their connections. So now this is starting to get a little more interesting. And what I want to note here in this one is this is now no longer directly calling the Graphistry API, but now we're actually going to be generating Cypher and GFQL because this is now a more complicated flow. But you don't have to know Cypher and you don't have to know any of these things. And so it creates something called collections, which are basically Cypher statements, and it does things with them like coloring. And so here in red we see the influential ones, and in orange the stuff one step out. I could drill into this Cypher, but I don't have to. And then kind of finishing it off, I say, I think, what are the main communities? I didn't see the last one, but what are the main communities in the graph, and explain each one. So often that's actually the job of the analyst. It's once we have the clustering is to kind of go through and hey, what's going on in this campaign or not, whether it's cyber or fraud, you basically have to explain each one. That's your job, is to make sure everything is kosher in each one, and if not, raise it. I just showed the AI doing all of that with just talking to it. So again, the first half is basically Louie desktop. The second one, I don't know if it's wait a few months or wait 6 months, whatever. The technology is here, so that is what you just kind of saw. So with that, I'm getting shooed, so I'm also going over. So as I said, basically all this stuff is free. So Graphistry, you can get a free hub account. GPU Cypher, just pip install it. If you have a GPU or CPU, have fun. If Graphistry server happens to run it for you if you'd like it. In Louie desktop, we're not GA, we don't do, we're not doing it as a public GA. Instead, we're doing it in cohorts. And so, sign up, tell us a little bit about what your use case. We're looking for operational users. And so if you actually run investigations, we're prioritizing you and looking for folks to have fun with. And then also remember the bots bench, so check that out. If you're more on the AI maker side, I'd love to talk to you about making that better. So yeah, thank you. Yeah, so Victor's asking the cost of the tokens. Yeah, so this has been really wonderful. So remember I said last year we were about 2 to 3 minutes. It was actually one of the things we did last year was actually do multiple tries. So we'd actually do parallel tries, so it was really expensive. We are now a median of 1 minute. So 1/3 of the cost, things are getting better. And then the other part that I should say, especially for our regulated industry users, we're starting to play with self-hosting models. And so that's, you might have noticed my questions earlier today. So that's also for, yeah. Any more? Cool. Well, all right. Hopefully that was interesting to folks and some fun free toys to play with. So thank you. Okay, so next speaker, I feel like Victor's talks are always the most fun ones, so I hope I'm not like setting you up too much for that with that, but it's also lower a bit. But okay, it's one of the more serious one because we're just dealing with like ransomware and things. He's dealing with like hundreds of millions of dollars of fraud, and it's really important and sensitive, and people get really worried about it.
All right, thank you, Leo. Hi, everyone. So today I'm going to talk about skills and their skilling and the AGI future of the cryptocurrency investigation with Agentic.AI. And I put the first 2 lines there because Leo already sliding my title there. But I'm going to talk about there's a few very important aspects of the AI that we kind of we feel like is will be very interesting to share and to hear your feedback. Okay. So we're AnChain.AI. The name implies analyze blockchain with AI. So we're also the RSAC Innovation Sandbox 2-3 years ago. So we are laser focusing on building AI into cryptocurrency investigation. And first of all, how is AI in 2026? I mean, stock is doing pretty well until very recently, but one of the things I heard is actually, will AI replace my job? And just a few weeks ago, I gave a talk at the ACFCS, is a Association of Certified Financial Crime Specialists. So me and John actually spoke to more than 1,000 risk analysts and all that, right? And this is actually, at least 5 people asked me this question at the end, right? So I think that people are concerned, right? And as you can already see what's going on with all these automations and all that. And that reminds me actually the Golden Gate Bridge toll story that is actually, that happened 10 years ago, not far away from here. Okay, so how many of you actually back then have to stop by the Golden Gate to pay the toll? Raise your hand. Okay, well, OG, San Franciscans. So, but until one day, I just drove by the Golden Gate. And this is AI generated. Raphael, that's AI generated, by the way. Yeah, I know, AI generated. No copyright issue. Good catch, Raphael. So, so we have to actually stop by to pay the toll, the Golden Gate Bridge toll, okay? And my daughter actually asked me, Daddy, is that a good job? Because no matter what car you're driving, you have to stop and pay, okay? And I paused a moment and I was like, well, what kind of skill is required in that kind of job? What, counting money, giving the receipt? And after you spend like 10, 20, 30 years in there, what kind of skill you keep improving? Well, you can maybe process those pay tolls faster. Is that an important skill? Well, the answer reveals itself, right? After just 1 or 2 years, one day I just passed by the Golden Gate Bridge without even stopping. And I was like, what's going on? Oh, because Easy Pass now deployed. So it's a little interesting story, okay? And I will relate that to my my following slides. The rise of AGI. So I think Professor Downsong, right, my friend, actually have this very seminal paper that published a few months ago. The definition of AGI, artificial general intelligence. Okay, so it's AGI, it's an AI that match or exceed cognitive versatility and of a well-educated adult. So what they do is basically they break down the knowledge into 20, 30 different categories, right? You can see those common questions in here. And they also start benchmarking GPT-4 and 5 and all that, right? So I got a PhD in computer science, but honestly, a lot of those questions I cannot even answer. And that means AGI is actually setting a pretty high bar, okay? And the third thing I found very interesting, is the guardrail models versus unrestricted models, okay? We're the good guys, right? But this is the thing we're dealing with now, and especially with GPT 5.4. Actually, if you ask it to write a POC code for exploit, it no longer give you those, unless I just asked Professor Downsong, right? He said, well, you have to break down the questions and all that. Yeah, there's an entire art to that, to jailbreak it, right? But then on the opposite side, the bad guys are using great models and they fine-tune it or distill it uncensored models. Okay, and by the way, this is, I have to block it because it's not safe for work, as you can see, right? When is one of the top model by Alibaba, guess what you can use it for, right? Anyway, so in our research recently, we look at all the different crypto fraud and crimes, right? So there's like billions of dollars, and being that the hackers are doing pretty well, and a lot of them actually were able to take advantage of all this AI. And I'm sure a lot of them are jailbreak LLMs, right, to write the codes and all that. They cannot just ask ChatGPT to provide those exploit code, okay? Okay, so now let's talk about the skills. And I actually did do a little bit of research into the job postings to see what kind of skills are people hiring for the SOC from Tier 1, Tier 2, Tier 3, or the AML risk analyst is also Tier 1, Tier 2, Tier 3, very similar setting, okay? And those are still active, okay? And also the Splunk, now it's part of Cisco, right? Have a very well defined job responsibility for Tier 1, Tier 2, Tier 3. And the way I summarize it is triage, that's Tier 1, that's what they're doing. And investigate, that's Tier 2. And then threat hunting, that's the Tier 3, okay? And if you start to really, like, and the AML side of it, the risk analysis is very similar, right? Triaging and investigate and threat hunt. Okay, so now let me show you some of the real, now we're getting to the more in-depth side of it. I know a lot of you are actually practitioners, so we're gonna bring up one of the case that we are the primary investigator on. This is one of the major DeFi cryptocurrency hacks. And we work with the DOJs and the law enforcement on this, okay? And basically, this is what I'm gonna show you. We use AI to do machine learning, right? Back then, since day one, to do all this investigation. But this is still now considered the old way of doing that. But still, I want to show you to set a little bit more context. Okay, so I'm gonna show you, let me see if the video. So Leo, is that? Okay, so it's loading. So I'm gonna show you. This is what we developed, the auto trace. So basically you add the, okay. So you put in a crypto address in there, right? Automatically, we can actually trace the money flow, right? Downstream, upstreams, and all that. Okay, and you can change layouts and all these different cool things, right? To investigate, right? And zoom in, zoom out, those cool things, right? And if you have a lot more graph nodes, I think Graphistry would be a better fit, but the one we're dealing with, we can handle probably like thousands to 10,000 in the browser. And then eventually, you can turn it into a report. And if you're in the financial service industry, this is the one that if you trigger the SAR, the suspicious activity report, right? That's the one that we actually develop AI to help them file the report to the FinCEN. Okay, that's one. And then, I mean, it's not gonna be that easy, right? As you can tell. So sometimes you will hit a roadblock, which is the smart contract, which is a piece of software operating decentralizedly on the blockchains. Okay, especially the EVM, the Ethereum blockchain, right? It's okay that you don't touch cryptocurrencies, just consider it's like a JavaScript-like piece of code that you can run on a virtual machine. And I want to show you here also because investigation is not just one dimension. The one we're dealing with is not just the graph. And a lot of time, right, you have to get into the nitty details of, I have to open up this transaction and see what's going on in there. And this, again, this is one single transaction that we're able to unpack. This is what's happening in one single DeFi transaction. Basically, the hacker is doing something shady to exploit the money from these crypto addresses. Okay, and I think this is actually a real example of that Kyber swap case. Okay, and this hacker just managed to find vulnerabilities in that DeFi protocol, and we're able to drain like $65 million. Okay, and we're working with the law enforcement and the clients to actually we're able to rebuild this entire forensics and investigate this entire case. As you can see, there's a lot of data. It's not just the graph. It's also a lot of text and transaction data you have to go through. Okay, so now, those two examples is actually like, now you see, okay, the machine learning and pre-GPT era of AI are doing. And now is really we're getting into a more exciting future, I would say, right? I think we are still at the beginning of this. It's how the agent skills and MCP will disrupt this entire field, okay? And I think all of you guys know about skills and MCP. I don't have to go deeper into that. But let me show you. This is actually, we are going to replicate the things that we just showed you in the previous two demo videos. And basically, now is we already have the agentic workflow set up, okay? So all you need is putting the prompt of, hey, let's investigate that transaction hash. And it's very interesting when you see how the agentic AI is actually taking all these different, the reasoning steps and start gathering all the data. It's funny to have the background music over here. So, and then also it's actually, in the past, this is actually a very manual process. As you can tell, there's a lot of tools you need to use. There's a lot of data transaction you have to go through. There's even source code you have to go and try to simulate to figure out how the hacker is doing that, okay? But now you're seeing that it's basically replicating what the human has done in the past. And a little bit spoiler alert. Can you guess how long did it take for us to partner with the law enforcement for that case? Take a guess. Months, exactly. And that probably would take, from our side, 2 full-time. And from their side, probably 2-3 full-times also, right? So you're talking about the resource in all these different tasks. And now it's like, and you can generate code also. It's like in some of the base 64 code encoded transaction, right? The AI agent were able to automatically figure it out and start building the Python to unpack those, okay? And of course, this will not be possible if we don't have the right AI native data and MCP infrastructure, okay? This is building on a foundation that we already established in the past 6-7 years, okay? But it's always fun to look at how the AI agent is actually cracking the real cases that happen. And boom, this is the one that we spend literally 2-3 months of couple full-times on. And now we make it open up for free also. Thanks, Leo, for the motivation. And if you are interested in just play with it, you don't have to be a blockchain or a crypto expert to seeing the potential of this technology, okay? So how many of you are still following? Because, okay, awesome. I love that, 2 hands. All right, that counts as 2. And a lot of them, you probably have not even deal with cryptocurrencies and all that. But you know what? The malware and ransomware now are starting leveraging blockchain as their C tool, the command and control. And this is one of the real cases that we just find out. Actually, that C tool infrastructure on BNB testnet is still active, as we checked last week. So they are operating. And how many of you heard about this click fix malware? Basically, it's popping up a thing like this, and how to fix, you click, and what's happening is actually you copy a piece of code into your memory, and then they will ask you to, hey, now verify that step by pressing that. I mean, how many of you can know there are people from Microsoft here, right? What does it do, by the way, the last step? To prove that you are human, by open up Windows and R, Control V, and hit enter. And what happened? You execute the malware on your machine, okay? So be careful. And by the way, they host that the malicious code, the middle one, right? It's on the blockchain infrastructure. And the cost I already mentioned, right? Per investigation, right? 2 full-time, 2 months, and that's probably like $70,000 or whatever. And the AI agent, for that example I just showed you, less than 1 million tokens, and with some cost of the AnChain.AI MCP and 10 minutes to run, and we still have to put a human in the loop to validate the results. And I want to explain why that is very important. So the total cost is less than 1K, and guess what? The 8 hours of human validation is like the majority of this. But then also, I put the slides here because the token pricing is always gonna go down, okay? And so don't bet against the LLM. This is the reason. Who said that, by the way? It's like Elon Musk or Sam Altman said that. Okay, so now go back to this also this concerning topic, right? De-skilling. How many of you in the room have to hunt for food? Raise your hand. No, right? And how many of you have growing your own vegetables, by the way? Oh, just 1 out of 100, okay. Guess what? Like, we are all already in the process of de-skilling in the past thousands of years, okay? And what's the definition, right? There's actually a Springer Nature Link article came in, and a lot of people, researchers also studying this, right? How is AI is actually eroding your human cognitive creativities and even critical thinking, because now you are probably becoming more and more relying on the AI. Okay, there's a word for that. De-skilling. Okay. And it could be very expensive, de-skilling. And there's another Nature article come out, right, a few years ago, right? So they research like the human, and then now a lot of people are talking about using AI to augment the human capability, right? Especially I say the entire expo hall, probably 80% of companies are talking about that. So have you figured, well, if the AI is correct, that is this bar, right? If the AI is confidently give you the wrong answer, and that turns out to be 6 times worse, okay, when working with the wrong recommendation. And for more details, refer to that Nature article, but I think it actually speaks to itself a lot, like over-reliance on the AI could be costly. And now go back to the table, right? Hope you still remember, right? So we break it down into those 3, tier 1 to tier 2, tier 3, right? My prediction really by looking at all this usage behaviors and all that, I think the tier 1, right? It's those people, the skills are highly replaceable by the AI, okay? And my guess is more than 90%. And the middle one, right? It's the investigations and all that. That require more advanced analytical skills into diving deeper into that, right? Again, you're not totally safe. I would say, I already showed you the example, the AI agent that we developed for investigation. I would say AI assisted in a very friendly way, but I would say 70% will be impacted. Threat hunting. How many of you actually have to hunt for threats? Raise your hand. Malwares and everything. Great. I think we are safe for now. For now. Okay. And I presented this last year in the same spot here, right? So I break it down into the known unknown matrix, right? So, and the known is you already know what's going on there, right? So, and the unknown, that's like the Wild West. You have to just use an R to do that, right? And the off diagonal will be interesting. And map it back to those 3 tiers I just mentioned. Again, this is just my theory, okay? Could be wrong. I definitely want to hear your feedback on this. I would say tier 1, that's known, right? You know this alert being triggered for some reason. Your system already detected that. Now your job is to triage it It's known now. You already know that, and it's already a fact. And the threat hunting, the unknown, that's the threat hunting. You are hunting down new threats, okay? That I would say the humans still like significantly better than AI. The off diagonal, I would say more investigate. You have to answer, like for example, known unknown, or the unknown knowns, okay? You have to spend a lot of effort to figure out what's going on in those transactions. And what do you think? I want to hear your feedback, because this, I think I come up with this. I want to, do you guys agree or disagree? Or is it? You agree? Okay, only one. Wow, that's sad. Okay, so but think about it, right? Let me know your thoughts. Okay, and now let's talk about the AGI future. And I want to see, okay. How many of you here last year when I presented this? Cheese not sticking to pizza, okay. That was actually my favorite example when I explained the AI hallucination. It's a real example. Google Gemini gave this recommendation that, hey, you should use glue to stick your cheese to the pizza. And it turns out that it was Google hallucinating because there was like a 10-year-old Reddit post. There was a guy putting that in there saying that you should use glue to stick the cheese to the pizza. Real story, okay? I think that's the best example I can think about to explain AI hallucination, okay? So, and don't worry, human, the AI has its limitations. Actually, at least 3. One is hallucination, okay? And the second one, which is actually when you deploy your product into the production, you're gonna suffer that actually a lot, the inconsistency. Have you guys tried to run multiple times, the same prompt, same parameters, and even the temperature set to 0, and the AI occasionally will give you different answers when you have a very complicated prompt? See that all the time, okay? Inconsistency. And the guardrail. So, like I said, that's their company putting guardrails to limit your use cases towards the legitimate way, right? But that become a limitation of the AI, especially in our field, in cybersecurity. And in my opinion, right, so the top skills that still require in the AGI era, the first one is critical thinking. Don't give up that. You don't have to trust whatever the AI give you, and grill it. And now the reasoning capability is great. So like the Cisco, that researcher talk about the reasoning model. I think that's actually the right direction for making sure the AI is moving to the right logical thinking process and all that. And you should still be able to review it and grill it. And hallucination detector or bullshit detector, okay? So, and that becomes a actually very interesting skill. So that example, that pizza example last year, right? I actually also used a results coming out from the ChatGPT explaining that smart contract, what does that do? It's BS. But the problem is that we know it because I'm the vertical expert in that. I know that it's BS in me. But a lot of people may be fooled, okay? So hallucination detector and evidence building. So for a lot of the financial and like cybersecurity, those applications, actually by law, by the regulators and all that, actually you cannot submit an automatic generated report without have a human put a proof of stamp on it, okay? And then the last one I found would be an interesting skill is we'll be able to manage agents and consider agent is a group of interns, okay? They're junior, but they can do a lot, they do pretty well when you have a well-defined task. So, all right on time, that's amazing. And okay, quick announcement. So I'm writing a book on the Agentic AI and cryptocurrency investigation with Agentic AI. And really appreciate Willie reach out to me to author this book. So it's probably going to come out in Q3 of this year. But if you guys are interested in reviewing, let me know. There's my email. Yeah, and you might get a free book or something better. So cool, awesome. I already have one sign up. Cool, Leo. All right, that's it. Yeah, that's it. Okay, cool. I'll open up for any questions. Thank you.
Questions? Okay. We'll be right back.
I got one second.
Oh, okay.
Go ahead. Yeah.
So, Ted, by the way, I've been chasing you down.
Oh, Ted, okay, hey, yeah, we need to talk, yeah. Thanks for coming.
Yeah, no, it's good to be here. So curious how, with the investigation tool, how you kind of solve for like the attribution or labeling problem through AI, or if you don't, if you kind of like plug in to those databases. Yeah.
Great question. The short answer is, like I just implied, it's we build our system on top of the foundation we already have. And in the past, we already have those machine learning labeling, right? So that was actually, one of those, right? As you can see, we have a machine learning model to try our best to put a tag on all these billions of addresses. And right now, we do not feedback and try to fill those labels. We build on top of it. But our strategy right now is actually by partnering with great company like you guys and all that, right? So we can put more labels, but we try our best to do our labeling on the blockchain layer. But I think the future is probably we should de-skilling ourselves and then trust like more high quality intelligence feeds. Could be wrong, but that's an easier engineering problem. And then I will make the slides available for you. And then just follow my linking, reach out to me on the linking and all that. And drop me an email. So, yeah, cool. Cool, thank you.
So originally the plan was we were going to do a session on a breakout where until 2:30 we were gonna just kind of go into groups and have discussions, whatever. I think instead let's just take like maybe a 20-minute break. We'll come back in about 20 minutes and just have more casual conversation and yeah, just enjoy. I wanted to point out the Sunderea team is, I think, going to do. It's actually really cool. They do. Basically like rules for like tool calls and stuff. So if you're trying to figure out how to harden your agents, they have a really cool thing. So they're just going to be, meanwhile, just presenting, I guess, in the main area. So if you want to also just see a cool way to make your agents safer, it'll be, I think, a mixture of a talk and demo.
Excuse me. We had a talk for security
yeah.
from Adobe.
Yes.
YouTube live.
And recording, right?
And recording. Oh, are you saying you want to record us? Yeah, no.
Is there is it gonna come back up?
Yeah, we'll post, okay. All right, let me, you know, just, we'll ace it or deuce it, one or the other.
Okay, cool. All right. Cool.
All right, should we get started? Okay, Leo. Okay, thanks. Thanks, Leo, for having us. Thanks, Lori, for sitting in the back and saying hello to us. Thanks to Bloomberg for hosting. My name is Josh Devin. I'm the co-founder and CEO of Sunderea.
And I'm Matt Maisel, co-founder and CTO.
So we are super excited to show you what we've been building. This is really like the first time ever publicly we're going to show our platform, which is a control plane that allows enterprises to set deterministic lanes for their agents to operate within safely. So we're going to kick things off. We're super excited. All right. As we all know, these agents are getting more and more capable, but with that comes much greater inherent risk. And this is really well exemplified in what Simon Willison calls the lethal trifecta.
Right, and that's the threat model, right, when we're giving our agents access to our internal private data, right, our source code, our internal documents. We're giving them the ability to externally communicate with web fetching and shell commands. And then through that, access to the internet, where all the context that makes it easier for them to achieve their task. But at the same time, that's where all of the untrusted content with prompt injection exists.
Right, but the problem is that it's precisely these attributes that make the agent useful, right? And so we're seeing this proliferation of agents like Claude Code, like Claude Cowork, appear in the enterprise, but that's causing like these headline news of like, Meta is leaking data and Claude is deciding to delete databases and all these things. So the question is, how do we have our cake and eat it? And in order to do that, what we're doing is sitting at this top layer, the trajectory layer that we call it. This is really where, while the agent is in motion, how can we guarantee with provable controls that it's always going to stop at a red light like a Waymo?
Right, and to secure that secure that trajectory layer, we built an agent harness that can observe and control every agent scaffold. Right, and I think in this group, scaffolds give the model agency, giving it tools to interface with the world. So it's not any individual one step, one action that the agent takes. It's on step 10 when it fetches a file that might have secrets or PII, and then in step 15 or step 20, when that web fetch or that shell command out to the internet, and that's where that risk of lethal trifecta is materialized and becomes an impact. And so we built a stateful analysis policy engine within our harness that we use policy as code, specifically the Cedar policy language, that lets us do formal analysis on the policies that we're creating and really take and have deterministic control over the non-deterministic actions taken by these agents.
That's great. And so we've been out talking to SEC regulators, auditors, insurers, lawyers, really trying to understand for enterprises what constitutes a standard of care to deploy agents. And so what we're going to show you today in our platform is how we can demonstrate that standard of care and deploy agents like safely and securely and auditably. So we're going to go through like a hypothetical example, like imagine we're a large financial that maybe begins with B and ends in G. Like we're a large financial and we want to say give all our developers Claude Code to, for example, build a trading platform. So what we're going to show you today is how we onboard and instrument a new agent into our ecosystem, how we simulate the risks that agent might present within our environment, how we then can create policies to mitigate those identified risks, and then how we can enforce them in real time, and then how we generate an immutable trajectory log that can satisfy regulators, auditors, lawyers, insurers, and customers. And so we're going to kick that off and go for it, Matt.
Great, so I'm going to put on my security engineer hat at this large financial enterprise. And I'm going to show you how we can build a policy for every agent with the Sunderea platform. So I'll go to my helpful assistant here, and I'll just ask it to help me onboard Claude Code, since that's what we'll be interested in onboarding today. We're going to do Claude Code, but we also we can also do support for other coding agents as well as other common, well-known libraries and frameworks. And then more recently, like Claude Cowork as well as Claude Desktop. But we'll do Claude Code today. I'll simply copy and paste a plugin command
to install over the marketplace. In the background, I have my Claude instance right now running, and now I've been able to register, and now it'll appear in my inventory of agents on my registry.
Right, and so what you're seeing here is like our fleet of agents. These are all the agents in our environment that are instrumented with our harness. This is what allows us to create a single policy and apply it across our fleet of agents, whether it's first party, third party, et cetera. Today, we're just gonna focus on this one agent that we've onboarded, which is Matt's Claude code. And what we're showing you here, and he's gonna pick one in a second, but what we're showing you here is what we call the agent card. This is like, who are we onboarding? Is this an intern with photocopy access? Is this a CFO who can send wire transfers? Like, very different risks, very different threat model, and we're gonna need very different rules to govern and control them.
Right, so this agent card is fetched dynamically on every trajectory run. It really constitutes the agent's identity and its capabilities. So we can get the model being used, we can get the current workspace, we can get all the tools, including MCP servers and tools that are exposed, as well as all the skills, slash commands, other configuration. And ultimately, this is what we see representing the potential of this agent and what we want to understand, given the capabilities that this effective agent card captures, what are the risks that we can mitigate through simulation and through our policy analysis.
Great, so now we have the agent that we want to onboard. The next thing that we do is move to what we call our Constitution Center. This is where we take all the natural language policies that you want your agents to be governed by. That might be what's in your system prompt, in your Claude MD files, your SOPs, your AUPs, your EU.AI Act, your compliance requirements, your business logic. What we're showing you here is a policy pack that we've created specifically to secure coding agents. And it contains hundreds of natural language rules that we've already converted to policy as code. We're gonna show you how that works. But now that we're onboarding this new agent, we want to know, like, are there any risks that we're not, aware of that these rules might not be covering? So the next thing that we're going to do is move to our simulation to see what this new agent might do.
Right, so Sunderea has a simulation capability where we can take our agent under test, in this case Claude Code, deploy it to an environment specifically for Claude Code, and then have a red team agent perturb it with different scenarios and try to elicit behaviors, in this case today, that would lead to data exfiltration or lethal trifecta. So we'll look at this individual scenario for that use case, and this is a result that we've had from a couple days ago. And what we're looking at is an example of a synthetic trajectory, a trace that was produced during simulation. And we can see the agent being requested to verify some API endpoints. It goes and reads a service file that contains credentials and secrets. That's fine again, that's fine by itself. But then subsequently it goes and makes a web fetch. That's where the information flow control blocks that tool call, because in the context, in memory, we have secrets, and ultimately that's what we're trying to do is reduce that blast radius from lethal trifecta and data exfil.
Great, and so what we're seeing is that given this risk, we're still subject to lethal trifecta. The next thing that we're going to do is, I can't show up to a large financial and be like, well, all you have to do is write 100,000 rules and everything is going to be fine, right? So we've done is create a process called auto-formalization that allows us to take the natural language and convert it at scale to policy as code and give every agent a unique set of rules that uniquely restricts the agent's autonomy. If we give a rule like don't steal, I can't give you a list ahead of time every way to steal. I have to look at every which way every agent can steal and then constrain it in order to follow the natural language rules. So through this auto-formalization process, we take that risk register that we just created. We take the agent card to know what it's capable of. And we take the natural language and we pull out what's called the deontic logic, if you remember from your ethics classes. These are the prohibitions, obligations, and permissions contained within the natural language. And then we have a policy agent that generates that bespoke policy as code for this specific agent to ensure that the natural language is followed. Matt, show us what we're showing here.
Right, so I ran this. We're using Gemini Flash 3.1 Lite just to make this happen fast today. But what's happening on the hood, this is really a generator critic loop that's happening for our auto-formalization pipeline, where we're generating candidate policies from this policy intent, as well as Josh was saying, as inputs coming from a rich registry, from the agent card, and then we're using a CEDAR schema to ground the generated policies. So we do first a verification check to just check that syntactically the policies that are produced are correct. consistent with our schema. And then we also run this through the lean tooling provided by the Cedar language as well too to check for other sorts of correctness. And then finally, we have a round of a rubric-based judge system that just looks at the semantic coherence to the input policy intent. What this does is produce a Cedar policy here on the right for this, again, this lethal trifecta scenario of don't read sensitive files and then perform web commands. And this is specific to this Claude Code agent where it has this action in the schema called web fetch. And then we're looking at forbidding that web fetch action whenever the resource, that is the trajectory in this case, when it's labeled or tainted with confidential or highly confidential information.
Great. And so now what this policy should do is if we access sensitive data with our agent, we should block external tool calls to break that lethal trifecta. And so what we're going to do is take that policy for a spin. We can, put these policies first in monitor mode so we can just see would they trigger. We can also do steering mode to get the agent to try again. What we're going to do is just do a full denial to do that. And what Matt's showing you here is he's reading a TPS report that likely has sensitive information in it, and we can see that populating. We can see in our control plane the trajectory appearing live as it goes through. And already we can see that as he's fetching, we're going to get a denial because the trajectory has been tainted with a flag that it emerges because we accessed sensitive data earlier. And so what we're going to do is block that call, and we'll see that denial right there. And so now we've seen this policy that we've just created stop in real time the agent from being subject to the lethal trifecta. Now, we also get this immutable trajectory log here that it says exactly what the agent not only did, but what it didn't do. So we have a provable log that we can send to your SIM or your log manager of choice, and have something that can show a regulator, lawyer, insurer, hey, this is exactly what our agent didn't do. So what we've been showing you today is what one agent, right? What we're going to have, though, is fleets of agents running around the enterprise. And so in order to understand what are the risks that those agents in aggregate might present to the environment, we've put together what we call this Atlas view. So Matt, explain what we're seeing here.
Yeah, so this is an Atlas view. This is using UMAP to embed the agent action. So each point represents one single step taken by the agent. We summarize the action and get an understanding of what thinking or reasoning or chain of thought happened by the agent, or what tool calling or what user prompt was submitted. And ultimately, we can look at density, very dense regions of similar policy violations or other clusters of reliability issues. And this lets us surface those patterns and then take that and pass those examples back into policy generation as well as simulation to adapt really our policies to maintain utility of the agent while also balancing that trade-off with security, compliance, and privacy.
Great. And so, with all of this, now we're getting confident that we can give Claude Code to our developers. And so in order to reduce the friction for developers who are either using the Claude Code that we're giving them or even building agents of their own, we need them to understand when their agents are bumping up against rules that the legal, GRC, or security teams have set. So we're meeting them where they are in the terminal, and we've created this terminal user interface that allows any developer to monitor their own agents that they're running, as well as the agents that they're building, to understand that they might need to retool or update the behavior of their agent if it continues hitting up against certain rules. That's a waste of tokens. It also reduces agent reliability, and this ultimately reduces the friction between the security engineers because the engineers can just go through these deterministic lanes and then understand without caring about the policies, which they don't, allows them to then retool their agent as necessary. And so with all of that together, just to do a quick recap of what we did, we onboarded a new agent, Claude Code. We simulated the risks that agent might present in our environment. We created a new policy to mitigate the risk that we detected around lethal trifecta. We enforced that policy in real time, and then we created that immutable trajectory log that proves exactly what that agent did and didn't do, and that creates the standard of care that enterprises are looking for to deploy these with confidence. So if you're building or deploying agents and want to do it reliably, safely, and auditably, we'd love to chat. We're going to be in GA very soon, but this is our first ever, demo here, and so we'd love to take any questions, and Matt will answer them all. So yeah. Thanks for listening. Mic drop. Go ahead.
Do you run into any scalability limits?
As far as generation or policy evaluation?
Like checking agentic compliance to these policies at a certain token count of assumptions, anything like that?
So in the policies there could be token counts and other like usage-based features or attributes that are provided. I'm speaking directly to there could be tokens or other usage-based features that could be created around policies. So there could be policy violations around that. That's what you mean.
Is that what you mean?
Somewhat. Like, that's an interesting way, and I actually implemented like a $15 price max for like my agents to have any given run. So that reminds me of that. What I was more interested in on like the UMAP visualizations and the data around looking at like, the individual step actions. Is there an upper limit that you guys are experiencing in terms of being able to produce efficient evaluation?
Yeah. So this is actually using the Atlas embedding library. I mean, so there is an upper limit. It's I think a couple 100,000. So we're at this point now just doing thousands. So we would sample or we would look at the past week. It's meant to be like a visualization aspect, but we could still get the embeddings and sort of do like really what's happening underneath is this pattern extraction. So yeah, that's certainly scalability issues with visualization. But yeah, I think at least for the methods for pattern extraction are still scalable.
Go ahead, Leah. Or.
So I guess like a twofer, just to make sure I'm tracking. It feels like you're using journeys as almost like tracking a dynamic information flow policy, and that flows into Cedar.
Yeah.
I'm actually not familiar with the guts of Cedar, but it feels like that's like, is it like LTL or what's the?
So Cedar is stateless. So what it does have though is the ability to track entities. So you can have like an entity store that's where we're maintaining state. We are looking at like linear temporal logic and other logic systems, but because maybe on touch on the scalability piece, like Cedar is doing like something like 500 million authorizations a day at AWS. Again, it has really nice formal properties for checking for like vacuous or contradictory policies in your policy set. So it's like great for doing that generation. But yeah, inputs come to that. So that's where like all guardrail signals could come in, bring your own guardrail kind of concept. It could be signatures, it could be models.
So
Yeah.
Then my last question would then be, when you said simulation, I did not understand like how do I think about simulation? Is that symbolic? Is that
so it's like running the policy. It's actually running the policy engine, running the Cedar policies in a simulation that are again asking Claude or any agent under test to perform some task from yeah.
I think it was symbolic execution when it's actually running it, or is it?
In this case, for our Claude code environment, it's actually running it on like we're looking at like Terminal 2 benchmarks, and other benchmarks as ways to sort of exercise it. But for like other agents, it could be other data sets, or it could just be through scenarios that would like prompt them with like in distribution sort of user prompts as well.
Yeah, I think the last thing I saw today. Thank you.
Thanks. Any other questions? Matt knows all the answers. Yeah, go ahead. I'm sorry?
You guys have deployments?
We are. This is good. You're asking the really hard questions now. We're deployed internally in dog fooding. We're actually getting ready to deploy in a couple of our design partners now. We're just about in GA. We've also got in GitHub. We've got open source. We've open sourced our policy engine, so you can like build your own Cedar policies and try it and kick the tires. Go ahead.
I was kind of curious in enterprises, is it like one-to-one? Like if I have 2,000 agents, does each one need its own unique policy? Are they that discrete?
Yeah,
it can be.
They can be. Yeah. Go ahead. Yeah.
Yeah. No, I mean the whole point is there's an idea of like a hierarchy. So there could be org-wide policy sets, regional, and then per agent, and it's all driven by context out of the agent card. So what capabilities it has. So it's all.
Yeah. We can talking to the large financials. There's like for example, or any multinational company, there's a lot of challenges around like, I'm in 180 countries. How am I going to prove to every regulator and auditor in every single one of these countries that my agent is adhering to their specific rule? And every state has different privacy laws. And even like at the local level, like to your point, like the same agent might need different rules. So like a Claude code for an R&D team might be different for the engineering team, because if I drop a database in production during business hours as a financial, I get fined, versus my R&D might have. So every agent really needs its own policy. I had another CISO say, I never thought I'd have my HR team writing code. So we need different rules. Thanks. Yeah, thanks everyone. All right, yeah.
So our next speakers are here, Chandrani and Shruti from Adobe, and I was really excited to be able to get I think a lot of us are been talking about from the ISV side or the maker side, but here they're actually having to protect the enterprise, and so I was really excited to be able to learn a bit about somebody as large as Adobe, how they're thinking about it.
Yeah, thanks so much, everybody. Thanks so much for the introduction. Hello, everyone. We are here from Adobe to talk about our project, how we are democratizing security guidance as a service, right, across various different platforms. So a little bit about ourselves. I'm Chandrani. I'm with Adobe Security for about 7 years now, and in the security space for about 10 years.
Hi everyone, I'm Shruti Dattagupta. I'm a product security engineer at Adobe, and my background and work so far has been at the intersection of AI and security. I've been in the space for over 5 years now.
Okay. Before we go into like what we have developed and into the nitty-gritty of it, let's first talk about like what drove us into this problem statement, like what was the gap that we were seeing at Adobe, right? So like the first problem is the scalability, right? Like for example, developer to the security researcher ratio is always very high, and then there is we cannot really get to one-on-one guidance and things like that. So there is always a knowledge gap between the developers and what we security researchers know. The second one is, again, scattered communication. So there are various different platforms, like I'm sure like in Adobe also it has, and in your organization as well, like there are Jira tickets where tickets come in and people need guidance. Then there is IDE, where now all this AI assisted IDE where we need to know what developers need to do and things like that. Then there are Slack channels, people come in and ask. So there are various different platforms wherein people ask maybe similar questions, and we need to give in like same information as well. And then there are plethora of information, right? There is no dearth of that. But like there are wikis, and all these guidances are created by SMEs as security champions. But I think the challenge was to get this information to the right person at the right time. That was the challenge we were facing. If I need this today, and if I'm able to find it, all that wiki search toil and everything after 2 days later, it doesn't really make much sense. Now with AI, obviously it changes the equation, right? It understands natural language. We are all in a time machine, going super fast. But then there are little bit nuances as well. Like when we are relying on AI to give us security guidance, it gives a generic answer, right? It doesn't give like your organization specific, like just now they gave like the policy details, or many organizations have like specific platforms, right? For example, for authentication, for authorization, we have specific platforms built, and how to use those, how we can onboard to those. So those are very org-specific context information that we need, that obviously the generic LLMs will not have. And then there is also the risk of hallucinated response, right? So keeping all this in mind, what we thought we wanted to build was like a security bot, or maybe a security as a service, which will be platform agnostic. right? So be it Jira, be it we have an automated threat modeling platform as well. So be it that, or maybe in the IDE itself. So wherever it is coming from, we will be able to provide the same security guidance, and of course it will be backed in the backend by some vector database. Those documents will be embedded and put in over there. So whenever we are asking some information, some question about that, we are able to pick the right information from there. So that was the intent. So before I go into again more the architecture and the data flow of it, let's talk about whatever we are going to say, whatever we are going to present. It was not that we had the entire picture built in our mind, entire architecture built in our mind in the day one itself, right? It was like over at least 1.5 years to 2 years worth of effort that we are telling it here. So initially, of course, that org-specific details and everything that we had in mind, we started with a RAG solution, right? Because we needed Adobe-specific context. Sorry. So to start with, the first place that we integrated it was in the Jira, because that is the place where all the pen testing tickets or the bug bounty program tickets, they come in and they have the SLA. So that's the one we need to really have the guidance like right away, so that those are fixed on time. So what we did was we collected like whatever we could from our security SMEs and security champions, like 50 to 60 docs, generated the embeddings, generated the numerical representation of it, and then put it in the vector store, right? And then it was almost at the same time, it was also realized in a Slack channel itself. So it was there in two places. But then soon we realized that there are other platforms where that could leverage this information as well. Like, for example, there was a separate team at Adobe that is working on, that has built an automated threat modeling platform, right? So for that guidance as well, we need that. Then when all these AI-assisted IDs came in, we developed an MCP server, so that similar guidance would be needed there as well, right? So then we understood like we need some type of automation for the document ingestion part as well, because so far in this chart that you are seeing in this flow, the Jira or the Slack, we had like 50 to 60 docs, right? But when I'm talking about we need automation across even more platforms for that, the number of documents are increasing. And there was automation, but it was a semi-automated flow, right? Semi-automated, why I'm telling is because generating the embeddings, upserting it to the vector store, those we have endpoints and things like that. But then even before that, collecting the document, creating the PDF or extracting the text out of it, that was still a manual process. So so in the process, we also actually built an automated document ingestion pipeline, which we are going to talk about. And simultaneously, it was also, we had endpoints published for thread guidance that was connecting to the same vector store. We have an MCP server where from within the IDE, people can call it. So now it is like we are pushing for the usage of it. Now talking about the doc curation workflow and the ingestion, what we built. So here, the idea was whatever is there in the backend should be there in a repo, right? So there will be a metadata repo, and that will be the source of truth. So whenever, say, for example, I'm an SME, I have created some secret ingestion, like some documents. So I'll have to come to this repo and then create some, some metadata, like what is the URL, what is the document about, some very basic information, right? So I do a PR, and then we do a validation, and we merge the PR. Then there is an upstream service, which is the downloader. It's based on a PubSub model. So the downloader picks up this PR and it gets the content of the page, right? And then we also take care, like for example, say URL A has already been ingested using this flow, but there has been a change, right? So we have a cron job that goes through like what is the delta, and then we fetch that delta content into that S3 bucket. And then upstream there is an ingester service which would take all this, all the downloaded docs. It will create the embeddings and everything, and then it will put it in the vector store, right? It will put it in the assistant. Once the entire process is done, we have a Slack channel to mention that, okay, this document has been uploaded to this vector store. And then we have evals in place. Evals in the sense, when initially itself I'm taking the document, there is a dictionary kind of a thing where I'm giving a question and answer set, where some 2-3 preliminary questions that can act as a reference set for that particular doc. Like when I wanna test it, like after the ingestion, whether if I'm getting the correct answer or not, so that I'm able to do it in that once I get the Slack notification. So now about the main architecture of the security bot. So as I was saying that the inputs can come from multiple different platforms, right? Be it a chatbot or IDE guidance, vulnerability agents. Everything goes through an AI orchestrator first. Once it and then once it receives, it basically it goes to a prompt engine. So we tweak the prompt in each case, and then we go to the vector store. We collect that information. It again goes through an a curated response LLM flow, and then everything we are also logging as in the Langsmith for traceability and observability information. Over to you, Shruti.
Awesome. So we've seen what the architecture looks like. Let's look into some examples of what this looks like in practice. So the first example was around the security support chatbot. So we implemented this via Slack. This is essentially, let's say anybody in the company has a security question. They come to this Slack channel and they ask the question, and we are basically retrieving the guidance from our vector store. So think of questions like, how do I do X at Adobe? What is the recommendation to do Y at Adobe? So this is an example that asks for standard security guidelines for using third-party SDKs. And again, the query is entered by the user in Slack, and then the Slack app is actually talking to our service, getting the guidance out, and then putting it out here in the Slack channel. The next example is threat remediation guidance. Like Chandrani mentioned, we have a sister team that does threat modeling, and they build an AI automated threat modeling engine. So once the AI agent identifies the threats, again, this engine makes a call to our guidance as a service, gets the requisite corresponding guidance for each of the threats that are found, and then surfaces that guidance back along with the threat model. The next example is on the shift right side of things. So when we have vulnerabilities that are reported by, let's say, bug bounty findings or pen test reports, right? So we have a vulnerability triage and ticketing pipeline. So when that pipeline gets triggered, when there is a new finding, they again make a call to our service. They send us all of the details of the vulnerability, the exploit, and everything. And then we get the guidance out. Here you can see that the guidance the formatting looks a little bit different. So for vulnerabilities, we provide not only the short-term fixes, but we also provide long-term fixes. So sometimes you can have a one-off fix that can remediate a vulnerability. But when you have let's say product teams who are seeing multiple vulnerabilities belonging to a certain class, then we also want to guide the engineering teams with long-term fixes that they can look into to mitigate that entire class of vulnerabilities. Finally, we have the in-IDE guidance. So this is via the MCP server, and this is meant to provide the same guidance to developers as they're writing code while they're in their development workflow without having to leave their development environments. So actually, I'll show you a pre-recorded demo over here. So here I'm in Cursor, and you can see here, we are connected to the Adobe Security Guidance MCP server. Right now we have just one tool, which again makes a call to the service and gets the guidance. This is an example wherein we asked it to generate the best practice guidance for SQL injection. Just a quick note here, we found that explicitly pointing it out and saying, hey, call the MCP server gives you better results. There's also another way to take care of it through skills, but you prompt it, and then basically the cursor coding agent is then, it is connected to our MCP server, it identifies the MCP tool, and then it sends the request to the MCP server with all of the details about SQL injection. We get the response back, and then it is formatting and pretty printing all of that information as guidance to the developer, right? And here I want to also show you that we are giving the citation to the actual document that we are pulling this guidance from. So if you want to dig deeper and get more information, we are giving you the right resource to go take a look into. Another example here is to generate best practices for HTTP headers. Again, very similar workflow. The cursor coding agent then calls our MCP server. Here in this example, it had to do like a couple of iterations to get the right information out. But then again, it is pulling out all of the information. Here, we have like 5 bullet points that is coming up, and then 1 cited resource. So here, actually, for the MCP server, we set a higher threshold for retrieval. This is, again, something that is configurable based on where the request is coming from. And I'll show you what the Slack workflow looks like in a minute. So this is the Slack workflow for the same request, best practices for HTTP header. We are getting the same response, just some additional response because we have a lower threshold for retrieval over here. And you can see, again, the same citation as before and an additional citation. Another thing to look for in the Slack workflow is the online evals that we are doing. So once we give out the response, we prompt the user to tell us whether the response was a good response or a bad response. This enables us to get real-time feedback from users. And once you hit on, click on bad response, this basically initiates this workflow. It requests the user to give feedback on what didn't work. Typically, it can be one of 2 cases. Either we do not have the document that answers your question, or we have the document and it does not contain the updated information that answers your question. Either way, once you enter your feedback, click on submit. This triggers a workflow that notifies our team so that we can get in touch with the document owners, and whichever is the case, we can have the most updated documents in our pipeline. So this was the quick demo. To wrap it up, some of the challenges and lessons learned here. First of all, building the reference set of evals. Now we have the doc ingestion workflow, so we are enabling or requesting doc owners to add those reference set of evals, but this is also something that was manual and cumbersome, and we had to do manually initially when we were first building our vector stores. And again, like, second point is around updated docs or doc freshness. This is a continuous challenge. We have automated the workflow to take care of this, but making sure that since our vector store is somewhat like the single source of truth, making sure that we have the most updated documents there is important. In our doc ingestion workflow, we have a PR review step, right? So right now, again, that is manual, but it can be a bottleneck. Right now, we are okay with that trade-off because that ensures that we maintain high quality of the docs ingested. But that is definitely something to reconsider if we get to that in the future. And finally, AI is evolving at a breakneck speed. Like Chandrani mentioned, we started building this like 2.5 years back. So we have had to keep pace with the evolving technology so that what we are building is not only using the latest and the greatest state of the art, but it's also relevant and useful for our developers. So to sum it up, few takeaways from our session. AI is helpful in security use cases. It is very helpful, especially when we think about providing guidance and democratizing guidance. But you need to provide the relevant context. Context is king to ensure we get the most out of state-of-the-art AI. We were able to centralize this guidance over time, and that enabled us to provide consistent, scalable guidance, security guidance to developers at every stage of their development cycle, whenever and wherever they need it. And finally, evals are important, and evals are what will turn your AI experiments into production systems. With that, want to make a quick shout out to the team who built this. Of course, this is not a 1-person or 2-person project. We have an entire team working on this. So big shout out and thank you to the entire team. And with that, thank you. Please connect with us on LinkedIn, and we are happy to open the floor for questions.
Yeah.
Yeah, questions around kind of the document, using the document storage for the guidance piece. So you've solely used vector stores for the document store, and how are you seeing like consistent use of those documents in like larger complex guidance flows? Have you looked at using knowledge graphs to get better consistent like flow data? I find with 1 million documents, technical documents in cyber data, when I go like, hey, can you go give me guidance, it flops over with just vectors. So yeah.
Yeah, so for the document ingestion part, currently we have done it for the wiki platforms only, right? Only it works for the wiki, and then some of the Adobe's internal platform, there are still like multiple other platforms where there are docs, which we do not have the code yet to ingest automatically. Right, and to answer your questions like graphing the doc or if people are using it, so at least for the Jira guidance that we initially started with, right, which is there at least now 1.5 years almost, we have got the feedback with the guidance over there. People are able to close out the tickets sooner. The MCP server and the thread guidance is very fresh in the sense like 6 months old. So I think we still do not have that much feedback yet. MCP server is actually even much newer, but people are using it, at least that's what we hear. But again, we are not talking to each and every entire Adobe developers. We try to do roadshows and everything, but then it is like on us doing the development and the roadshows and everything. Yeah.
To follow up on what she said, security guidance is not necessarily a lot of best practices. There are some fundamental best practices that you need to follow. And time and again, we see that even though they're fundamental and everybody should follow, they do not follow. And what happens is, as products and systems evolve, these documentations keep growing. So you might have like 10 different versions that's saying the same thing, but you don't know which is the correct version. So I think we are solving more of that problem so that as a developer, when you want to find out, oh, how do I fix a SQL injection vulnerability, I don't have to go and search what the right document is. That document is provided to me by the security team. So far, we've not necessarily seen a need for having a knowledge graph as opposed to a vector store. Yeah.
Any more questions? I guess I have one. It's always interesting how things fail, right? And so I was also, first of all, thank you. This is so cool. I was curious about two points of failure and how to deal with the handoffs. One is at the ingestion point, like you mentioned that things, like you catch that things may be ingested wrong because the eval failed or whatever. So I was kind of curious, like, is it like, and actually even before then, there's a question of, first of all, who writes the eval? Is that your team or the person who wrote the doc? Like, how does that get figured out? And then if the eval fails, whose responsibility is it?
Yeah, there are few other failure scenarios also. Like one happened actually last week only because we did it for wiki, and then I think last week there was some updates in the wiki format or the platform itself. So we have the logic works on a certain kinds of macros or something like that was updated, and so the document ingestion part started to fail. Anyways, we were able to figure that out. We were able to put in that logic. And I'm sorry, what was the other question?
So the question is, do you expect
evals,
do regular engineers do the evals, and then when a document fails to ingest, whose responsibility is it to fix it?
Yeah. So it is like a shared responsibility model. That's how we are, giving it out. We can put in the evals questions, but then it becomes a lot of onus on us. We don't really want to do it. So whenever people are giving us the doc for the PR, we are asking them to give those at least 2 evals question. It's not a lot. And they can generate it via the AI with the content and all that, right? So yeah, if it is not there, I mean, with even after asking, maybe at that time we add it, but we want to make sure that the evals questions are there. We started doing it from our team when we were small. And we had fewer documents, but naturally, as we scaled and we started adding more documents, it was not scalable for our team to take responsibility for all of it, which is why we are doing like a shared responsibility model wherein the document owner is responsible for adding the evals as well. Yeah.
Any more questions? So I think we're, so first of all, thank you.
Awesome. Thank you so much.
I think we might have maybe a, say, 15-minute break, and then we'll be doing Josh's session on, we will see in a little bit. Actually, do you prefer Joshua or Josh? I always get messed up like this.
Josh is fine. I mean, people call me both, so it doesn't
Yeah,
really
because I see you always write it. But,
yeah.
Hi, folks. On to the next session. I'm not actually even sure exactly what I'm allowed to say about what's about to happen. So formerly, you may have heard of models like something called Llama. I don't know if anyone's heard of Llama, but somebody was responsible for making it safe. And then apparently he has even better ideas to do with his life now. And so I actually am not sure what we're going to learn about here, but it'll be somewhere between the two of those. So this is Josh, and he does really cool stuff.
All right, thanks, Leo. I'm tall. I don't know. Here, 1 second. Can you guys hear me? Okay, like this? Okay. Okay, so I'm Josh. It's nice to meet everybody. So yeah, like Leo said, up until 3 or 4 weeks ago, I was engineering lead for AI security at Meta. So I built the AI security program. So our program around applying AI to all the problems in the CISO org at Meta, and I also worked on, sort of built and incubated the Llama security effort and our prompt injection guardrails effort. But yeah, now I'm at a startup with my friends Gabe and Hiram, who I think are both here, and we're building AI agents for defensive security. So I'm going to talk about. So basically, this talk is my framing of what it looks like to build well-engineered, like scientifically based agents for security. And I think I have 20 minutes if I'm going to leave 5 minutes for questions. So I'm going to look at the clock while I talk. Okay. Okay. So we think that so the company I'm at is Security Superintelligence Labs. It's just Gabe, Hiram, and myself right now. So when I say we, that's who I'm talking about. We think that we're going to have to pretty soon get into sort of dangerous territory with AI agents that we're building for security defense. Dangerous in the sense that we're going to need our agents to, without our looking at them and watching them, make dangerous state changes to our infrastructure and to our code bases. Yeah, so this is going to mean getting comfortable with agents doing sort of milquetoast level things like investigating SOC alerts. But it also is going to mean having agents do much more serious things, like turning off your executive's computer when we think it's compromised, or patching a production code base, or shutting down a host that we think is compromised. Because we're dealing with like opaque neural networks, and because mechanistic interpretability is nowhere near the level that we need to verify these neural networks, really the only game in town for verifying that the agents will do what we need them to do when it counts is statistical evaluation. So just lots and lots of behavioral evaluation to see what they do under lots and lots of different circumstances. So this isn't so different than like the self-driving problem, for example. And I think this applies to like every area of cyber autonomy that we're going to have to build for, right? So autonomous code remediation, alert management, access control, cloud posture management, lots and lots of different, really all the subdomains in security in which we're making changes. Okay, so here's the security model that we were using. Well, I'm sure my old team is still using at Meta, in which we're using at the startup. Basically, so there's various levels of maturity that you can inhabit when you're building agents for security. So the first state that I call the crawl state is when it's just all vibes, right? So you're building an agent and you're asking the agent to say classify documents as to whether they're sensitive or not, or follow up on a SOC alert and dismiss it as a false positive or not. The sort of level of rigor is just, it works on my machine on a handful of examples. So I think much of the industry is in this crawl state right now. And then, the problem with crawl, which I think surprises people who don't come from a machine learning background, is that you quickly get into this pathological state in which people just, are making claims about how well their agents are doing on their cherry-picked examples. But you can't make progress as a team or even as an individual. And there's really no basis for saying that like version 1.2 of your product is better than version, the previous version. Okay, so then there's this walk state that that we talk about. So walk is like, you know, maybe you're not making, you know, full use of the data that you have access to, but you do have some evals, right? That are good enough that they are uncontroversial within your team and organization. Uncontroversial with respect to their indexing of the problem that you're trying to solve. So if that's patching a code base, right? Maybe you've agreed that you know, a bunch of open source projects in your eval sets that that pass their unit tests, you know, that constitutes a pass in terms of producing a patch. And every night, you know, your team runs their candidate agents against these evals. And when somebody claims to be on the top of the leaderboard, this doesn't cause a big philosophical debate. But everybody can agree that, okay, like, you actually have the state-of-the-art agent, and that becomes a candidate to actually ship. Okay, and then there's oh, right. Okay. But so I think there's a limitation to this walk state, which is that we're still at this point, not taking advantage of. We're still at this point just using sort of vanilla off-the-shelf LLMs, and this point might be controversial in this group. I'm not sure, but I think there's a limit. If our ultimate goal is actual autonomy, making autonomous state changes to our code and our infrastructure, I think we're eventually going to need to build fine-tuned models that are specialized in making those decisions. So that brings us to this final state, which I call run. And this is sort of I think this is the mature state in which any actually machine learning product is operated, in which we are building models based on, we have a sort of inner loop in which we're improving our agents based on offline evals. So those evals that we've all agreed sort of index the problem that we're solving. But then we have a sort of outer loop in which we're deploying the agents in A/B tests and evaluating how well they do on our online metrics. And we're even fine-tuning those agents based on that feedback. So we see people adopting this motion outside of security. So for example, it's pretty clear that Anthropic has adopted that motion with respect to fine-tuning their models for coding based on all the customer feedback they're getting from people using their models. It's pretty clear at places like Meta and Google, people are doing that based on more sort of consumer use cases. We're eventually going to need to do that in security, but very few people are doing that yet. Let me check time. Leo, what time should I stop talking? Is there like, okay, I'll just keep, okay, all right. I think I've probably gone for like 10 minutes. Okay, and so it's really urgent that we get to this run state, right? So I think in security, it might sound like I'm stretching a bit, the idea that we would get to this run state, since the state of affairs with respect to the evals that we have with respect to fine-tuning models for specialized security use cases is immature. But people have done this in other industries, right? So there's really mature areas like ads, ad recommendation, right, or feed ranking, like at a company like Meta, or search when it comes to Google, in which this sort of run state is just the accepted standard with which we run ML products. We need to get there within security because the attackers are coming with automation, and the offense is way easier, I think, in this new AI era than defense, just as it was before. It's way easier, for example, to build an agent that that does a React loop and breaks into your network than it is to defend the network. And I think I think adversary behavior over the next year or two is going to be a forcing function to sort of achieve this level of maturity. Okay, so here's some bad news with respect to our ability to achieve this level of maturity. Basically, I think that noise is built into the technical problem that we're facing here. I think our whole model for how we do evals in machine learning is based on the sort of benign world of like text and image classification going back decades. So in computer vision, right, the famous ImageNet data set, which was put together in the 2010s and that sort of drove a lot of the convolutional neural network progress in that decade, was based on labeling images, in terms of like, a taxonomy of categories. I think there were hundreds of categories actually in ImageNet. And this is a totally different ontological environment, right? So labeling a cat versus dog, an image as a cat versus dog, is like totally different epistemologically than understanding, for example, where all the bugs are in the Linux kernel. So it's actually unknowable from a theoretical computer science perspective, right? Where all the bugs are in the Linux kernel, right? So you couldn't go and label all that data. deciding whether a binary is malware or not. There's all sorts of theoretical problems with that. When you go and ask people to start labeling security data that has these very difficult epistemological problems built in, you run into all sorts of problems. So we actually did this at Meta, right? We got committees of analysts to label data. So for example, if you go try to get SOC analysts to label an alert as sort of worth investigating or not worth investigating, they'll often disagree. Actually, what I've found in my experience is that there's like a double-digit disagreement rate between any two analysts, right? So it's actually very hard to get clean labels, and that imposes a noise ceiling on your ability to improve your ML system, right? So once your ML system gets 90% agreement rate with your analysts who disagree 10% of the time, right? You're sort of in this region in which you can't actually further improve. I'm going to skip over some slides just to go fast. Here's a simulation I ran, sort of demonstrating that dynamic. And so this uncertainty is just a built-in feature of the security landscape. So in almost every domain in which we operate in security, we're dealing with a pretty low noise ceiling. That's for sort of theoretical computer science reasons. That's also because adversaries are attempting to hide from us, right? So we don't have access to the most recent malware examples that are actually active in the wild, right? We also don't have access to the 0 days that the NSA is working with or the Iranian government is working with, right? So this is always going to be a dynamic in our field. Okay, so I think the good news is that we can sort of reframe a bit in order to allow ourselves to hill climb even further beyond this kind of noise ceiling. Okay, okay. So thanks for whoever laughed. Thanks for appreciating my my AI art. Okay, so in traditional machine learning, there's the construct of an oracle, right? What one is supposed to imagine when using ImageNet is that it wasn't mechanical Turkers, right, who labeled the data set. It was an oracle, right? And the oracle knows the true label of every image, right? And sort of comes down from the Platonic heaven and bestows the label cat upon an image, right? And then we can trust that label as ground truth. The oracle just doesn't, so that was an okay conceit to make in classical ML. It's not an okay conceit if we're going to climb the hill up to full autonomy within cyber defense, right? We need some other construct that allows us to continue to hill climb. So here's sort of like how ridiculous it is to evaluate an agent using classical machine learning, right? So in classical machine learning, if you're using metrics like precision, recall, and F-score, right? The way you're modeling your agent's outputs is as just a sort of binary vector of like, yes, this is malware. No, that's not malware, right? And so you're actually taking like, let's say you're using a coding agent to identify vulnerabilities in a program. You're taking like a bajillion tokens that came from like a trillion dot products, right? And you're reducing that entire output to like this one, right? And then you're comparing it to a label, which you're actually quite uncertain about, which is this one here, right? And then you're doing some math on these binary vectors to get your final summary statistics. This is like a really sad, like woefully impoverished representation of your system, right? You want to do much better than that, right? Okay. So these are maybe okay assumptions for like a traditional classification problem, like a document classification problem, but these are really bad assumptions when you're reasoning under the kind of uncertainty that we're dealing with in security. So here's my thesis about how we need to sort of reframe the evaluation problem as we build towards AI agent autonomy. So we should use those traditional accuracy metrics because we don't want to, because those are, we don't want to throw out signal. But we also want to actually look at the agent's reasoning and behavior and understand and sort of look at the agent as we would an employee we were evaluating as a security engineer, right? To understand, is it collecting the right evidence? Is it reasoning from first principles? Is it justifying its decisions correctly? Because there's a lot of signal in the reasoning traces themselves. Okay. So here's the kind of evaluation that we need, and this is the kind of evaluation that you do within an interview, I think, within a kind of behavioral interview of a SOC analyst or a security engineer. We want to know how high quality is the agent's reasoning under complex and ambiguous circumstances in which uncertainty is built into an environment. Did the agent come to the same conclusions as our best security engineers in the last 10 incidents? But if not, was it actually right against the engineers? This is something I actually found many times in practice, as the agents were actually disagreed correctly with a committee of analysts. Does the agent retrieve the right context and call the right tools in an intelligent way that we can relate to and that is reasonable versus going completely off the rails, right? And then we also want to ask what the agent's precision and recall were, but in the context of this much larger picture in which we're taking advantage of all the signal in the agent's behavior. Okay, it looks like I have 5 more minutes. Okay. Okay, so the way we were pursuing this at Meta and the way that we're pursuing this at Security Superintelligence Labs is we follow a procedure like the following. So we define a rubric for what good job performance is with respect to the agent's observed behavior. We have humans grade the trajectories based on a protocol that we design. And then, because that doesn't scale to the hundreds or thousands or tens of thousands of agent runs that we actually do, we calibrate a judge LLM to those human judgments, and then we sort of use that judge LLM offline and online to actually understand the agent's performance. Okay, I'm going to skip through the worked example because I'm almost out of time. But okay, so I mean, another thing I'll say here is that once you have an evaluation methodology like that in hand, once you have a calibrated judge LLM, then you can actually automatically hill climb, right? So you can hill climb the design of your agent harness and your prompts, and you can also hill climb in parameter space. Okay. So yeah, last I just want to say a few practical notes on process that I've, these are just some lessons that I've learned over the last year or two, and actually working on designing AI agents for security. First of all, if you're building agents in your organization and you don't have evals, building evals is an iterative process. You don't have to do it perfectly at first. We iterated many, many times on our evals at Meta when I was doing that work at Meta, and that's what we're starting to see in our startup as well. You really need to budget a copious amount of time to evaluation. I would say at least 50% of one's time needs to go to evaluation in machine learning. And actually the big breakthroughs of the last 15 years in machine learning, I mean, actually really the last 30, 40 years, right, have all come from evaluations, right? So the MNIST data set, if people are old enough to remember that, right? The SWE-bench data set, which is now, well, I think at this point it's been saturated, but it's an index of AI coding agent performance. ImageNet, which was really the driving force behind the development of convolutional neural nets. We're going to do the same thing in security, and on any given team, right? Any time spent on evaluation isn't wasted because it allows you to actually index your own progress and actually iterate and improve. Okay, I'm done. Hopefully I was useful. Thanks, and would love questions and discussion.
Yeah, any questions for Josh? Actually, I have one, I guess more, maybe you say, hey, look at slide 7 for this one, feel free to but I think there's like a fundamental leap being made here, or assumption that I was curious what the grounding on, which is, well, you could imagine a textual gradient on improving the harness versus doing a regular gradient on improving the transformer, right? And so I believe evals, and I think that's the way forward, but I think there's this question of if you told me that improving the model will give us more efficiency, so I could run a smaller model at better performance per watt or tokens per watt, I would have believed you. But the leap that I'm not directly seeing is that there's we need it for quality of result. I'm wondering if you have any intuition of why we can't do textual gradients essentially, like in prompt engineering, context engineering, to are we at a point where the base reasoning models are improving enough and getting enough that we could just do the harnesses? Where for the quality, not performance, do we really need the better?
Yeah. So Leo, is basically what you're pushing on is why do we need, or maybe at what point do we need specialized fine-tuned models and security versus why can't we just elicit the behaviors that we want by optimizing in prompts?
Yeah, can't we just keep writing OpenAI and Anthropic? Where does that change from not a performance side but a quality side?
Yeah. I mean, okay, so I think you wouldn't disagree that probably take a problem like data loss prevention or something like that. I imagine you wouldn't disagree that it's highly unlikely that the logical end, many people right now are using Sonnet 4.6 to decide whether documents going out in email attachments are sensitive corporate IP, right? And like, I think you wouldn't disagree that that's probably not the logical end state to have like a 1 trillion parameter model doing that job, right? Like, so I think at a certain point, we're gonna, as we mature as an industry, we're probably gonna swap out these huge generalist models for more specialist models.
So in that one,
yeah.
if I was gonna,
yeah.
like what I would say is like, well, more important is to have the digital twin, so we have the context of the user, the organization, the document, and then as models keep shrinking, I'm not actually sure we need a generalized model. I would actually expect we could use even a dumber and smaller model.
So basically, the argument would be like, what you're gonna want is a small sort of generalist cognitive core that like does RAG, or you give it the right context and it can make generalized decisions. Yeah, I mean, it's possible, right? I think it's an empirical question. I guess my hunch is that, like, if you look at what I think that, like, if you look at what Anthropic and Cursor are doing, they have a flywheel with respect to customers using those models for coding, and they're sort of hill climbing that specific capability. And the knowledge is being baked into the parameters, right? Like that, you know what I'm talking. Cursor just reads like Composer 2 or whatever. This new fine-tuned model. So I think we'd have to. So I think, and I think that's what I think that's what Meta and Google and OpenAI are doing with respect to consumer chat use cases also, like the behaviors that they're getting out of those models. Like the sequences of like reasoning and tool calling they get to answer questions like find me the best restaurant in San Francisco, like after Leo's event, right? This kind of thing. I mean, I think that's being fine-tuned into the parameter space also. So yeah, I think I'm skeptical that, so it's possible it will go in the direction of some sort of general reasoning core that's, augmented by RAG, but that doesn't seem to be the direction we're going right now.
I guess when I could make that claim for the performance side. I know in the speed side, I would totally do it. But so the question is really the hard part for me is the quality that, But anyway, but yeah, I feel like I'm monopolizing the floor.
Yeah. I just want to say, but I think you're getting at a good question. That I mean, like one last thing I'll say is like, the performance concerns, like performance, throughput, latency, especially performance and throughput, but I think latency also eventually, I think these are like key design dimensions, like these are key product feature dimensions in security. Like in security, we probably want to get to a place where like 2% of the process tree deltas on all of your network are being reasoned about by an LLM. I mean, that would be a nice state to be in, right? And like, but to get there, we probably need 500 million parameter models, right, that are doing the heavy lifting there, or something like that. Anyways, that's all. This is where my intuition comes from around like the need for custom models.
We should talk more after.
Okay. Yeah.
I don't know for anyone else. There's it's really, we're lucky to have Josh and team here. So if you want to ask annoying questions like this.
I can always ask questions. Yeah, I guess I don't know where y'all are at as far as going to market. So I'm just curious from a customer point of view, what is it like to bring these capabilities into the sales processes, et cetera?
Yeah. We've only quit our jobs like 3 weeks ago, so we have so we don't have any customers yet. But yeah, maybe next year if we get invited back, we'll have a good answer. So yeah.
Okay.
Okay, cool.
So yeah, maybe time for one more, but Diana will be setting up. So otherwise, thank you.
Thanks.
I have like so many questions.
Okay, yeah, let's talk about it.
I should be sharing the screen already. But
yeah, excellent.
Let me double check. Are we good? Yeah, actually, let me make sure. So you're good?
Yep.
Okay, so yeah, our next speaker is hailing, I don't know if it's like technically Microsoft CISO's office or...
Yeah, it's the CISO, it's a CTO org within the CISO org,
yeah.
So
some folks may be familiar with CISO, and then deputy CISOs would be John Lambert, so of fame of Attackers Thinks in Graphs and Defenders Thinks in Lists. Diana, and last year at Graph the Planet, John gave a great talk of, I'd say, the vision of where things are going, but then somebody actually has to make it real. And so enter Diana.
Great intro, thank you, Leo. Hi, everyone. My name is Diana. Like Leo mentioned, I do security research and AI engineering work at Microsoft, so tons of different projects spanning from reinforcement learning on security telemetry to creating, kind of orchestrating red teaming agents, blue teaming agents, different types of security agents. My special niche is enabling these different agentic systems with different types of security knowledge graphs. Whether or not that's like posture graphs or activity graphs. So today I'm going to be sharing some new functions that we open sourced from my research org with Sauron and John Lambert. John, like Leo just mentioned, has this famous quote that's something along the lines of, attackers think in terms of graphs and defenders think in terms of lists. And because of that, attackers will always win. And so a lot of the core of these functions is the intent of these functions is trying to enable defenders to more easily create and think in terms of knowledge graphs, because it turns out creating knowledge graphs is not a super trivial thing to do. And so, this is Graph the Planet. I'm sure lots of members of the audience already know the power of the graph data structure to solve tons of different problems across different industries. But just quickly spinning off, knowledge graphs are super powerful. They help make implicit relationships explicit, which helps empower humans, but also AI systems. A lot of relationships that humans, whether or not they're aware of it, they have in their head. Sometimes making that explicit for AI systems can be pretty beneficial. There's tons of really fancy graph algorithms that you can run on top of knowledge graphs. GNN stuff. There's edge prediction. There's also tons of operators that you can only really there's tons of different types of questions that you can only really ask with graph operators that you can't really ask in the relational or tabular world. In the relational and tabular world, you're limited by where clauses and selects and projections and summarize bys. But maybe you want to ask questions that you can only really ask with graph operators like pathfinding or blast radius or node centrality and things of that nature. And so there's tons of graph applications already happening in security, as most people are really well aware of. There's posture graphs, there's attack graphs. This is kind of like your bloodhound type thing. Reverse engineers are using abstract syntax trees for research. The core of this presentation is really going over number 6, activity graphs, so knowledge graphs that are created from your security logs. Yeah, go for it. Oh no. Oh, sweet. Yeah. Thank you for fixing that. Thank you. Don't want to lose the remote, folks. All right, beautiful. Thank you. And this is really important because activity logs are how we see threat actors. Everything that we know about threat actors in Microsoft, we've learned through security logs. The way you know you're getting hacked is usually through security logs, and this is where a lot of SOC analysts are currently living in. So if we give a security analyst a posture graph or an abstract syntax tree, they don't really know what to do with it because they're lost in the weeds of security logs, and that's how they see the world. And so, one second. And so even in security logs, there's some graph nature to this. I think there's been some excellent presentations essentially covering this topic earlier today. But every single security log has a graph just waiting to be pulled outside of it. There's nodes, there's entities that have different relationships between them. I might look at a security log and see IP addresses that are requesting auth to particular users with particular passwords. And it turns out that there's multiple ways of modeling just one row of data. I might look at this sign-in log and see these relationships in this graph structure, but different analysts might look at it and see and pay closer attention to the device or the host name of this authentication log. And so even from analyst to analyst, or even like myself when I'm investigating things, sometimes when I look at some logs, I see certain relationships in certain entities versus other investigations, I might pay closer attention to the user agent, something of that nature. And so it turns out for security logs, there's a lot of kind of opinionated modeling. The modeling is a lot more flexible and manual and malleable. It's very hard to get one security knowledge graph modeling to rule them all with activity logs, especially because analysts are also really opinionated about how they see the world through their data. And we don't really want to make them change how they see that. And so historically, a lot of the work in terms of creating these activity graphs is kind of flown through, like, you start at your relational kind of tabular database that you already have. This is like your Custo, your SQL, like your log telemetry, and then you cook it and bake it through ETL pipelines and turn it into like into the knowledge graph data structure. And then you store that in a separate kind of copy, as a separate copy in a graph database. This is like your Neo4j, your Tinkerpop, your Custo graph, et cetera, et cetera. And there's really elegant ways of doing this to make this efficient, but it's very kind of resource intensive. You have to store a copy of every single network event, and it tends to get pretty expensive pretty quickly. And so for the purposes of this presentation, we're really only focused on making kind of temporal, ephemeral investigation graphs that have just the amount of data you are looking at for your investigation. So analysts and AI systems can spin up kind of temporal, ephemeral investigation graphs right kind of at the layer of the relational and data tables that already exist in your system. And we're trying to keep it as like granular at this level. So analysts can render these graphs from this layer, because it's really challenging to orient yourself around a graph that you didn't create yourself, that's been cooked and baked a bunch. Like analysts are super, they're very much experts at the relational and tabular world. They know that data and that schema in and out. Making them kind of process and understand a graph of data that's been cooked and relabeled and all of that stuff can be challenging, versus like keeping them at the layer of data that they're at and enabling them to have just the right functions and operators to kind of spin up graphs at that level. And so a lot of this presentation is going to be about kind of the KQL Custo world of security telemetry, if you're familiar at all with Azure, Microsoft kind of ecosystem. But these concepts can be applied to lots of other databases and query languages. So if you're not aware, there's this really cool tool that's free. It's a desktop application that's free for anyone to download. It's called Custo Explorer. It's a desktop app that has a lot more kind of features in terms of like query interface, like lots of different types of highlighting and conditional formatting and things of that nature. And they have this extra handy-dandy feature that enables you to kind of render and make graphs. And there are a few operators to make graphs out of your Custo data and query it. There's this whole like pop-up window that enables you to query the graph, have conditional formatting, have icons for nodes and things of that nature. And so it turns out that if you have data right now in a Sentinel Log Analytics workspace and you have the Defender XDR connectors into your Sentinel Log Analytics workspace, you can connect to the same data that you already have in Custo Explorer with the link at the bottom. The same data that you already have, you can view and query with this tool that's available out there for free and start making graphs with this operator. And so this is an example of MakeGraph, the main operator that's used to construct these knowledge graphs in Custo Explorer. Traditionally, it's super, super useful. Traditionally, you have to kind of manually mint nodes and edges with a bunch of let statements. So for each and every single node and edge type you have to have a let statement. And this enables you to make knowledge graphs pretty quickly for smaller, more simple knowledge graphs. But as soon as your graphs get more complex, as soon as you want to change your model, I mentioned earlier that a lot of security activity graphs, you might want more kind of malleable modeling. As soon as you want to change up your model, you have to rewrite all of your let statements. And this gets super cumbersome and tedious. I've written make graphs statements that are like hundreds of lines long. And this is not really a priority for SOC analysts or investigators. They're already knees deep, knees in the weeds, trying to investigate tons of different alerts and investigate all these different threat actors. They're not really willing to spend the time to break out to just make a graph with this really long KQL statement. And so to tackle this problem, we've made a few more generic Custo functions that wrap some of the complexities and the redundancies of MakeGraph. So essentially, given the results of any KQL query that you already have now, and a JSON mapping of the node and edge types that you have and the columns that represent those node and edge types, you immediately have a knowledge graph representation of that same query result. And so that's lift to graph. And then graph render view actually renders your graph. And so This JSON object is something that you can save off on your cluster, your database in Kusto, so you can reuse them. And so this is an example of one of them. There's node types and there are edge types, and those are the key and the props are the columns that map to the unique identifier of your node and edge types and the properties on those node and edge types. And then you can also define icons to be your nodes as well in your graph, so it's a lot easier to orient yourself around the graph by using visual cues that match what you're already familiar with in whatever data world you're in. So for example, we use the official Azure icons as node types, so folks can easily orient themselves in the data that's being represented in their graph. And so we've open sourced, we've released on GitHub a few of these functions that we've created. Lift to graph, like I mentioned previously, takes in the output of a KQL query that you already have in the JSON mapping for that same KQL query. It transforms it into a table of nodes and edges, but it does not actually render or call make graph just yet, because you might want to do a few other operators and transform that table of nodes and edges in different ways. And one of those ways could be this thing we call graph fold. And what this does is it essentially collapses common nodes that have the same property value of the same entity type into one Uber node. So an example is if you have like a bunch of IP address nodes scattered across your graph and you want to see, okay, what are all the IP addresses of like X carrier, like the Amazon incorporated carrier doing? You can collapse it into kind of one Uber big node and all the edges will rewire. This is kind of a similar view as like as group by in KQL, if anyone's familiar. And then graph render view at the end actually renders your graph. But you can imagine a bunch of other Kusto functions that do other operators to your graph that could enrich your nodes with different data sets that are in different tables and can kind of transform your graph in different ways while you're investigating. And so for the purposes of this demo, we're really showcasing the KC7 data set. This is a super awesome project for folks to learn more about, security logs and how to query and find and investigate different threat actors in your environment. So synthetic open source data set, and it's been super, super useful for the purposes of our open sourcing these functions. And so this on the screen is kind of a run through. This is Kusto Explorer, the tool that I mentioned previously. On the left here, we have the KC7 open source data sets, and this is an example of one of the liftographs that we have. As you can see, instead of like hundreds of lines of KQL manually minting all these nodes and edges, it's just a few function calls. You have your mapping JSON, which again, you can store off on the cluster and call as a function. And then we call that KQL query, we call lift to graph with the JSON mapping and graph render view. And now just with a few lines of Kusto, of KQL, you have this kind of graph authentication event graph spun up. And so this can enable analysts to make these graphs a lot easier at the language that they're already familiar with the data sets that they already know, with this tool that's already free and available for anyone to download. And just at a glance, you can kind of start to investigate this data and see the different kind of structures and shapes that stand out to you. For example, these smaller subgraphs are benign sign-in events, but there's this kind of giant, huge network in the middle that's kind of the interesting bit for this particular KC7 investigation game. And you can interact and see the properties of these nodes. You can query on the right. This is a different graph that we have. This is just a take 400 of email events. And again, just with a few function calls, you have this graph constructed for you of different email messages being sent between different email addresses. And then in Kusto, just like how you can union tables of data, you can also union graphs together. The same, like again, they're just at the end of the day, tables of nodes and edges. And so what you can do is that if two nodes have the same unique identifier, make graph will just pick one of the two nodes randomly, and we have a function to dedupe within lift to graph dedupe the two nodes and bag up all the properties so you don't lose any. And so now you can start investigating and poking around the union kind of union graph. So you can imagine, like, if you have a bunch of hunting queries that you have, or a dashboard of hunting queries that you usually run when you're investigating, you can kind of have your mappings created, union them together, and start to have an investigation graph that then you can do things like graph fold by property, which I mentioned earlier. So the email messages have labels as to whether or not they're blocked or suspicious or clean. And so here we're folding the email message nodes by their verdict. And in Kusto Explorer, you can define the size of your nodes to be by a particular parameter. Here, we're defining it to be by how many nodes are folded to create the Uber nodes. And here, this one stands out. These are all the email messages that were labeled as clean. So there's 100. We keep all of the folded nodes defined as one of the properties on this Uber node. And then you can run graph queries. Here on the right, we ran a graph match on looking at paths that are like 3 hops away from these different folded nodes. So here we can start to threat hunt and see, or investigate and see, okay, what sign-ins to users around this time led to them receiving some or sending some email that was blocked within their organization. And this is pretty relevant for this particular KC7 game. And so these are the sorts of graphs that we can construct by just making a few simple Kusto functions that wrap some of the complexities of MakeGraph that really uses this free tool that already exists from data sets that analysts are already familiar with and a language they're already familiar with. And so, one of the key takeaways that I have from this experience is like, there's, with AI and code-gen agents, there's this huge like hype to build everything and build new solutions to fix every single problem. And when I was first kind of tackling this problem and thinking about it, I was like, okay, I need to build like 50 different data connector, ETL pipelines, and spin up these graph databases and load up these things. But we've been able to find a lot of impact and get actually a lot of analyst usage of these graphs by just meeting analysts where they are and the query language they're already familiar with over the data sets they're already familiar with. And it's a lot easier, like I mentioned previously, to orient yourself on a graph of data that you've created yourself on a schema that you're already familiar with. And so that's all I had for today. Thank you so much for your time. Does anyone have any questions?
Well, first of all, maybe I can kick it off. Also, I could turn on the microphone. Testing. I don't know if I'm on. Okay, great. Oh, there we go. Yeah, I'm wondering, like, when you're working with the analyst teams, like, I found that often, some people are already trying to do graph stuff and like they're happy to like, oh great, this just makes it a lot easier. And like, that's our favorite case, right? But sometimes there's other people who haven't been doing this stuff. And so as you've been like, I hear what you're saying about meeting them halfway of like, okay, they're already doing Kusto, or let's just and maybe the initial language is weird. Let's make it a little easier. But like, do you feel like there's like any patterns you've seen of like what makes the ahas like, oh, there's a certain kind of graph or certain kind of use case or anything that you've noticed makes it easier?
Yeah, totally. I think showing graphs, I mentioned previously that the graph data structure enables you to ask questions because of the specific operators that you can only apply to knowledge graphs. So showing examples in which, hey, this query would have been like 100 lines long in KQL, and you would have to do like 5 joins and like crunch all this data. This is an example of that same question being answered as like a graph query instead, and look at how much simpler it was to write. So stuff like that of just showing them like how much easier certain parts of their jobs will be if they answer these questions in terms of graphs instead.
Do we have any other questions for our speaker?
Cool.
I've looked some at the KC7 data, and I was curious what other data sets, public data sets, are out there that you recommend that you guys are using or presenting on. If there's other good cyber ones. I mean, the Sentinel graph is about to. That's also kind of a. It's going public this week, right?
Yeah, Sentinel graph, they got tons of cool features coming out. I think they're releasing this week. In terms of the public synthetic data sets, KC7's the main one that I've interacted with, but we just had a whole awesome presentation today on the other data sets too that aren't just Azure or Microsoft specific. So there's tons out there.
Well, maybe flipping around, which one would you like to see? If there's any, like, oh wow, I'd love to have a data set like this, because
multi-tenant data sets would be interesting. I don't know. I'm coming out from Microsoft where we have tons and tons and tons of tenants. So like lateral movement across tenants is something that we're really interested in, and something that I haven't seen a lot of synthetic data sets really focus on, but that might just be a big corporation problem of having tons of tenants and less of, yeah, so. Cool.
Cool, yeah, so she'll be around after if you have more questions. So yeah, thank you for your time.
Thank you.
Do we have David Cass somewhere? He did make it here. Yeah, let's maybe give it 5 minutes while we get the last speaker situated. Are we good? Okay, so our final speaker of the day is going to be pretty interesting. David I think might be winning in affiliation count. So day job, pay the bills, CISO, KeyRock. I think you're going to be hearing about that. Faculty over at Harvard, and then president of CISOs Connect. And you just gave me a flabbergasting number of CISOs when you said that.
Yeah, we have about 1,600 member CISOs. So.
Yeah, so this will be interesting.
All right, so I think I have, about 20 minutes, or?
You have 25.
Okay, perfect. All right. Happy to join you guys today. I'm a former regulator, so this is going to be a little bit from the regulatory perspective as well. So before I joined the dark side, I went over to crypto. I was one of the regulators for the 8 largest banks in the world for pretty much all things cyber and IT risk. So we're going to approach it from very much a regulatory perspective. So back in 2023, I published, I think while I was still a regulator, I published an article for Forbes on 10 things that you should kind of take into consideration if you're a regulated institution and you're using AI and ML at the time. That didn't even take into account where we are with generative AI today, let alone Agentic AI. So we're going to kind of build from that point of view. So from a regulatory point of view, we always start with the construct of safety and soundness. So we'll go through what the core concepts of that are and why it matters, especially if you're a regulated institution or plan on being a regulated institution. We'll look about the evolving threat landscape, which is different depending upon whether you're using generative AI versus agentic AI. We'll talk about some, I guess, unique challenges for agentic AI, and then we'll really talk about the other fundamental underpinning of this, or the foundation is going to be, really, do you have a good governance framework to help you manage through all of this? And by a governance framework, I don't mean what banks have traditionally done, where when you talk about model risk management, somebody gives you the Excel spreadsheet list of all the models that they think they have running. I mean actually real governance around it. We'll talk a little bit about the regulatory landscape as well as some of the emerging landscape, and we'll talk about just the CISO's view from some of the things that I've learned by actually having some of this stuff already deployed in the field. All right, again, this is just the key takeaway from this slide is really looking at it from, when in 2023, when I wrote that first article, it was really about voluntary guidance, from that perspective. Now it's really moving to enforceable law. When you look at what's going on in Europe, when you look at what's coming here, so you really need to move from treating this as, a nice to have, as something that you actually have to do, because you're going to face real compliance issues depending upon whether you're a global organization. All right. So as a regulator, safety and soundness essentially apply very well to anything AI and ML. So when you start thinking about safety and soundness, they're not the exact same thing, but it's, two pieces of the same puzzle, essentially. So you look at, when we talk about, safety, we're talking about the ability of a system to operate without causing harm. So by harm, we mean through a system malfunction,